Hello everyone, welcome to ISTQB Agile Tester Extension Certification Training from Software Testing Mentor and RCV Academy. This is comprehensive course for ISTQB Agile Tester Extension Certification. So if you are a fresher or you are a person who is working into the software testing industry and want to get certified as ISTQB Agile Tester, this course has everything that you need to become a certified ISTQB Agile Tester. I have covered the whole syllabus that is relevant for ISTQB Agile Tester Certification. So all the topics that have been covered in this particular course are from the syllabus. So there is nothing that has been missed out. The whole course will give you a good understanding of the syllabus topics that have been mentioned in the ISTQB Agile Tester Certification. In terms of the course contents, we will start with the course introduction, then we'll understand what are the agile software development fundamentals, then we'll proceed further and we'll understand about the agile approaches. What is the difference between the agile and traditional development approach, right? Then we'll understand about the status of testing in agile projects, and all these topics that you see are directly correlated with the syllabus that is there from the official ISTQB Agile Tester Certification. Then we'll go ahead and understand about the managing regression risks in agile projects. What are the concepts that are required in order to manage the regression risk within the agile projects? Like in waterfall approaches or previous development approaches, we used to manage regression risks differently, but in agile, how we can manage regression risks in agile. So all that will be covered in this particular section. We'll understand about the role of the testers in the project. We'll understand about the agile testing methods, then the assessing the quality risks and estimating the test effort, how you estimate the test effort within agile projects, right? So all of that will be covered in this particular section. We'll understand about the techniques in the agile projects, the test techniques. We'll understand about the tools that are used in agile projects and how the agile testing is basically done in the actual industry. So it will give you a good idea, not only just the theory concept to pass the exam, but also how overall tools are used, how the roles are, what responsibilities are there for the people within the agile project, with the testers within the agile project. So these are some of the key topics that are taken up from the ISTQB Agile Tester syllabus, and this course is made to help you to understand all those concepts and pass your exam with ease. So go ahead and enroll in this particular course and start learning and get ISTQB Agile Tester Certification. This is very valued certification in the software testing industry. So you will get a good knowledge along with that. If you go ahead and do the certification, I'll be putting all the information required for the certification where you can go ahead and take the certification. Once you take the certification, you will have a lot of value add in your resume and your profile. So go ahead and enroll in the course. Happy learning. Thank you. Hi, welcome to ISTQB Agile Tester Certification course. In this course, you will learn about all the ISTQB Agile Tester Certification syllabus topics in detail, which will help you to pass your certification with ease. My name is Manish and I'll be your instructor for this course. I have more than 14 years experience in software testing, test automation, test management, and agile methodologies. I am ISTQB certified test manager, professional scrum master, and scaled agile practitioner. This course is a comprehensive course and covers all the aspects of ISTQB Agile Tester Certification exam. At the end of this course, you will be well prepared to appear for your ISTQB Agile Tester Extension Certification. Feel free to look at the course description, and I look forward to see you in the class. Introduction to Agile Software Development. Agile software development evolved in order to overcome the limitations that we used to have in the older development methodologies like waterfall and V-model. In the year 2001, the group of individuals who were representing the lightweight development methodologies at that time, they came together to see what are the common themes across all those development methodologies. Now, by the end of their meeting, they agreed to the common set of values and principles, and those principles and values later became the Agile Manifesto, or Manifesto for Agile Software Development. Now let's see what are some of the key points of Agile software development. Agile software development is a lightweight software development methodology. Agile follows 2 to 4 weeks iterations, or 2 to 4 week cycle, and after each iteration, Agile team delivers the working code as compared to the waterfall and V development methodologies, wherein the delivery of the code was after very long duration, like 3 to 6 months, or sometimes even a year. Requirements and solutions evolve through collaborative effort. So in Agile, the requirement and solution evolve by the collaborative effort of the whole team, as compared to waterfall development methodology, wherein there was a dedicated team working on the requirement, dedicated team working on the design, and then development test. So they were all different teams working on only a specific set of tasks. In Agile, it's a collaborative effort within the team, and the whole team works towards a common goal to deliver a common goal or common set of understanding what each person has within the team, so that everyone is on the same page, and at the end, the product that is delivered is basically what is expected by the stakeholder or by the customer. In Agile, teams are cross-functional. Now, the team in Agile is a mix of business people, developers, architects, automation testers. So all these people come together and work in a collaborative manner. So cross-functional teams make an Agile team. In Agile, there is always a focus on continuous improvement. Since there are 2 to 4 weeks iterations, there is a working code delivered after each iteration, and then how the team performed within that iteration, that is being discussed in the retrospective meeting after that iteration. And in that retrospective meeting, they discuss what went very well for that particular iteration. Were they able to deliver the points they discussed, or they committed? Was there good collaboration, or what improvement could be made so that future iterations are much better as compared to the previous one? So there is a focus on continuous improvement always in Agile development. Now the last point is Agile encourages rapid response to a change. Since there is a working code or working software showcased after each iteration, now the stakeholders and the team who is watching the demo, or then they are seeing the working code, they provide their feedback. What is working pretty well, and what is, like as per the expectation. If there isn't something which is not as per the expectation, those feedback are recorded, prioritized, and then the team can work on those changes in future iterations. So Agile encourages rapid response to change as well. So these are some of the key points of Agile software development methodology. Agile Manifesto. In this tutorial, let's understand what an Agile Manifesto is. So Agile Manifesto is the common set of values and principles that the team or group of individuals who were working on the lightweight software development methodologies came together in 2001 and set those values and principles. So those common set of values and principles became Agile Manifesto, or Manifesto for Agile Software Development. Now this Agile Manifesto contains 4 statements of values. Let's see what those 4 statements of values are. So the first statement of value is individuals and interactions over processes and tools. Second one is working software over comprehensive documentation. Third one is customer collaboration over contract negotiation. And fourth is responding to change over following a plan. So these are the 4 key statement of values for Agile Manifesto. Now, what individuals and interactions means over processes and tools? So the manifesto, Agile Manifesto, says that individuals and interactions between the individuals and teams is more important and is going to give more value rather than over reliance on processes and tools. And when what this means is that Agile doesn't discard the usage of processes and tools completely, but over reliance on processes and tools is not recommended in Agile development methodology. Now, working software is much more beneficial as compared to comprehensive documentation. So if you have something working software to demo, a person who is looking at the working software is more likely to understand more as compared to just reading the documentation around that functionality. Customer collaboration is more important and more valued in agile development as compared to just negotiating over the contracts. Similarly, responding to change is more important rather than just following the plan. So if there is any feedback from customer and you incorporate that feedback and give the value, that's more important and more valuable to the customer as compared to just following the plan as it used to be in the older development methodologies. So these are the 4 key values. We'll discuss all these key values one by one in upcoming tutorials. Manifesto value: individuals and interactions over processes and tools. Agile development argues that there are benefits that can be derived from good tools and processes. However, the core of the team or core of the agile development who produce the software is the people. So interaction among the people or within the team is more important as compared to the over-reliance on the processes and tools. So there will be benefits from following the processes, but over-reliance on the tools and processes hampers the progress of the team and delivery. So let's see what this value talks about. So communication is given more priority over tools and processes. So as part of this value, what Agile Manifesto says is that communication within the team members is more important and given more priority over just following the tools and processes. So for example, if you're having issues or if you're blocked with something and you communicate with the person who can actually resolve that issue, that is more helpful rather than logging a ticket and then following the whole process of resolving that ticket and then going back and forth. So communication is given a higher priority or more priority over just following the tools and processes. The second point is over-reliance on tools and processes creates rigidity. Now, if your team is relying on the tools and processes a lot, then there is rigidity to the change. So if there is any change required, then it becomes really difficult to cope up with the change because the team has to follow the whole process of getting all the approval, raising the ticket, etc. to come up with the solution or come up with the resolution of the blocker that they have. So communication is the key, but relying on the tool up to some extent is good, but not over reliance on the tools and processes. Now next step is team interacts early and frequently to resolve issues. Now agile team interacts on daily basis. They interact with each other on any issue that comes within the team so that the issues get resolved easily and quickly rather than following the whole process of raising tickets and looking for resolution of those tickets. So team interaction, early team interaction and frequent team interaction is given more priority in Agile. And Agile development is people-centered because people or the team members in Agile are the one who deliver or develop the working code and software and not the tools and processes in the team. So Agile development is more people-central and communication within that team member and people is given more important. Agile Manifesto Value 2: Working software over comprehensive documentation. Working software is more useful for customers as compared to the comprehensive documentation that teams used to provide if they used to follow waterfall and V-development methodologies. Now, since Agile has shorter iterations of 2 to 4 weeks, and there is a working software or working code delivered after each iteration in Agile, so that working software is much more valuable for the customer rather than he going through all 1,000 pages of the documentation and understanding what the team is going to build 6 months down the line. The second advantage is that working software provides opportunity for rapid feedback. Now, because working software is available pretty early in the life cycle or after each iteration, there is some working code available to the customer. This provides the opportunity to customer or stakeholder to provide feedback after each iteration, which can then be implemented or which is utilized by the team, or team prioritizes that feedback and can incorporate those changes in the upcoming iterations. The third benefit is that working software delivers business value much earlier in the life cycle. Because there are shorter iterations in Agile, the business value is delivered much earlier in the whole development life cycle. The next advantage is time to market advantage. Because the working software is available pretty early in the life cycle, the team or the customer can decide to launch a software with limited functionalities early and have the time to market advantage. So these are some of the key benefits of working software over comprehensive documentation. Agile Manifesto Value 3: Customer collaboration over contract negotiation. So in this value, customer collaboration is given more importance as compared to the contract negotiation. So collaborating closely with the customer on a regular basis is more important as compared to just negotiating over the contracts. Why is this important? We'll discuss in the next slide. The reason why customer collaboration is important because elaborating the whole requirements during the initial phases of development is very difficult. As we have seen these shortfalls in the older development methodologies like waterfall and V model, there was a requirement gathering phase altogether, and that was the only phase wherein the customer was supposed to provide all the requirements for the whole project, which could be like for 6 months, 1 year worth of work. And to gather all that requirement detail was really difficult for the customer to get what he wants upfront and document everything in the requirement. And that was the whole reason that most of the projects have these issues of having lots of change requests, because the end product was not as per the expectation of the customer. So elaborating whole requirements during initial phases was really difficult in the older development methodologies. And that is why Agile says that customer collaboration is much more important as compared to negotiating just over the contracts. The second thing is around that requirements are better understood with direct collaboration with customer. Now, rather than having a dedicated requirement gathering phase wherein the customer or the requirements team just goes in and gathers all the requirement from the end users or from other customers, requirements will be better understood only if you have direct collaboration with the person who will be using that software, or the team or the customer who is actually providing, who's actually looking for that particular solution. So the more you discuss, the more you collaborate with the customer, you will understand those requirements in a better way. So that's the second reason why the customer collaboration is more important rather than having the requirements gathering phase and customer providing all the requirements in silo, gathering all the requirements and then providing those as part of the requirements document. And then we manage all that delivery through the contracts. The next benefit is that close collaboration is likely to bring more success to project. Now, because you're collaborating closely with the customer on regular basis, this is going to bring more success to the project rather than having the requirements phase and then those requirements passed on to the next team, and then they're building the software based on those requirements. So they are not basically cross-checking or validating with the customer on regular basis that whatever they are building is actually what is required by the customer. So customer knows this only after the end product is delivered, and then whether that fulfills his needs or is fit for use, he knows only after the delivery of the software. So in Agile, because there are short iterations and close collaboration with the customer, so he knows what is being built in those short iterations and whether that is fit for use and is as per expectation of the customer. Agile Manifesto Value 4: Responding to change over following a plan. Now, in this value, we will discuss what is more important, whether it's responding to change or just following a plan. So Agile Manifesto says, or Agile Manifesto value responding to change or following the plan says that it is more important to respond to a change required by the customer rather than just following the rigid plan that we used to follow in the older development methodologies. Now, why is this important? Why is responding to change important as compared to following a plan? So the first thing is that projects keep changing due to various factors, and those factors can be business operations or how the other business players are performing in the market. It could be that, it could be legislation, it could be competitor activity, technology advances, etc. So because of all these factors, projects keep changing. And due to changes in the market, there might be a need that whatever was discussed or whatever was a requirement today might not be valid 6 months down the line. And that is the key reason that in this volatile environment nowadays, with so much technological advances, that it is very important that projects should be able to accommodate change rapidly. So responding to change is very important rather than just rigidly following the plans. The second point is rigid plans and processes do not help the customer. Now, because of these technological advances or the factors that might impact the changes in the project, if we start following a rigid plan as we used to follow in older development methodologies, then you will end up, after 1 year down the line, you will end up creating a product which might not be required anymore in the market, or the market demand has changed. And that is the whole reason that rigid plans are no more acceptable or no more helpful to the customer. So customer basically wants to analyze the market need, and then based on those market needs, the development team should be able to accommodate or respond to the changes that are required by the customer, not just rigidly following the plans and processes. Rigid plans and processes do not help the customer. The next point is that development should be quickly able to adapt to changes. Now, because of all these volatile changes or volatile market conditions and technological advances, business or competitor activity, the development team should be able to accommodate any changes required due to these factors by the customer. So if a customer comes or does a market research 2 months down the line when the project started, and he comes up with some new features, the team should be able to accommodate those new features, as well as if there are some changes to the existing feature as per the market demand, they should be able to accommodate those changes quickly in the development life cycle. Now, because software projects change due to like many internal and external factors, development team should quickly adapt to those changes, and agile teams are expected to anticipate and welcome change throughout the development life cycle. So that is why responding to change is the key to agile software development. Agile Manifesto principles. In Agile, there are 12 Agile Manifesto principles. Let us go through these principles one by one and understand them in detail. Now, the first principle says, satisfy customers through early and continuous delivery of the software. Now, this is the customer satisfaction is the key in agile software development. And in order to satisfy customer, it is very important that the software is delivered to him early in the life cycle, and continuous delivery of that software in regular iteration, so that customer can have a look at the working software and see whether it is fit for use and meets his expectation. Now, because in agile, software is built incrementally and regular feedback is obtained by the customer during software development, and these small iterations of 2 to 4 weeks are very helpful to provide the customer with a working software and get an early feedback. Now the second principle is welcome changing requirements even late in the development cycle. Now changes are inevitable in today's landscape. I mean, internal and external factors, competitor analysis, or how the competitors are behaving in the market, what they are launching. There could be like legislation or laws or technological advances. There are many factors due to which changes might be required in the project. Now, agile development should welcome any changing requirements even if it is late in the development cycle. The third principle says frequent delivery of software. Now, because agile development says that that software should be delivered in shorter iterations of 2 to 4 week cycle. Now, because of that, the frequent delivery of the software after each of these iterations is very important and helpful for the customer to provide early and frequent feedback. Fourth principle says daily collaboration among business people and development team. So daily collaboration is very important with the business team and development team, because understanding what exactly customer is looking for and what development team is building, everyone should be on the same page, and development team should talk to the business people on regular basis to understand what their expectations are and whether whatever they are building is as per their expectation, to cater for any last moment surprises. Another principle says build project around motivated individuals, provide support and trust team. Now in agile development, it is the team members of development team who deliver the software, and agile team should be built with skilled and motivated team member. Once the team is formed, they should be given decision making power in order to come up with the best possible solution. So there shouldn't be micromanagement sort of stuff going on in agile teams. People should be hiring the right set of people and motivated individuals who can take ownership, communicate regularly to find what is required by the customer, and then share ideas within the team to come up with the best possible solution. So building a project around motivated individuals is another key principle of agile development. Another principle says face-to-face conversation and collaboration is very important. So co-location is another agile principle of agile manifesto. When teams are co-located, there is a lot of face-to-face conversation and collaboration becomes really easy. Collaboration within each team member on a regular basis is easily possible only if the teams are co-located, and face-to-face conversation makes a lot of things clear and everyone is on the same page. Another principle says working software is the primary measure of progress. Now, delivering the working software is the primary measure of progress in agile software development, because that's the key thing that the customer is looking for, not the 100 pages of design document, because that design document is not going to be released in the market and customer or end user is not going to benefit anything out of that design document. So the key focus or primary measure of progress is the working software. And in SCRUM methodology, the showcase is done at the end of every sprint or the iteration, which is 2 to 4 week cycle, and the team delivers a working software after each of these iterations. So that working software is very important and primary measure of progress in agile development. The next principle says agile processes promote sustainable development and teams should be able to maintain a constant pace. So agile development promotes a sustainable development pace, and this pace and team deliver working software with this pace in each iteration. So basically agile teams provide the software, or basically they build incremental software in each iteration, and they maintain their velocity of the amount of work that will be delivered in each iteration of the agile development. The next principle says attention to technical excellence and good design enhances agility. So as agile software development comprise of motivated individuals, they come up with the best skills and right solutions which can accommodate any changes if required. This ensures that team can maintain the pace and sustain changes if required. Now, because the team is motivated and team
team do a lot of communication, come up with the best solution. So if there are any changes required, they can accommodate those changes without impacting the whole design. The next principle is simplicity. The art of maximizing the amount of work not done is essential. So agile processes also advocate simplicity to any delivery. Develop just enough to get the job done in a simple way. Agile team focus on essential things which create value to customer and not on distractors or unnecessary lengthy documentation which won't be of much value to the customer or end user. So simplicity is another principle of agile software development. Another principle is self-organizing team produce great products. Agile software development teams should be built by hiring skilled and motivated team members. These team members are self-organizing teams and self-organizing team members who know what they are supposed to do and take ownership. These team members communicate regularly and produce the results that are expected by the stakeholders. Because there is a close collaboration and everyone in team is on same page and know the goal they are working towards, these members of the team, they self-organize and work towards that common goal to deliver that product or that value to the end user. The next principle says retrospectives conducted regularly to analyze how to become more effective. Now, agile teams gather at regular intervals, which is after each iteration, when they showcase the working product, which is 2 to 4 weeks cycle. They have these retrospective meetings to discuss what worked very well, what didn't work very well in that last iteration, and what they can improve in the upcoming iterations. So these are the 12 principles, or the 12 Agile Manifesto principles. Whole team approach. One of the biggest differences in agile and traditional development approaches is the whole team approach. Now, what is a whole team approach? In whole team approach, there are some key factors that Agile Manifesto outlines, and with whole team approach, the first point to note is that quality is everyone's responsibility in the team. It's not about having the quality as a responsibility of the testing team or just the developers. So it's basically responsibility of each and every member of the team, be it the development team member or business stakeholder or customer. It's basically a closed collaborated team. So quality is responsibility of each and every member in the team. It's not any particular team's responsibility. Now, the second point says development team, business stakeholders and customers work together. So agile teams are formed by hiring the right set of people and who are self-motivated, self-starter, and work towards the common goal. So you hire the right set of people in the development team, business stakeholders and customers. They all come together and know the goal towards which they are working for, and everyone self-organize and work towards that common goal. Next thing is co-located team. Co-located teams are also very important in Agile because co-location facilitates communication and interaction. Now, if the teams are co-located, there will be a lot of communication. If there are any doubts to any team member, they can approach to the other team members and clarify those doubts and ensure that everyone is on same page and working towards that particular common goal. Daily stand-up meetings is another very important thing in Agile approach and whole team approach as well. So daily stand-up meetings are organized in whole team approach, wherein these stand-up meetings are very short, 15 minutes meeting every day, wherein the team comes together and mentions what they were working yesterday, what they are working today, and if there are any particular blockers that can be resolved by the team members if any other member can help and resolve those issues. So these daily stand-ups are also very important. Now, the other point in whole team approach is that co-location enhances collaboration and communication. Because the teams are self-organized and co-located, this enhances collaboration and communication within the team members a lot. And because of this collaboration and communication, everyone understands what they are working towards, and there is a transparency within the team, and everyone knows the goal towards which they are working for. Agile teams are also relatively very small team. The team should not be more than it should be 3 to 9 people, not more than 9 people, because the small teams can organize very well. They can communicate and collaborate and know the goal towards which they are working for. If the teams are very big, then this communication and collaboration within the big teams is very difficult and not fruitful. So these are some of the key points for whole team approach. Benefits of whole team approach. Let us discuss some of the key benefits of whole team approach in agile development. So the first benefit of whole team approach is that it enhances collaboration and communication within team. As Agile mentions that co-location is strongly recommended in Agile, and because of the co-location of team, everyone in team basically collaborates and communicates with each other on a regular basis. So it's daily that team collaborates and communicates to clarify any doubts if they have. Then the second benefit is that project benefits with the different set of skills in the team. Because Agile teams are built around self-motivated individuals and cross-skilled people. There are people from different business units, like people from business, and the development team comprises of architects, developers, testers, etc. And also the customers involved closely in the team. So because of all these different set of skills in the team are available, the whole team benefits with the different set of skills available within the team, and everyone works towards one common goal. And due to this cross-skilling, everyone in the team benefits with the different skills available within the team. The other benefit is that whole team takes care of the quality. Quality is everyone's responsibility in the whole team approach. And the essence of whole team approach lies in the testers, developers, and business representatives working together at every step in the development lifecycle. They work closely and ensure that the desired quality levels are achieved. So everyone ensures that the quality levels are achieved, whatever was desired. What this includes is, it includes supporting and collaborating with business representatives to help them create suitable acceptance tests, and then this also includes working with developers to agree on the testing strategy and deciding the test automation. And then development team also helps in finalizing the automation approaches and the scripts and the ways to do the effective automation and testing within the team. So because of all this collaboration, communication, and cross skill present in the team, quality is taken care by everyone in the team, and everyone, all the members help each other to ensure that the desired quality levels are met. The next point is that business representatives are involved throughout the development lifecycle. Now, business representatives or customers are involved throughout the development lifecycle to ensure that the whole team understands what the customer or business representative is looking for to be delivered, or what is the common goal towards which the whole team is working for. Knowledge sharing. The next point is knowledge sharing among the team, because there are different set of skills present in the team, and team collaborate and communicate regularly. So there is a lot of knowledge sharing happening within the team. Developers help testers in many automation activities and frameworks, and setting up some of the complex frameworks for automation, and then also helping out if there are certain issues in scripting, etc. So the developers or the person who knows that particular skill set or skill helps other team members to ramp up and develop that skill. Now the next point is that whole team takes part in analysis and estimation, known as power of 3, which is business analysts, testers, and developers. So all these members of the team work together in order to analyze what the requirements are or what the user stories are, and in order to estimate the amount of work required to deliver those user stories in the form of working software. So these are some of the key benefits of whole team approach. Early and frequent feedback. In Agile, there are short iterations and team demonstrates working software after each iteration. In contrast to the old development methodologies, Agile has short iterations, and after each iteration, the team demonstrates the working software to the stakeholders or the customers. And because of these demonstrations or showcases, the early and frequent feedback is received by the business or the customers. In old development methodologies like waterfall and V model, customer didn't used to get the product by until end of the project or until end of the development life cycle. And due to that, this frequent feedback was not possible in those approaches, and that was the big issue in the old development approaches. Because the customer used to get software in the end of the life cycle, if there were any changes required, those need to come in the form of change requests. While in Agile, these feedback are obtained after each showcase, and the development team can prioritize those feedback based on the risk factor or time to market advantage, and then work on those feedback to deliver those points or features in the upcoming iterations. Now let us see some of the key benefits of early and frequent feedback in Agile. The first benefit is that it avoids requirements misunderstanding. Now, because the iterations are very short, of 2 to 4 week cycle, the customer sees the working software and he can provide the feedback whether that particular software is fit for his use or it meets his expectation. And if there are some deviations or changes required in that particular software or the feature, then those can be easily incorporated in the upcoming iterations. The second benefit is that software is available early to customer, because each iteration builds the software incrementally. After each iteration, the software is available early to the customer, which can be released to the market even with limited functionality and provides huge time to market advantage. The third benefit is that team knows what is the priority for the business. Now, because there is a constant communication with the business people on a regular basis or daily basis, team knows what is the priority for the business, and based on that priority, team works and delivers those priorities to the business. The fourth benefit is that quality issues are resolved in early phases. Now, because of the early and frequent feedback, if there are any quality issues or the software is not working as per the expectation of the customer, these issues are resolved early in the iteration and any defect fixes are done early in the life cycle. The fifth benefit is that it helps better team management. So because Agile teams are small teams of 3 to 9 people, and because of those short teams or small teams, this feedback helps in better team management. The last point is that it promotes consistent project velocity. Due to this early feedback, consistent project velocity is maintained. Teams are self-organized and self-motivated. They know what they are going to deliver in the upcoming iterations. So these are some of the key benefits of early and frequent feedback in Agile development. Agile software development approaches. In this tutorial, I'm going to talk about aspects of agile approaches and agile software development approaches. So there are several agile development approaches. However, all these agile approaches implement agile manifesto values in different way. So some of the very commonly known agile development approaches are extreme programming, SCRUM, and Kanban. And all these approaches implement agile manifesto values in different ways. So they share the common manifesto values, but the implementation within these agile approaches is different. Now, the key philosophy or the common philosophy shared between all these agile approaches is collaborative user story creation, retrospectives, continuous integration, planning for the whole release, as well as planning for the iterations or the cycles within the agile software development. So in any of the agile software development practice or approach, there is a lot of collaboration within the team. Team members talk a lot about any of the doubts or clarification required for any of the feature or any of the work that is being done within the team. Because in Agile, the responsibility of quality and delivery lies within the whole team. It's not a responsibility of the small silo of the team or the sections of the team as it used to be in previous development methodologies. So there is a lot of communication and collaboration to plan the work within the iteration and within the release. And then once that planning happens, there is communication and collaboration to work around or to figure out the amount of work required and what needs to be done to deliver that piece of work after the iteration as well as after the release or the planned release. Now, all of these approaches implement agile manifesto values in different ways. So for example, extreme programming implements these manifesto values in different ways, SCRUM in some different ways, and Kanban in different ways, but the underlying values are still same. So they share, all of them share still the same agile manifesto values. Now for ISTQB certification, Agile Tester Certification, the key three key approaches that I'll be discussing is extreme programming, SCRUM, and Kanban. Now these agile methods are not exclusive. Extreme programming offers an efficient and effective approach to software development. SCRUM mostly focuses on the management of team and the process, while Kanban is more towards optimizing the flow of work. So I'll cover the detail about each of these agile development approaches in further tutorials, but as of now, to brief about, it's basically all these three approaches have same agile manifesto values, underlying agile manifesto values, and in some organizations you would find that there would be like a hybrid of all these approaches utilized, or there will be Kanban utilized in some teams within the organization, and then there will be some development team which will be using SCRUM, and then there will be some development team using extreme programming, or there would be teams which would be utilizing the hybrid of all these different approaches. Programming. In this tutorial, I'm going to talk about extreme programming, which is one of the agile software development approach. Now, extreme programming is a software development approach which is intended to accommodate requirement changes and improve quality. So as in old development approaches like waterfall and V model, accommodating changes or requirement changes was not really an easy thing. So you have to go through the whole change request process to accommodate any of the changes. And because the releases were there were long releases, it was difficult to accommodate changes frequently in old development methodologies. So to address that, this extreme programming software development approach came, and the underlying principle of the extreme programming development approach is still same. It's the agile manifesto values. It implements agile manifesto values, and agile manifesto says that accommodating requirement changes is an important thing in order to improve the quality. So this development approach, extreme programming development approach, approach is intended to accommodate requirement changes so that the quality of the end product is improved. Extreme programming was introduced by Ken Beck, and Ken Beck is an American software engineer. And extreme programming advocates frequent releases. So as compared to the old development approaches like waterfall and V model, which had releases of large duration like couple of months to years, extreme programming advocates shorter frequent releases and short development cycle as well. Rather than having a long development cycle of 6 months and then getting to know that the end product is not satisfying what the customer or stakeholder is looking for, have a short development cycle and have a frequent releases so that you can get a feedback from end user and customer or stakeholder to accommodate those changes if required. Extreme programming also advocates pair programming. So what pair programming is? Pair programming is two people within the team, like developers or even testers, sitting together and working towards or working on one single piece of functionality or the piece of code. So one person writes the code and the other person looks at the code, what the person is implementing, and guides him in case of any misses or any gaps that are identified within the code. So there is a lot of communication, collaboration within those two members while pair programming to identify any of the open-ended question, and if there is something missing that needs to be implemented within the code or addressed within the code of that particular functionality. So pair programming is not only among developers, in extreme programming it's among the testers as well, or the testers who are doing the automation. They also sit together. They can sit together with the developer or with the tester to have the same approach of pair programming and come up with the better piece of quality and code. Now, extreme programming also advocates extensive code review and unit testing. Because of this short development cycle and frequent releases, extreme programming also advocates that there should be extensive code review, and that is why there is a concept of pair programming first, and then after pair programming, and once the code is checked in, it needs to be extensively code reviewed and then unit tested before it's actually deployed or released in the production. Now, the last bit to cover in extreme programming is close collaboration within team and customer. So because of this pair programming and approach, there is anyways a lot of collaboration within the team, within testers, within developers, and within the whole team to communicate together and come up with the better ideas to implement a solution and implement the code. And it also advocates that there should be a close collaboration with the customer to get continuous and constant feedback from the customer of the progress that the team is making, and to showcase what the team is doing and get the feedback then and there, continuous or quick feedback around the development, and to implement any of the gaps within that development cycle before it's too late for the production release. So close collaboration within the team and customer is also one of the key features of extreme programming. So these are some of the key extreme programming features that are very important as per the ISTQB Agile Tester Certification exam. Thank you. Extreme programming core values. In this tutorial, we will learn about the core values of extreme programming. Extreme programming has 5 core values: communication, simplicity, feedback, courage, and respect. So communication is one of the core values of extreme programming, wherein everyone is part of the team and everyone in the team communicates daily face to face. Team works together on everything right from the requirement gathering till the code and implementation. So since it's the whole team approach and there is a lot of communication within the team, so everyone in the team communicates around the requirement and make sure that everyone is on the same page in terms of understanding the requirement, and then everyone works together to implement the code from those requirements and then ensure that the code quality is changes as per agreed standard, and then the whole team works towards the implementation and release of the product. And because teamwork creates the best product, so that is why communication is one of the core values in extreme programming. The second core value is simplicity. Now, team will do what is needed and asked for, right? So simplicity is another of the key core values, and whatever is required to implement the code or to deliver the piece of software, that's what the team will focus on. There won't be unnecessary things to focus. For example, creating a lot of detailed documentation which won't be required at all in future. So team won't do that. So team will only work on the key and core important things that are necessary to release a quality agreed standard software in the market. Now, team will take simple steps to achieve goal and mitigate failures as they happen, and that's the second core value of extreme programming. The third core value is the feedback. Team will take every iteration commitment seriously by delivering working software. So every iteration in extreme programming is taken seriously, and team ensures that after each iteration a working software is being delivered and a feedback for that working software is taken and implemented in the upcoming iterations. So team demonstrates the software after the iteration and listens carefully and listens early. Since they demonstrate the software early, they get the feedback, they listen to the feedback carefully and make the changes as needed in the further iterations. Now, team also talks about the processes in future iterations, if required, to adapt to those changes in future in a more effective and proper way. Now, the fourth key value is the courage. All the team members in extreme programming tell the truth about the progress and estimates, because the team is the whole team is responsible for the delivery. Everyone has the courage to tell the truth of what they are able to achieve and what they are not able to achieve. There isn't any scope of lying in extreme programming. So everyone every day communicates and knows where each team member is in terms of progress and estimates. If there is a task which is going to take a long time, it's a complex task, then the team members have courage to say it's going to take time, and that's what the estimate looks like for that particular task or for that particular piece of work. Teams don't document excuses for failure because they plan to succeed. So in extreme programming, team plan to succeed. They do not fear anything because no one works alone. It's the whole team that works together and adapts to changes whenever those changes come and deliver the working software in the market or to the stakeholder. Now, the last core value of extreme programming is respect. In extreme programming team, everyone gives and feels the respect they deserve as a valued team member. All the team member in extreme programming are valued team member, and everyone respects each and everyone within the team. Everyone contributes value in the team, and because it's a teamwork, everyone's feedback is taken into account and made sure that that feedback has been worked upon. And so developers respect the expertise of the customer, and customer respect the expertise of the technical members in the team. So it's not that skill set of each and every member in the team within extreme programming team is respected. So respect is one of the another key core values of extreme programming. So these are 5 core values of extreme programming. Thank you. Extreme programming primary principles. So at a lower level, extreme programming describes a set of 14 principles as additional guidelines. So let us see what these 14 primary principles are. Now, the first primary principle is humanity. Second one is economics, mutual benefit, self-similarity, improvement, diversity, reflection, flow, opportunity, redundancy, failure, quality, baby steps, and accepted responsibility. So these are 14 principles as an additional guidelines in extreme programming. Let us see all of these one by one and understand what all of these mean in extreme programming. Now, humanity. So provide supportive working environment to team and reward development team. Why humanity is important? Why this principle is important in extreme programming? Because people develop software, and to gain their productivity or to gain productivity from people within team, you have to provide them with the supporting working environment and also reward the development team. So humanity is very important principle in extreme programming, and that's one of the 14 principles. Because people develop software, you have to provide them with the supportive working environment and reward them. The second principle is economics. The goal is to produce business value and not just the code or cutting edge technology, right? So if there is no business value of anything that the team is producing, that's of no value. So the main goal is to produce business value. That's the second principle of extreme programming. Third principle is mutual benefit. Now, looking for the win-win solutions which satisfies all the parties within the development team. So when we say all the parties, it means the customer, end user, the development team, and the business or the project sponsor. So mutual benefit is very important and one of the principles. So delivered software should satisfy all the parties, and you should be looking at the win-win solutions for everyone in the team. So that's the third principle of extreme programming. Now the fourth principle is self-familiarity, which says that make effort to see and understand existing solutions, patterns, and apply them in new contexts. So understanding the existing solution, or when the team actually starts working towards something, then the understanding of the existing solution is very important. So getting yourself familiarized with what you have at this particular time before you actually start building the new solution. So you understand what you have at this point of time, existing solution, and then you apply the same context, same knowledge in the new context. That's the another principle of extreme programming. So having self-familiarity is also very important. Now improvement is another principle which says no design or process is perfect. You have to make continuous effort to improve that. So improvement is the key of the extreme programming and is one of the principle among the 14. Now there is nothing as perfect in this world, so you have to work towards, you have to always try to make yourself or try to continuously improve to make things better, right? So it doesn't matter what design you have done as part of the solution or the process you have defined, there is always a scope to make things better, be it code, be it process. So continuous effort to improve the existing design or existing process is another principle. You should be always looking to improve the process or design. So improvement is another principle in extreme programming. Diversity. So team productivity increases through diversity, and you have to bring people with wide array of skills and perspectives to deal with problems. So diversity is another principle in extreme programming which says that there has to be diversity within team to get the new perspective or skills. So there should be like people within the team with different skill set, with different perspective, and that will give you an edge to look at the same problems in a different way to solve them, to get the better perspective or better ways to solve those same problems. The next principle is reflection. Now reflection is something saying that if you have done some mistakes in the past, be it like in the development cycle or in the release cycle, so extreme programming says that you have to go back and look what you have done right and what you have done wrong, and then learn the lessons from the mistakes that you have done in the past. And that's very important principle in extreme programming, looking back what didn't work very well or what worked very well, and then making sure that you implement the right process or approaches to address those issues that happened in the past and implement the good things that happened in the past in the future. So reflection is one of the another principle among the 14. The next principle is flow. Now Flow is important because you have to break large tasks into small manageable tasks and then follow short iterations. Now, why flow is important? Because having trying to deliver the big piece of software or big piece of work just at once is pretty difficult. So having a flow of like a small cycle or iterations is pretty important. So that's one of the another principle. So if you have a big piece of work, try to break it down into small manageable tasks and then fit those small manageable tasks into small iterations to deliver that big piece of code or work. Now the next principle is opportunity. You should learn from failures and obstacles and look for opportunities to learn from obstacles and failures. So it doesn't matter, always you cannot win or succeed. So there will be instances where the project will fail. There will be instances where the solution that you have implemented or the approach that you have taken might not necessarily lead to the success. So if you have failed in the past, try to take that opportunity to learn from the failures and obstacles that happen in the past and look for the opportunities and make sure that you learn from them and do not do same mistakes again in future. So that's another principle of extreme programming. Now redundancy. Try to avoid repetitive tasks. So in extreme programming, if there is anything which is repetitive, try to automate it. That's another principle of extreme programming. You shouldn't be doing any repetitive tasks in extreme programming. For example, if you are doing testing and there is data generation or test data generation activity for which you need test data again and again, try to automate those tasks, because that's something which takes a lot of time and it's a redundant activity. It's a repetitive activity. Do not do that. Try to implement automation to avoid the repetitive task. The next principle says accept failure. You need to try things even if they don't work and consider failure as a chance to learn. That's another positive aspect in extreme programming that you need to implement. You should be ready to accept failure. So you try something new. If it fails, even if it doesn't work, that's fine. You tried something new, you tried a new approach, and you learn the lesson from it. Make sure you consider the failure as a chance to learn something new. The next principle is quality. You have to maintain high quality because it increases predictability and efficiency. And high quality is also motivational. So if you have delivered something of high quality to the market, it gives you a lot of confidence and motivates you as a team, because you get a lot of good feedback from customer, from stakeholder, which motivates the whole team that you have developed something or you have made something which is really high quality and has been appreciated by the users in the market. For example, in today's world, Google, most of the product Google or Amazon launch, they are of such a high and good quality that once you use them, you are sort of a big fan of those products. The reason is because they put a lot of effort to ensure that the things that they are delivering in the market are of really high quality standards. So quality is another principle among the 14 principles of extreme programming. The next principle is baby steps. So don't rush too much. So baby steps is talking about basically take lots of little steps. Can be faster than few large bounds. So rather than taking big steps or trying to finish majority of the chunk in small period of time, you have to take baby steps. Try to do things one at a time or smaller things in a continuous iteration or short iterations on a regular basis, right? So take regular and prompt feedback and then improve in each iteration. So taking baby steps is much more important as compared to taking fast steps and taking large chunk of work within the short period of cycle. Now that's another baby steps in another principle among 14 principles. The next principle or the last principle is the accepted responsibility. Now what this means is the team is taking the whole responsibility. The whole team is responsible for the development and the quality of the product or software deliverable that's planned, and the whole team is responsible for completing the tasks within the team. So accepted responsibility is one of the principle of extreme programming, wherein the team assumes responsibility. There is no regulation or prescribed by the management, or there is no one else who will guide the team for the responsibility. So team is self-guiding or self-managing team in extreme programming, and they should be accepting responsibility. So that's the last principle among the set of 14 principles of extreme programming. So these principles are really important in terms of ISTQB Agile Tester Certification exam. So try to understand these principles thoroughly before you attempt your ISTQB Agile Tester Certification exam. Thank you. Extreme programming primary practices. In this tutorial, I'm going to talk about primary practices in extreme programming. So there are 13 primary practices in extreme programming. The 13 practices are sit together, 10-minute build, incremental design, weekly cycle, quarterly cycle, informative workspace, team, test first programming, continuous integration, Slack, stories, energized work, and pair programming. Let's see all of these 13 primary practices one by one and understand what these primary practices talk about. Now, the first primary practice is sit together, which means co-located team and co-location of the team. That means all the members of the team sitting at one place or at one office. They are co-located, which basically enhances or helps in communication and collaboration to be more effective. If the teams are co-located, then they can collaborate or communicate in more effective way. For example, I'm sitting on the same floor as my other team members. I can simply walk to the other person's desk to clarify my doubt. But if the team is not co-located, I have to call them, or I have to ping them over the chat to get the information that I would need. So extreme programming practice says that have a co-located team to enhance more collaboration and communication within team. The second practice is 10-minute build, right? So create a build and run automated tests in a maximum 10 minutes. Automated build and test reduces efforts and cost. So 10-minute build says that you have to create a build and run automated tests in not more than 10 minutes. So it has to be integrated software or a continuous integration. And whenever you have a code check-in, try to build that and run the automated test within 10 minutes to ensure that the build and the test are still fine and there is nothing broken. So because of this automation of the build and automation of the test or sanity check, this reduces a lot of effort and time, effort and cost in case the build is broken. So if there is a manual process around this, it will require a lot of manual effort to deploy, to build, and then to actually run those tests to ensure that the build is broken or not. So having an automated build is very important. That's the second practice of extreme programming. Now, whole team. So bring together all skills and perspectives necessary within the team. So teamwork produces higher quality product. Now, the entire team with different skill set and perspectives will bring the higher quality product or higher quality outcomes, right? So in the team, there should be people from different skill set and different perspective to bring the better quality product or software. So that's another practice in extreme programming. Informative workspace. Workspace should have visible lists, graphs to show project progress, and teams should have visible graphs and notices about tasks. So informative workspace is basically everyone on the floor or within the project area should be aware where the particular project is and where the particular iteration is. What is the actual progress? What are the timelines? All these things should be available or stick on the walls, and everyone in the team should be aware of these details. And a team should have the visible graphs, be it like the actual wall or the softwares that are available nowadays like Jira, etc. So you have visible lists and graph which show where the project is at, what tasks the whole team is working and who is working on what, and everyone is aware of what things are happening within the team. So that's another practice in extreme programming. Energized work. So work-life balance promotes enthusiasm and effective contribution. Workplace should be stress-free and there shouldn't be any overtime. So energized work will be possible only if there is a work-life balance for all the team members that are working within the team. So that's energized work is another primary practice in extreme programming, that there should be a complete balance of work and life, and there shouldn't be any stress in the workplace. So team members in the workplace should not be doing overtime, and they should be stress-free, they should be vocal, they should be able to convey their thoughts about the work-life balance and if there is any stress within the team. Now the next practice is slack. So include some minor tasks that can be dropped if needed. Don't overcommit and underdeliver. Set realistic attainable target. So what this means is the team shouldn't overcommit and underdeliver. So as a team in extreme programming, try to get some minor tasks in the iteration, and in case you are not able to deliver, those tasks can be dropped. Also, if there is some big piece of work that you know that cannot be achieved, or it will require a lot of extended hours of work, do not overcommit that sort of work. So only commit the amount of work as a team that can be delivered within that particular iteration. And also setting up realistic attainable target is very important in extreme programming. The next practice is pair programming. So as in the first tutorial of extreme programming, we saw that pair programming is one of the key things in extreme programming. So two heads are better than one. So two people working together on single piece of task is better than just one person focusing and just applying one perspective to solve that problem. Now this keeps each other on task, so everyone is both members at least know what is going on, and they both understand the functionality, and they add their perspective to bring up the better solution. And two people brainstorming together clarifies things more and fills the gap. The other thing is hold each other accountable to team standards. So because you both are working, or both people are working on single piece of task, so there will be team standards that had been set for the development work or any sort of work within the team. So the other person needs to ensure that the other person is accountable to follow those team standards. And then in pair programming, you take programming tasks in pair and alternate partner after 1 to 3 hours. So you just change the partner. So who is coding at the moment, you just change it after 1 to 3 hours to get the different perspective, and the other person keeps giving the feedback around the gaps and the quality of the development happening. So pair programming is another primary practice of extreme programming. The next practice is stories, wherein you describe requirements in the form of user stories. So rather than having the requirements in form of requirement specification document, the big documents that we used to have in old development approaches like waterfall, in extreme programming you should be having the stories which define the user requirement in the form of user stories. And user stories are the brief statements of required capabilities that can be finished in short time frame. So if it is you are able to accommodate that particular piece of work in an iteration, then that's what you should be looking at in extreme programming. So another practice is the stories. You should be having stories in extreme programming approach. The next thing or next practice is the weekly cycle. You do planning on a weekly basis, review the weekly progress, and pick a week's worth of stories to implement this week. Now weekly cycle is important in extreme programming. You do not plan big iterations or iterations worth of months. You do planning weekly. You review the weekly progress, see what has been finished, and then you pick what can be done in the another week or can be implemented in the another week. So that's the weekly cycle. The next practice is the quarterly cycle, wherein you do the high level planning, which is for 3 months. You pick a quarter's worth of stories or quarter worth of requirement, which is the stories in extreme programming, and then you review the lessons learned and improvements implemented. So you just do not ignore what things went well or went bad in the previous iteration. You have those lessons learned and ensure that you implement those improvements in this quarterly cycle meeting or quarterly planning meeting. Then you focus on the big picture, where the project fits within the organization or within the whole landscape. That's another big aspect of extreme programming practice, that you have to make sure you do not lose the sight of the big picture, that you have to ensure that whatever you are delivering adds the value in the whole approach. So in quarterly cycle, you ensure that you see the big picture and see where this particular project fits within the organization or for the end user and the customer. The next practice is the continuous integration. Continuous integration is very important in extreme programming because you have to integrate and test changes frequently. If you do not have continuous integration functionality and tools available, it's really tedious task to do all those manual code build, deployment, and then run the sanity check or run the build verification tests to see whether the build has passed or failed. So continuous integration, what in turn it does is, as soon as you check in the code or developer in the team checks in the code, the build happens automatically. The build is done, it is deployed on the test machine, and then there is a build verification test suite which is also automated, can be run by the continuous integration tool itself to ensure whether the build has passed or failed. So integration and testing changes frequently, and having continuous integration in place or automated build in place is really important and important practice in extreme programming. Regular integration defects, errors quickly. So you have to verify the integrated code by automated build and tests, and also you have to ensure that regular integration happens and it detects errors quickly. Now the next practice in extreme programming is test first programming. What this means is that you write tests before you actually implement code, right? So test first programming, as the name suggests, you implement the test cases first, or you write the test cases first, and then you actually run those tests to see the code fail. Now you actually write your development code to make sure that those tests are passed. So you rerun the test and see if those tests pass, and you do this cycle or refactoring until all of the test cases that you have written in the first step are passed. So this test first programming approach is another primary practice of extreme programming. And the last practice in extreme programming is incremental design. So design incrementally. Incremental design can incorporate feedback from customers, and incremental design improves the quality. So rather than designing the whole big solution in big bang approach, what extreme programming practice or what extreme programming development approach suggests is that you do the incremental design, right? You do the design, you do initial level design, you get the feedback of what is good, what is bad in that, what improvements need to be implemented, and then you incorporate the feedback and build incremental design and address any of the quality improvements or any of the bad design decisions that happen in the previous iterations to come up with the best design possible for that particular solution or software. So incremental design is one of the other primary practices in extreme programming. So these were the 13 primary practices in extreme programming, very important for ISTQB Agile Tester Certification exam. So please make sure you watch this tutorial and learn all these 13 primary practices in detail for ISTQB Agile Tester Certification exam. Thank you. SCRUM. In this tutorial, we are going to learn about SCRUM. So SCRUM is an agile framework for managing product development. SCRUM is lightweight, iterative, and incremental approach for product development. And Scrum is simple to understand but very difficult to master. And Scrum is a software development approach which implements the values and principles of the Agile Manifesto, right? So as discussed in previous tutorials, that we'll be discussing about Agile development methodologies like extreme programming, Scrum, and Kanban, and all these three Agile development methodologies or approaches are implement same values and principles as defined in Agile Manifesto. So Scrum is another Agile framework which is built using or which implements the values and principles of Agile Manifesto, and it's an Agile framework for managing product development. So any software development can be done using this Agile framework or Scrum. And Scrum is lightweight, and it's iterative and incremental approach for product development. So it uses iterative approach to do the product development instead of big bang approach. It is very simple to understand, but to master it's really difficult. So let's see what Scrum talks about in detail. Now, some of the Scrum instruments and practices are a sprint, product increment, product backlog, sprint backlog, definition of done, time boxing, and transparency. Let's see these instruments and practices in detail. Now, what is a sprint in Scrum? So Scrum divides the project into iterations known as sprints. So as we have seen in the first slide, that Scrum is iterative approach of software development. So sprint is the iteration, or iterations in Scrum are known as sprints, and these iterations or sprints are time boxed iterations. So sprints are fixed length of 2 to 4 weeks and for the entire project duration. So sprint is the iteration within the Scrum. So any iteration in Scrum is known as sprint, which is time box iteration or time box cycle of 2 to 4 weeks depending on the agreement within the project. Now, what is product increments? Product increment or product development is done in increments. So rather than having the whole list of requirements built at once in 6 months or 1 year, in Scrum, product development happens in increments, in iterations, which is sprints in Scrum, and then product development is done in increments. So after each sprint or increment, you have a shippable product that can be delivered to the market. The next thing is the product backlog. So what product backlog is? It's a list of items or the requirements that need to be delivered within the project. So for example, you have a project of duration 6 months or 1 year. What is the end goal of that project, right? So there would be some end goal, and based on that end goal, you define the product backlog. And product backlog is basically the set of user stories and epics that define the whole product backlog or the requirement for that whole product. So all that list of items for that whole product or project is known as product backlog. And product owner manages and prioritizes the product backlog. Product backlog evolves from sprint to sprint. So it's not necessary to have the product backlog defined and have it clarified in the first sprint itself. So you have the high level stories in the product backlog, but it evolves in sprint by sprint when you get the stories in the sprint planning, and then elaborate those sprints. So that evolves the product backlog in each and every increment or sprint. Now, what is the sprint backlog? So sprint backlog is the backlog that you pick in the sprint or the iteration to build within that iteration. So the highest priority items to be delivered in the sprint are known as sprint backlog. So depending on what is the priority of the delivery for that whole project, highest priority items are picked first in the sprint to be delivered within that particular sprint or iteration. So iteration are known as sprint in Scrum. So sprint backlog is basically whatever items or stories you pick within that sprint to be delivered is known as sprint backlog, and the whole team is responsible in delivering all items in the sprint backlog. So whatever backlog items or stories or the requirements you pick in the sprint, the whole team is responsible to deliver those stories at the end of the sprint. or iteration. Now the next important thing is definition of done. So definition of done is a checklist which defines the criteria of completion for the stories and sprint. It's basically saying entry and exit criteria in the old development methodologies. In Agile, definition of done is the checklist which defines when a particular story is complete or when a particular sprint can be said to be complete. So you define the criteria or the checklist, and when all the items in that checklist are fulfilled, you say the story has been done or the sprint has been done. We'll cover definition of done in much greater detail in further tutorials. Now definition of done can have a criteria like no open defects for stories or acceptance criteria met for the story. So any story will have the acceptance criteria defined by the business analyst. So if all those acceptance criteria are met, then the story meets the definition of done. Or say for example your definition of done says no, there shouldn't be any open defects for the story until you can close it. So that's another criteria for definition of done. Now the next important thing in Scrum is time boxing. So Scrum applies time boxing to all variety of activities in sprint. Now time boxing is very important in Scrum, and this is the key thing in Scrum methodology, that every activity in your sprint, be it your sprint or activity within the sprint, is time boxed. So meetings are time boxed, and there is a daily stand-up meeting which shouldn't be more than 15 minutes. And this stand-up meeting is to talk about what everyone in the team is doing, what they have done yesterday, what they are doing today, and if there are any blockers. So time boxing of all the activities within the sprint is another key aspect of Scrum. And sprints are time boxed to 2 to 4 weeks. So depending what approach you take. So there are organizations which have a 4-week sprint, and there are organizations which have a sprint of 2 weeks or 3 weeks. So depending whichever duration suits your project and your organization requirement, you can set that up. But you have to ensure that whatever time boxing or sprint duration you set for the first one, that remains same for the whole duration of the project. And the next thing is the transparency. So development team reports the work progress on daily basis, and for that daily stand-up meetings are organized, which is 15-minute stand-up wherein everyone in the team talks about what they have, what the progress is, and if there are any blockers for them. Then task boards are set up to show the team progress and showcase after each sprint to demonstrate the working software. So transparency is very important in Scrum development methodology, wherein you have daily stand-up, you have showcase after each sprint, and each member of the team is accountable or takes responsibility and is transparent of the progress that he has made within the sprint. So these are some of the key things around Scrum and what Scrum is. Thank you. Scrum roles. In this tutorial, we are going to learn about the Scrum roles. Let us see what roles are defined in Scrum. So Scrum defines 3 roles: Scrum Master, Product Owner, and Development Team. Let us dig into details of these 3 roles and what responsibilities does these 3 roles have in Scrum. Now the first role is the Scrum Master, and Scrum Master is a person who acts as the coach for the team. He or she helps to remove blockers for the team, ensures the Scrum principles and practices are followed by the team, and is not a team leader. So most of the time, people who are coming from the other development, who have worked in other development approaches like Waterfall and V model and coming to Agile, they have a misconception that Scrum Master is a team leader, but Scrum Master is not a team leader. It's a altogether different role. The role of a Scrum Master is to act as a coach. So he coaches the team, and Scrum Master is the person who ensures that if there are any blockers within the team, to remove those blockers, to help the team to unblock themselves and ensure that the work that has been done or that is in progress within the team is being progressed without any issues or hindrances. The Scrum Master is also also ensures that the Scrum principles and practices are followed. So for example, the time boxing principle or practice of Scrum, he ensures that any activity within the iteration or the whole life cycle of the Scrum development, the time boxing is followed. For example, the stand-ups, he ensures that the stand-ups don't exceed 15 minutes and people in the team stick to the key rules or principles of the stand-up, that what they have to talk about. They have to talk about the key things that you are supposed to talk in this stand-up, what you did yesterday, what you are planning to do today, and what if you have any blocker. So these are some of the key things that a Scrum Master is responsible for. He ensures that the principles and practices are followed. If there is any meeting, say for example retrospective meeting or showcase, etc., he ensures that all the principles or Scrum principles are followed in all of those meetings and processes. The next role we want to discuss is the product owner. So product owner is a person who is responsible for creating, maintaining, and prioritizing the backlog item. And what are the backlog item? So project backlog or product backlog is basically the requirement or the user stories that are defined as in the whole product delivery, right? So for example, you have a product development plan which is for 6 months, so all the user stories or all the requirements defined for that whole product development are defined as a product backlog. So product owner is responsible for creating that product backlog. He maintains that product backlog and then he prioritizes that product backlog based on what needs to be built first and what needs to be built afterwards. So he is the main person who is prioritizing based on his research and market analysis and what the end customer wants, and based on that he comes up with the backlog items and make sure that the team picks the high priority item in the upcoming sprints. Then product owner represents end user or customer. So product owner is someone who has who closely works with business as well as development team, and he could be the end user or he represents the end user, or he could be representing one of the customer. So if you're working in product based organization, a product owner could be someone who does the market analysis and who has a lot of market insights and knows what needs to be built as part of the product that needs to be delivered in the market. So he represents either the end user or the customer in the project. Product owner also sets the clear direction for the team. So product owner sets the clear direction that what the team is supposed to work and in which particular order team needs to work, because he owns the product backlog. He knows the backlog items, he maintains the backlog items, and he prioritizes. So he knows what needs to go in the first and second, third releases based on the direction that he sets. Then product owner also manages the releases. So depending on what direction he has set and what's the priority of the product delivery is, he manages the product release, or he manages the releases that needs to happen in the market or for the customer. Then he's also the key person for stakeholder management. So he manages all the business people and other business stakeholder for the whole product life cycle or whole product development life cycle. And product owner should also not be mistaken as a team leader. So product owner is also not a team leader as it used to be in other development approaches. The third role is the development team. So there is no tester, no QA. In Scrum, it's just one single team, and that's the development team, which comprises of cross-functional team and self-organizing team. So what cross-functional means is there will be developer, there will be business analysts, testers, solution architects, and all these different roles or different skill set make the development team. The development team is the set of people or the team who develops and tests the product. And the team which develops and tests the product is a development team. It's a cross-functional team. It will be having business analysts, it will be having testers, developers, solution architects, etc. It's a self-organizing team. There is no team lead. So there is no team lead culture in Scrum or Agile development methodology. Team makes its own decisions. So in sprint planning or when they do the iteration planning, team makes the decision. So based on the prioritized backlog set by product owner, team pulls the item and they decide how much items or how many items can be delivered within that particular sprint. So there is no one to push the amount of work within the team. It's a self-organizing team, and team knows their velocity and capacity, and they make their own decision of the amount of work they'll be taking in the sprint and then delivering within the sprint, after the sprint. And development team also ensures transparency with daily Scrum meetings. So because of the daily Scrum or daily stand-up meetings, there is a transparency in the development team, because everyone in the team talks about what they are working on, what they'll be working, what they have worked in the past, in yesterday, what they have worked, what they are planning to work on today, and then if there are any blockers. So all the members in the team are on the same page and know what each and every member in the team is doing in order to achieve the one common goal of the development team. So these are the key roles or main three roles of the Scrum development methodology. Thank you. Kanban. In this tutorial, we are going to learn about Kanban, which is another Agile software development methodology that is very important for ISTQB Agile Tester Certification. So what is Kanban? So Kanban is a Japanese word which means visual signal, and work is represented as a card on the Kanban board. So like you have a board. So nowadays you have a lot of softwares available wherein you can design your Scrum and Kanban board, but you can also have a physical wall wherein you have those sticky notes, and these cards or the sticky cards represent an item or the work item on this Kanban board. Now members of the team can see the state of every piece of work on this particular board. So there are physical boards in each project, be it like a Scrum or Kanban, where the team gets together for daily stand-ups, and then the members in that team can go to the Kanban board, which is a physical wall with the board. I'll show you the board in next slide, how the board visually looks like, and then members can see where each piece of work is on that particular Kanban board. And as the work is visual on board, so problems can be seen and addressed quickly. So as there is a visual board for Kanban and even for Scrum, so you can see where the problems are and can address those problems pretty quickly if there are any issues, defects, or anything related to the work item in the Kanban. Now there are three instruments in Kanban. First one is Kanban board, second one is work in progress limit, and third is the lead time. So these are the three key instruments in Kanban. Let's discuss each of these one by one. So what is Kanban board? Kanban board, it looks something like this in Jira, and you have different columns wherein these are the cards that the work item cards. So you have green, blue, so these are the work items, and then you have these columns, so requested, in progress, and done. This is the simple flow of the Kanban board, and that's how the board will look like in any of the application which supports Kanban board like Jira, or you can set up this physical board on the wall as well, wherein you have 3 columns or 4 columns depending on how you want to set up your Kanban board, and then you can have different cards, physical cards and handwritten cards or printed cards with the work items, an assignee as well, and then these items move in the board from one column to other depending on where these particular work items are. So if they are still sitting in the requested, no one has picked them, they are not in progress, then they'll sit in the requested column. As soon as someone in the team picks the item to work on, it will get moved to the in progress. And once the item is finished development, you see the sub column here, then it can move to testing, and then finally once the testing is done, it can move to done column as well, right? So that is how the Kanban board will look like on your actual wall or in the application like Jira. So next thing in Kanban approach is work in progress limit. So Kanban restricts the amount of parallel active tasks. So there'll be only a set of defined parallel executive tasks that can be there in one particular status. So for example, in progress, as a project you can define that there couldn't be more than 10 parallel tasks at a time in progress status. So Kanban restricts the amount of parallel active tasks. There can be only allowed maximum number of tickets at one station. So for example, start is your one station, in progress, which could have a development and testing. These are the other stations or other columns in the board, as we have seen in the previous slide. So there will be only a set, only allowed number of tickets at one particular status or station. Once the station is free, the developer pulls the task from predecessor station. So once, say for example, you have defined that in development there could be only 10 tasks at a time. So as soon as the tasks reduce from 10 to 9, the developer pulls another task from the previous station in the development station or development column. Now the third important thing in Kanban is the lead time. So lead time is measured as soon as the work item is created. So in Kanban, as soon as the item is created, the lead time starts. And Kanban is used to optimize the continuous flow of tasks, which minimizes the lead time. So as soon as an item will be created, the lead time starts from there. And with the Kanban approach, the key thing is to reduce or minimize the lead time, so that once the item is available or available in the development cycle, then it doesn't take much to deliver that particular item. Now we'll understand some of the key similarities and differences in Scrum and Kanban as well. So Scrum, for example, the release methodology of Scrum is at the end of each sprint or iteration, but in Kanban it's a continuous delivery of work or continuous delivery of the item or at the team's discretion. So team decides when they are going to deliver in Kanban, or it could be continuous delivery as well. Then in terms of a task board or visualization of the tasks, you have in Scrum you have Scrum board, and in Kanban you have Kanban board. So Kanban board is known as Kanban board. Scrum board is in Scrum you have Scrum board. Then in Scrum you have defined roles like product owner, Scrum master, and development team members. However, in Kanban there are no defined roles or no existing roles. The time boxing or iterations in Scrum is a sprint. So in Scrum you have sprints, which is 2 to 4 week cycle, which is mandatory, and at the end of every sprint you have to have a shippable product, and that's the principle of the Scrum development methodology. However, in Kanban, time boxing is optional because it's a continuous delivery of work, so releasing deliverables item by item. The key metrics of Scrum is velocity, and the key metric of Kanban is the lead time. So velocity is the key metric in Scrum to measure the progress or progress of the items or the delivery of the item in the sprint, and in Kanban lead time is taken as the metric for the team or for the work progress. So these are some of the similarities and differences between Scrum and Kanban. So in order to appear for ISTQB Agile Tester Certification exam, make sure you go through Kanban and Scrum development approaches thoroughly and understand what are the key similarities and differences between Scrum and Kanban. Thank you. Story introduction and collaborative user story creation. In this tutorial, we will learn about a brief about what a user story is, how it looks like, and collaborative user story creation within Agile development team. Now, a user story in Agile is written to capture the requirements. As in the older development approaches like Waterfall and V model, we used to have the requirements gathering phase and requirement specification document, right? Which used to capture the requirement that need to be implemented in the software product. Now in Agile, these requirements are not captured in one single phase or in a big requirements document. The requirements in Agile software development are captured in form of user stories, and these user stories are developed with collaborative effort within the development team. So business analysts, developers and testers and other stakeholders required work collaborative to come up with the user story in Agile software development. There are frequent and informal reviews done to accomplish shared vision among the team. So the reviews and close communication collaboration is there within the team in Agile to come up to bring everyone on the common page or same page what the story is about and what is the main goal or what is the aim of having that particular requirement in the whole Agile development or for the whole product development. So in short, user story is used to capture the requirement, and the Agile team works in a collaborative manner to come up with the user stories or to develop the user stories in Agile software development approach. Now this is the sample user story. So how the user story looks like, it's written in a plain English language, and it's easy to understand for everyone. So even if a person is from business or non-technical background or technical background, it doesn't matter who is reading this particular story or the requirement, everyone will be able to understand this particular user story in very simple way. So it's written in a simple language in a end user format, and there is a specific format which says, as a role, I want to do some activity or capability, or I want some capability in the software so that I can achieve something, or so that the system performs something, right? So this is just a simple format, and to give an example of that, I have come up with the sample user story which says, as a Gmail user, I want to log into the Gmail account with valid username and password so that I can check my emails. So this is just to give you an example. The actual user story can be even further broken in the smaller user stories, because this is just very high level sort of example that I have taken of a Gmail. But in turn, if you actually work or start implementing the user stories or write the user stories or refine the user stories, the format will remain same, but there'll be a lot more stories in a granular format that will be that will be captured as the requirement of the whole project. So this is sort of the format of the user story and an example of a user story. Now, why in Agile software approach you have this simple format of the user stories? Just to keep everyone in the team, it doesn't matter if the person is from technical background or non-technical background, everyone, by seeing the requirements in this format, is able to understand what the end result or what the end product should look like, or what functionality the end product should have once this particular user story has been implemented in the iteration or sprint. Now, moving forward, there is a 3C concept defined by Ron Jeffries, and the 3 elements of the user story that are defined by Ron Jeffries are card, conversation, and confirmation. So these are the 3 elements of the user story, and let's see what these elements talk about further. So card in user story is a physical media which describes the user story. So if you already have some prior experience in Agile, you would be very familiar with this, like the card which you use to write the user story in the format that I have discussed in the previous slide, right? So it's a physical media wherein you write the actual user story, and then you have a physical SCRUM or Kanban wall wherein you stick this user story and for the team to actually work upon. So depending on the sprint, you pick these cards or the user story and then progress further in the sprint to implement these and test these and deliver these user stories. So this is a physical media which describes the user story, and then you have softwares available as well wherein you like Jira is there, wherein you can define the Scrum board, and you have these virtual cards which will be available to all the users in the team to define the user story, and then people can move those cards on the in the software itself, so to move through the workflow. So the other thing is it identifies the criticality of the story and acceptance criteria. So in this card, in this particular card, this physical card, you have the user story definition, and that it identifies how critical the user story is, and the acceptance criteria is also mentioned on this card. This card also includes the expected development and test duration. So the key thing that are included in the card is the user story definition itself, the criticality, the acceptance criteria, and the expected development and test effort or the duration required, right? So you can have the physical card as well as most of the agile development team, you will have a physical card with a physical Scrum wall where you will do daily stand-ups, as well as you will have a software like Jira wherein you will build a board, you will set up a board, and then you can move those virtual cards within that particular workflow or the Scrum workflow or the Agile development workflow. So your physical wall and your virtual wall will be exactly in sync. So for daily stand-up, you will be standing against the physical wall, and or you will be displaying your virtual Scrum board on the projector, and everyone sitting or everyone attending the stand-up and updating where those particular cards are moving in the development life cycle. Now the next C talks about the conversation. So conversation among customers and development team is very important. Conversation clarifies what is needed by the customer. So once the story is defined and picked up for the development and agile development approach or in the sprint, then conversation among the team to clarify what is needed, or if there are any doubts for that particular user story, it's really important to have a conversation and with the development team, with the customer, to clarify if there are any doubts. These conversations can be documented or they can be verbal if they are like the quick one. Communication clarifies doubts and reduces ambiguity. So instead of just assuming something in the agile software development and going further and developing something which is actually not what the customer is looking for, it's better to have a conversation, clarification with the customer development team and build the end functionality as per the requirement of the customer. So conversation is very important in agile software development. The next thing is the confirmation in the 3C concept. So card defines the user story, conversation clarifies the user story if there are any ambiguities and doubts, and confirmation is to confirm that the acceptance criteria that has been mentioned on the user story has been met. So every user story, when defined in agile software development, has an acceptance criteria, and the acceptance criteria is nothing but an exit criteria which says that particular user story has met or fulfills the end needs needs of the customer or end users. And once those acceptance criteria or defined acceptance criteria for the user stories have been met, then the confirmation is then it's a confirmation and the story can be moved to done. You have to make sure that you do a lot of positive and negative tests to ensure that the confirmation or the acceptance criteria is met, along with functional, non-functional testing, security testing, and all sort of testing needs to be done to ensure the confirmation, the story is confirmed to be closed or done. Now, in the user story creation, you need to use the invest technique when you are doing the user story creation. Now, what is the invest technique? Let's see it in detail. So invest comes from the couple of like word: independent, negotiable, valuable, estimable, small, and testable. Okay, so the first point here is independent. So story should not be dependent on any other story. So when you are doing a collaborative user story creation in agile software development, you have to make sure that all the user stories that you're working on or your team is working on needs to fulfill this invest technique or the criteria defined in this invest technique to get the proper user stories or good user stories for the agile software development. Now, story should be independent. There are some instances wherein you cannot completely make 100% independent stories, but the team should try to make as independent the story as it could be. So break it in such a smaller chunks that there is no dependency within the stories, or one story should not be dependent on the other. The reason for that is if you start developing one user story and it's dependent on other, then that's a big blocker for moving further the stories that are dependent on the other stories. Now, this is the main reason the story should be independent, so that you can pick a user story and finish that user story within that sprint without having dependency on any other stories or tasks. The other thing is negotiable. A story is an invitation to a conversation and can change. So it should be negotiable and it's an invitation to a conversation. So stories should be negotiated within the team, with the customer, and any doubts should be clarified and changed in the user story. The next point is that the story should bring value to the customer or to the business. So there shouldn't be any story just for the sake of it. The story should bring in value to the customer or the end user. The story should be estimatable, or you should be able to estimate. Okay, so estimable, you should be able to estimate an story, or you should, as a team, you should be able to identify how much effort is required to bring to build that particular user story. The story should be small enough so that it can be completed in the sprint. So it should not be a large story that moves from one sprint to another. And the last thing in invest technique is the story should be testable. It should clearly define the acceptance criteria, and that acceptance criteria should be testable, and the person or the development team member should be able to test that particular story and meet the acceptance criteria. So these are some of the key points in the invest technique, and when you are doing a collaborative user story creation, these points should be always kept in mind when in the user story creation. Now, the next thing is the tester's role in user story creation. So this the tester's role is very important in user story creation because testers ask a lot of questions to figure out any missing detail. Tester perspective in any project is testers see the project as an overall and what value that particular project is going to bring to an organization or to the end user, and that's where testers feedback is really, really important in the user story creation, because the perspective that testers bring in the project is cannot be brought in by any other member of the team, because developers and other members, they do not see or have the limited set of scope in terms of looking at the whole picture. But because testers do the end-to-end testing and see the whole picture and are basically interacting with the other teams and systems, so they know the whole picture or the whole value that particular story is going to bring. And because of that, they ask questions to figure out any missing details, and that's where testers bring a lot of value in user story creation. Testers identify any missing functional and non-functional requirements in the stories. So because you are going to test it, if there is any functional requirement or non-functional requirement that's missing, testers can easily identify and ask the questions to include those requirements. Testers should use brainstorming and mind mapping techniques for user story creation. So testers should also use brainstorming and mind mapping techniques for user story creation. And testers also confirm the acceptance criteria. So whatever acceptance criteria is mentioned in the user story, testers confirm that particular acceptance criteria is complete, and if there is anything missing, they will be able to talk and clarify that particular acceptance criteria. And testers also propose the ways that they'll be using to test and automate that particular story, and these ways and approaches in turn also identify some of the gaps if there are in the particular user story. So this is all about the tester's role in the user story, and also what a user story is and why a collaborative user story creation is very important. So all the concepts discussed in this particular tutorial are very important for ISTQB Agile Tester Certification. So make sure you understand all these concepts thoroughly in order to pass your certification successfully. Thank you. Retrospectives. In this tutorial, we will learn what a retrospective is and some details about the retrospectives in Agile software development. So what is the significance of retrospectives? So retrospectives are the meetings to look back the work done in previous sprints. So whatever work has been done in previous iterations or sprints, retrospective is setting up the meetings and everyone in the team getting together to look back what was done in the previous sprint, what went well, what didn't went well, and what are the lessons learned. So that's the significance of the retrospective. Now, what is done in retrospective meetings? You discuss what went well, what didn't work very well, and what needs improvement. So these are the key things that are discussed in the retrospective meeting, and then anything that worked very well, and thanks to the team members who have worked in a collaborative manner to achieve the sprint goal. It covers the topics like processes, teamwork, tools, and many more. So there are a lot of topics that are covered in retrospectives. The key ones are the processes, tools, teamwork, etc. And there are follow-up activities defined in retrospective meeting to ensure that whatever action items have been defined in the retrospective meeting or agreed upon in retrospectives are being actioned and addressed in future iterations or future sprints. So that's the significance of retrospectives. These are the meetings to look back for the previous iteration and how the previous iteration went. Next thing is timing and organization. So what is the timing and organization of these retrospectives? Retrospectives are planned at regular interval. So after every sprint or iteration in Agile development in SCRUM, these retrospective meetings are planned. So after each sprint, there will be a retrospective meeting planned. These are organized and run by the facilitator. Whole team takes part in the meeting. So it's not that it's a meeting for some specific people within the team. It's the meeting for everyone working in Agile project towards a common goal. So the whole team takes part in this meeting, and other team members may also be invited. So whosoever is working in the Agile development team is part of these meetings, and also if required, any other business stakeholders if required are also invited in these meetings. Then what are the success factors for retrospectives? So retrospectives, in retrospectives, you need to have a clear objective and right set of attendees invited. So the whole team should be there, and if required, the right set of people from business or customer should be invited to get the real benefit of retrospective. There should be mutual trust and respect within the team. So everyone in the team should respect each other, and there should be trust within the team. There shouldn't be any fear within team member to come up with any idea or any feedback for the previous iteration or sprint. Issues and problems discussed in the retrospective should be welcome. So no one should be targeted, and any issues and problems discussed within the retrospective should be welcomed and taken as a feedback, and should be tried to improve in further iteration by taking them as an action item for the further sprints or iterations. These meetings should not target any team member. So these meetings are to discuss what the whole team has been going through and how everyone or the team as a whole performed, and these meetings should not be targeting to any specific person or set of persons or a group within the team. And there should always be follow-up activities. These are must to ensure that if there is something that didn't work well and needs an improvement in further sprints or iterations, that is addressed by having those follow-up activities in further sprints. So these are some of the success factors for retrospectives. So in short, retrospectives are the meetings to look back how the sprint or iteration went, and then what are and some of the key things in retrospective are the timing, how they need to be organized, and we have covered some of the success factors for the retrospective. Thank you. Continuous integration. In this tutorial, we are going to learn about continuous integration in agile software development. Now, let's first understand the continuous integration process and see what exactly the continuous integration process looks like. So continuous integration, the term itself is, what it means is, as soon as there is a change or there are changes done by developers who are working on the code or building the functionality, they are making the changes. As soon as they check in that particular code in source control server, this continuous integration process has defined set of tools and machines or servers that are already in place with scripts in place, which fetch those code changes, build it, test it with the build verification test and other set of tests that you could have, and then they notify the team with the success or failure to everyone or each member in the team who needs to know how the build went. So that's the brief about continuous integration. In terms of process, we'll see that, say for example, you have two developers or there is a development team that is working. So they check out the code from the main branch, and then for example, they start working from the scratch. So they did some development and they will check in the code. So developer 1 and 2, they check in the code in the source control server, which is the server to maintain the code repository. As soon as the code has been checked in, this continuous integration process, by this process there are scripts set up which fetch that code. So the step number 2 is to fetch that code to continuous integration server. Okay, so from source control server, which could be anything, there are many tools available in the market, like SVN and all. You have Git nowadays, very famous. So from that source control server, the code changes are fetched, and then in continuous integration server, the build happens. So step number 3, the build happens. Once the build is successful, no failures in the build, then the automated set of tests, step number 4, is executed. And in number 4, the test could be build verification test. There could be other functional tests, key functional tests that need to be executed. And if all of those tests pass after the code check-in and build and test, then the team is notified with the success and failure. So here the email will go to dev lead, developer, all the developers and other members of the Agile team. So this is a brief about the continuous integration process and how the continuous integration process is implemented in any of the Agile team or any of the development teams within the organization. Now, what are the automated activities in continuous integration process? So this the process that we saw previously was the continuous integration process, and there are many automated activities within that continuous integration process, which is the first automated activity is the static code analysis. So static code analysis happens, then compilation of the code happens. Apart from that, unit testing, code deployment, integration testing, reporting, etc. So these are some of the automation activities that happen in the continuous integration process. So like you will be having automated unit testing, automated code deployment, integration testing, and there are many tools and scripting languages available to achieve all these automation activities in continuous integration process. And this whole continuous integration process should be in place in Agile development, because Agile development, you have short iteration and there is a lot of code changes in each and every sprint. So unless until you have this continuous integration process in place, automated unit testing and automated regression testing, it becomes really difficult to cope up with the manual testing effort once the incremental build starts happening in the further iterations. Now, the benefits, what are some of the benefits of continuous integration? So continuous integration addresses the integration issues and defects very early. So as soon as there is any failure in unit testing, unit test execution, or build compilation, or any step of the continuous integration, you can easily detect that failure, or your automation or automated process itself will let you know. There will be automated email notifications coming to you whether the build has been passed or test has been passed or failed, and it will let you know at which step the particular failure happened. So any integration issues or defects are detected very early if you have a continuous integration process in place. The other benefit is that frequent feedback to development team about any issues in checked in code. So as soon as the developer checks in code, they'll be able to know that if there is any issues within their checked in code, because the build will happen, the test will run, and the test run pretty quickly. So you don't need to execute the whole suite of tests in the continuous integration process. It should be quick build and quick number of tests to check the compilation thing and the initial build verification test to ensure that the code check-in from the developer is all fine. The other benefit is automated regression testing can be done continuously. So with all these continuous integration process, you can have another set of automation testing automated in this life cycle, and with each build you can trigger this automated regression testing, and that can happen on nightly basis or depending on what frequency you want to set up for the project. Then it provides more time for testers to do exploratory testing. Once you have continuous integration process set up, you have your regression tests automated and running on nightly basis. Testers in the team have more time to do exploratory testing and identify more issues and improve the quality of the end product. It gives better testing coverage. So because you have automated testing, the combinations that are really impossible or you cannot achieve the permutation combination of test coverage if you're targeting those manually, with automated testing you can run those combinations pretty easily, which provides you better testing coverage. Continuous integration also eliminates risk of big bang integration approach, because you are checking in every day, or like in couple of days the code check-in happens, build happens on a regular basis, testing happens on a regular basis. The risk of big bang integration and failure of the build is reduced. It reduces manual testing for repetitive tasks, so no repetitive tasks are required in continuous integration. Anything which requires repetitive tasks can be automated. And executable software is constantly available for team to test or demonstrate to stakeholders. Because of this continuous integration process, build happens daily, and once the build happens, you have that executable software which you can install on your test machine or demonstrate to a stakeholder anytime. So these are some of the key benefits of continuous integration process. Now, what are some of the risks and challenges of continuous integration? So the risk and challenges are the identification and implementation of best suited tools. So one of the biggest challenges is to identify the tool that best suits your needs in the project. So that identification itself requires a lot of time in continuous integration process. Now, defining the continuous integration process, how the whole process will look like, what steps you'll be having in place. So that defining the whole process is another big challenge in the continuous integration process. Now, getting the people with the right set of skills to implement CI. So now in Agile, the major focus is around automated testing and having a lot of people with right set of skill who can do automation, write scripts to do the continuous integration. So getting people with those right set of skills is really challenge. Then tendency to perform less integration testing because there is continuous integration process set already. There is a tendency among the team that most of the coverage is happening through automated testing. So there is a risk that team might have a tendency to perform less integration testing or less exploratory testing. Then team may over rely on automated unit testing. That's another risk of having continuous integration. That over reliance on automated unit testing shouldn't be there, and team should do their due diligence in unit testing or any other exploratory testing required, even though continuous integration process is in place and a lot of automation is there in place. So these are some of the risks and challenges of continuous integration. Thank you. Iteration planning in Agile development. In this tutorial, we will learn about iteration planning in Agile. Now, what is iteration planning? Iteration planning is concerned with planning items for each iteration or sprint. So in Agile, you have short iterations known as sprint in SCRUM, and you plan the items that need to be developed or delivered within that particular sprint or iteration. In iteration planning, you define the iteration backlog. So iteration planning, you define what items need to be delivered in that particular iteration, and you define the iteration or sprint backlog. This iteration planning happens prior to start of each sprint or iteration. Now, prior to each sprint and iteration, the iteration planning is going to happen, wherein you will pick the items or the user stories that you are going to plan and deliver in that particular sprint. Who is involved in the iteration planning? Scrum Master facilitates the meeting. Product owner is involved. The whole development team is involved in this planning, and other stakeholders, if required, like subject matter experts, relevant members from other teams are also involved if required. But by default, Scrum Master, product owner, and development team is always involved, and if required, you invite other members from other team as well. Now, activities in iteration planning are that team selects the user story from the release backlog. So you have a release backlog, and product owner prioritizes the release backlog, and he prioritizes the user story that need to be picked up in the priority of development. So from that release backlog, you pick the user story, and then that user story is elaborated and elaborated in this iteration planning, so the team understands what the story details are, and if there are any doubts, those are clarified within that particular iteration planning, and those doubts are clarified from product owner, from the business analyst who are participating in that iteration planning meeting. Then the estimation of that user story is done. Then the user story is broken down into smaller tasks and subtasks and assigned to the respective team members who is going to work on those particular tasks for the implementation. So these are some of the activities that happen in the iteration planning. Then what is the tester's involvement in iteration planning? So tester's involvement is very important, because testers estimate testing efforts for the stories and provide the input around the testing effort that is going to be required to test those particular user stories in the iteration or sprint. Then testers participate in detailed risk analysis of the stories, and they also identify functional and non-functional aspects that need to be tested. So depending on what stories are being picked up in iteration or sprint, testers come up with the functional and non-functional aspects of testing required for that particular story. And testers also identify the story acceptance test based on the acceptance criteria defined in the user story. And if there is any gap in the acceptance criteria, or there are some doubts for the acceptance testing or meeting the acceptance criteria, testers clarify and provide their inputs in iteration planning meeting. Then testers also plan the automation strategy and the way and the levels of testing they are going to do for that particular user story, and communicate it within the whole team so that everyone is aware of the level of testing to be done and what coverage is going to be there for those particular stories, and the end result and the quality of the end product after that particular story is being finished development and testing. So these are some of the key points or the testers' involvement in iteration planning. Thank you. Release planning. In this tutorial, we will learn about release planning in Agile software development. Now, what is release planning in Agile development? Release planning is concerned with product release after certain number of iterations. Release planning happens few months ahead of project start. And release planning defines the release backlog. There are high-level estimates done in the release planning, and any project or product risks are also captured. Now, release planning is the planning of release after certain number of iterations or sprints in Agile software development. Now, what this means is that, say for example, you have a project which needs to be delivered in iterations or in couple of releases. Then you plan those releases upfront, 3 or 4 releases, and then within those releases you have the iterations or sprints. Now a release might be within after a month or 3 months, so depending on how the release frequency is for that particular project or how the organization works, the release planning will plan what are the action items or what are the stories or the work or the tasks need to be completed within that specific time frame to do the release in the production. And this planning happens few months ahead of the project start. So this release planning will happen couple of months ahead of the project start to ensure that the things or the requirements that need to be delivered in that particular release are well understood and captured well in advance, and any gaps or doubts are clarified well in advance before the project actually starts. Once these high level estimates or the requirements are captured, the high level estimates are also done for those particular user stories in the release planning, and if there are any product project risks, those are also captured in the release planning. Now, who is involved in the release planning? Scrum Master facilitates the release planning meeting. Product Owner is the representative, and he represents the general view of product backlog. So Product Owner represents the general view of the product backlog, and then delivery or a delivery team or the development team is involved in the release planning, and the stakeholders who advise around the release planning. So these are the key people or persons involved in the release planning meeting. So Scrum Master should be there, who will be facilitating the meeting. Product Owner represents the whole general view of the backlog of that particular release, and then the development team provides their input and feedback, clarifies the doubts, and the stakeholders advised around the release plan, the whole release planning. Now, the activities in the release planning are that all the required members in the Agile team get together. Then there is a product backlog that is created in the release planning meeting for that particular release, and user stories are then prioritized for the release. Within that meeting, they are discussed, and based on what is the end goal or result that is required for that particular release, the whole team discusses and prioritizes the backlog. Then high-level effort estimate are being discussed within the team and done for the release, and then test approach and plan is also defined within the release planning meeting, how the testing is going to happen, what approach needs to be taken for the testing and automation. Then what is the tester's involvement in release planning meeting? Tester estimates the testing effort. He provides the member of the testing team provide the testing effort of the stories that are planned for the release. It would be the high level estimates though. Then they also plan for the release testing. So they plan the whole release, they plan testing for the whole release. They see what is the what functionality or what product is planned for release in this particular cycle, and they plan the testing for the whole product. They contribute to the quality risks. So if there are any risks associated with the quality within those release, they contribute inputs for those, and then they define testable user stories and also provide estimates for the testing task within the release planning meeting. So these are some of the involvement or key testers involvement in release planning meeting. So that's a brief about release planning and testers involvement in release planning. Thank you. In this ISTQB Agile Tester Extension Certification tutorial, we are going to talk about the differences in testing activities between Agile and non-Agile projects. So to show you an example, I have taken the V model to explain the differences between Agile and non-Agile testing activities. So as you can see in V model, the testing team was almost involved in each of the phases from the beginning. But still, however, the most of the testing activities in V model were still left to the end. So if you see this model here, you have the business requirements, which used to be form the basis for the acceptance testing. Then the system requirements formed the basis for the system testing. High-level design formed the basis for integration testing, and low-level design formed the basis for the unit testing. The reason of the delay was that even though testing was involved in each of these phases, they were mostly doing the prep work or doing the test preparation in each of these phases. When the requirements were being gathered, business requirements were being gathered, they were doing the acceptance testing scenarios and doing work around that. Similarly, on the other phases, they used to write mostly the test cases, and there was a long phase of coding in V model, and only when the coding was completely done with all the business requirement, system requirement, high level design, low level design. So after all this work was done in phases and coding was done, then the testers used to get the code for unit testing, integration, system and acceptance testing, and that's where the major delay used to happen in the old development methodologies. Now, what is the what was the major problem with this approach was that in the earlier phases, the testing team was mostly occupied in the testing documentation activities, and in the coding phase, if the coding phase went more than for more duration as it was planned for, then eventually it used to be a big problem for the testing team. Now, how is it different in the Agile? In Agile, if you see the activities in Agile methodology is specification, design, development and testing are all completed in small iterations called sprints. So sprints is a term we use in SCRUM development methodology, and that's one of the Agile development methodology. So in Agile, there were multiple sprints wherein you used to get the stories, or you took the stories that need to be developed in those sprints, which is 2 to 4 weeks of cycle, and all the specification, design, elaboration of the stories, understanding the stories, what the requirement is, doing the design for those stories, doing the code, and then deploying that code in the test environment along with testing and automation is all included in those small sprints, which is 2 to 4 week cycle, and then at the end of the sprint the end product was available to be showcased, or to be it can be demoed to the customer or stakeholder. And that's the key difference, because if you compare the old methodologies, it was more like sequential approach and a long duration for the coding, and then after the coding it was the testing phase that used to start. Now with Agile, because you have the small sprints or iterations, all these activities are being done in those small sprints, and because of that there is a big advantage that you do not have to wait for the whole code to be available in order to start testing. So in that small cycle you are closely involved with the business people, with the business analysts, with developers, solution architects as a tester, and you are also planning your automation test cases along with your manual test cases to get ready to start testing of that code in that particular sprint itself. And because in Agile, testing is the responsibility of whole team, so everyone in the team, including business analysts, developers, solution architects and testers, it's responsibility for everyone to make sure that everyone understands the requirement correctly or the story correctly, and know what end result is supposed to be for that particular story. So quality is everyone's responsibility in Agile, and finished product after each iteration should meet definition of done. So that's the other major difference in Agile testing methodology as well, that finished product, so you have definition of done defined for each story and for each iteration as well. So the finished product after each iteration should meet the definition of done that is defined for that particular iteration. And definition of done is nothing but you can compare it with the exit criteria in the V model. And definition of done is defined for user stories, test level, feature, iteration and release. So there is a definition of done defined at each of the levels in Agile. So it's at the user story level, at the test level, feature level, iteration level, and only if all these definition of done criteria are met, then you will pass on the story to be as done. So for the iteration, you will ensure that the user story meets the definition of done, that test level defined meets the definition of done, feature, whatever feature is covered in that particular iteration meets definition of done, and the iteration definition of done is fulfilled. Only then you will say that particular story or the stories in that particular iteration meet definition of done or meet the exit criteria to be deployed and showcased to the business and to be deployed in the production. So these are some of the key differences between the traditional development methodologies and Agile methodology. Now, different Agile models differ in terms of how testing and development activities are integrated, and likewise project work products, name, entry and exit criteria, etc. for various level of testing, use of tools and how independent testing can be effectively utilized will vary based on the model. So there are different Agile models, and the work products, name, entry, exit criteria will differ in these models. So as a tester in an Agile practice, you should be able to more of a so when going with the Agile practices, the organizations nowadays, they adjust or customize the Agile practices based on the best suited format within their organizational culture and structure. So as an Agile tester, you should be able to quickly adapt to the context of a given project and the software development practices that are followed within the organization. So this understanding the differences between the old traditional methodologies and the Agile methodology, and how these Agile practices are implemented within the organization, and your flexibility to adapt to those changes, the usage of the practices, Agile practices within the organization, and the tools and the processes is key to succeed in any of the Agile projects within your career or within the organization that you're working with. Thank you. In this ISTQB Agile Tester Certification tutorial, I'm going to talk about the benefits of pairing. So as we have seen in previous tutorial of extreme programming, that pairing is a concept of extreme programming, which is one of the agile development approach. And pairing can be used in any of the agile development approach. It's really helpful, and there are a lot of benefits associated with pairing in agile development approach. Let's see what are the benefits. Now, the first benefit is there is increased quality. Now, because there is a discussion between a pair, which is analytic and brings greater understanding of the issues and how the functionality should be implemented. Because of this discussion among the developers, they figure out the gaps if there are any, and similarly if the testers are pairing together, they understand, or the other person who is sitting together brings in their perspective, so it brings in more value add and more clarity to the requirement, and even to the level of code that is being done for automation or for the actual development work for the product. So because of all these inputs from multiple people or people sitting together in pairs, they bring in different perspectives, different ideas, and which in turn adds a lot of value and improves the quality of the end product. As well as if you're talking about the testers, it improves the quality of the automation code, automation architecture, and in turn it improves the overall coverage and the quality of the product. Now, the second benefit of pairing is that there is a knowledge sharing. Now, because individuals who have a lot of technical and business knowledge of the domain or the technical aspects of the product, once there is a pairing concept, people with good knowledge of domain technical expertise will sit with other people, and in that way the whole team will have that knowledge sharing capability, and the team members who have less experience or who do not have the knowledge of the existing system will learn the existing system quickly, and this knowledge sharing will be beneficial for the whole team in the organization. So that's the second benefit of pairing. The third benefit is the capability uplift. Now, less experienced team members in the team can learn from the highly experienced team member. So highly experienced team member will have a lot of knowledge around the processes, around the products, the technical aspects of the product, and all the tools that they'll be using in the project. And because of this, once there is a pairing concept, any new member in the team can easily pick up by sitting with the highly skilled team member, and the highly skilled team member can easily guide the new member, and he can uplift his capabilities to the level that are required in the project. That's the third benefit of pairing. The next benefit is reduced risk of lost expertise capability. So because if you're not doing pairing, so for example, there is a person who has been there in an organization and has a good understanding of all the processes, tools, technologies, and he has been there for a couple of years, and he is the only one who knows, and once he decides to leave the organization, it becomes really difficult to get all that knowledge documented somewhere or even shared somewhere within the notice period that he'll serve to the organization. So because of the pairing, there won't be any dedicated person who will have all the knowledge information about the tools, processes, and technologies which he'll accrue over the year. As the pairing concept is introduced, so there will be always knowledge sharing, and there will be always people who will be knowing same thing and same level of technical expertise. There will be multiple people in team with same level of technical expertise, with same level of business capabilities. So this reduces a risk of lost expertise if one person decides to leave the organization. So these are some of the key benefits of pairing. And even if the team members are geographically dispersed, pairing is still possible if you use like proper tools of having the conference calls. You can have conference calls and build the team even if the team is geographically far away. So these are key benefits of pairing and really helpful in today's agile development approach. Thank you. Project work products. In this tutorial, we will see what are the project work products in agile versus traditional development approach. So let's see what are the differences in the work products of agile approach and traditional approach. So in agile approach, there is a lightweight documentation. However, in traditional approaches, if you have worked, you would have seen that there is a massive list of documentation that is required. Right from the requirements phase, you have a long list of documents that define the requirement and how the software should be built, till the end in the test summary report and all the other reports and documentation. It was pretty massive documentation at each level of the traditional development approach, be it waterfall or V model. However, in agile, it's lightweight documentation, and whenever it's required to do the documentation, it's done, and it's very concise and precise. So it only captures the key points and the things that are really required, and not just for the sake of documenting something. So that's the biggest benefit of having an agile approach, that the documentation should be lightweight, and it's really helpful and saves a lot of time when you have a concise and precise documentation instead of having excessive documentation. The second thing is document. In agile approach, you document only things that deliver the value to the customer. So if there is something which is not delivering any value at the end of the day, then you do not document unnecessary things in agile approach. However, in traditional approach, there was everything that needs to be documented in relation to project, and it used to be a detailed documentation at each level of the development lifecycle. So these are the two of the key differences in the documentation approach of agile as well as traditional development approach. Now let's see what are the key work products of agile development. Now agile project work product categories are mainly three. So you can categorize agile project work products into three categories. First one is the business oriented work products, second one is development work products, and third one is test work products. Now let's see what all these categories are and what sort of documents lie in each of these categories. So business oriented work products describe the required system specification, so like requirement specification and how to use it. For example, user stories, epics, etc. So this is what a typical business oriented work product will be. User stories are the form to capture the requirement in agile. So user story is one of the business oriented work product, and user stories evolve during the project as more information is present. Now at iteration planning time, a user story must define a feature small enough to be completed in the iteration. So user story is one of the business oriented work product, and it should define the feature which is small enough that can be captured that can be finished in the iteration. Now epic is a broader level of requirement which has multiple user stories below that, right? So epic is widely it has a large set of information which is then later divided into smaller user stories which will fit into the iteration to be completed within the iteration. So these are the business oriented work product in agile approach. So epic and user stories form the business oriented work product. Now in development work product, there is a code, there is automated unit test, and any other technical documentation that is required. So all the code that is being developed in the iteration forms development work product, and any automated unit testing and any documentation that the developers are doing while they are doing the coding. Say for example, they are defining how the configuration settings should look like. They are creating a document to guide the deployment team how the deployment should be done and what are the configuration changes that need to be done in any of the servers or any of the configuration files. All those documents form the basis, or they are the development work product in agile project. Now the third category of the work product is the test work product, wherein all the testing related documents like test strategy, test plan, manual and automated tests, test results, test summary reports, etc. they all come in the test work product category. So when the project starts, there is a high level strategy that is defined for the whole duration of the project, duration of the agile project. It's not a massive piece of documentation as it used to be. It just captures, so this test strategy and test plan in agile projects just capture the relevant information that is required for that particular project duration, and no other unnecessary information is captured in the strategy and plan. Then the manual and automated test. So because in agile approach you have a lot of behavioral driven development approaches nowadays, so your test cases could be in the form of given when then format, which form the basis of your manual as well as automated testing. And similarly, any of the test results, test logs, test data, etc. also forms the test work product. So these are the key these are some 3 key areas or 3 main categories of agile project work product. Now, as we have seen, or we have been discussing, that in agile you have minimal documentation as required. However, in some cases, if there is a regulatory requirement, and in some agile projects, or you are testing a safety critical project or some government project which has the requirement to have the detailed documentation, then even if they are following the agile approach, then in those cases there is more formalized approach of documentation that is taken, and the work product in those sort of agile project will be a bit more to satisfy the regulatory and auditors requirement. So these are some of the key things to note and key things to remember for agile project work product categories. Thank you. In this ISTQB Agile Tester Certification tutorial, we are going to talk about test levels and the differences between the test levels in agile development approach versus traditional development approach. Now, before we get started, let's see what the test levels are. So test levels are the testing activities that are logically related by the maturity of the product under test. Now, what that means is that, for example, your product is in the initial phases of development, then there will be unit testing that will be done on that particular product. Once the unit testing is passed and that phase of development has happened and developers are happy to move it to further testing, then that moves to the testers to do the integration testing. So here unit testing and integration testing are the test levels, and similarly, once the integration testing is passed, you move to the system testing, and once system testing is passed, you move to the acceptance testing. So these are the testing levels in the software testing. So unit, integration, system and acceptance testing, these are some of the testing levels in software testing. Now let us see what is the difference between the test levels in agile versus traditional development approach. So in agile approach, test levels overlap. Requirement specification, design, development often overlap with the test levels. However, in traditional approach, if you would have seen the waterfall approach or V model, you would see that exit criteria of one test level becomes entry criteria for the other test level. So until and unless all the test cases or the agreed amount of test cases or coverage is found or is passed in the unit testing level, you don't start with the integration testing. That was how the traditional development approaches worked, and until the agreed amount of test cases are passed in integration test, you don't move to the system test. And that was the whole idea in the traditional development approach, that entry criteria or exit criteria of one test level used to become the exit criteria for the other test level. However, in agile you don't have any such approach wherein entry criteria of one test level becomes the exit criteria of one test level becomes entry criteria for the other test level. So in agile, usually all the test levels will overlap with the requirement. With the design development, you will have the test levels as per the progress in the development phase. There will be testing activities within that same particular iteration as well. Now during the iteration, what are the test levels that could happen in the agile? So these are some of the test levels that will be there in the agile development approach in each iteration. So you'll see that there is a unit testing, which is typically done by developers in agile development approach. Then there is a feature acceptance testing, which comprises of verification and validation. So there is a feature verification testing and feature validation testing. So in feature verification testing, this involves testing against the user stories acceptance criteria, and this is often automated and may be performed by developers and or testers or both. So in agile, because everybody is responsible for the quality of the end product, so it's a collaborative responsibility of the team to perform the feature acceptance testing. And mostly in agile, you have to do the automation around the acceptance testing criteria and regression testing, so that you can do the whole coverage with the incremental builds. Now the other part is the feature validation testing, which involves the testing to confirm whether the feature that you are developing is fit for use for the end users and the customers. So this is often will be done by manually. This is manual testing by the developers or testers or business analysts or even the other acceptance testing people. Now this improves the visibility of the progress and gain real feedback from the business stakeholders. So feature validation testing, which is done by the testing team or development team in agile project, and then it could also be done by the actual business stakeholder or the customer to see what is the actual development that is happening, and this gives the real feedback of how the product is looking like and the feedback to the business stakeholder. Now the third form of testing that happens in agile development approach is regression testing, which is also in the iteration, and this is done throughout the iteration or sprint. So regression testing happens throughout the sprint, and it runs in parallel with automated unit testing and feature verification tests from the current iteration and previous iterations. Automated regression tests are part of the continuous integration framework. So regression testing in agile is only possible when you have the good automation strategy in place, and you keep automating the regression test cases from the previous sprint as well as current sprint and iteration. The reason for that is because you are building incremental, there will be a lot of regression test cases that need to be executed in all the upcoming iterations, and that number will keep growing. So if unless until you automate those test cases, it will be really difficult or not feasible for you to do or perform those regression tests in one iteration in 10 iterations down the line. So it's very important that automation unit testing and automated regression testing is in place for each iteration to cope up with the amount of regression testing that needs to be done in the agile development approach. The next test level in agile is system testing, which is done once the user story is ready for testing, and this involves functional and non-functional aspects of the story which needs to be tested. So system testing happens once the user story is ready for testing. So till now regression testing mostly was automated, so all these test levels are happening in the same iteration. So in system testing, once the story is done, ready for testing, you do the functional as well as non-functional testing of that particular story. The next level is the acceptance testing, which is usually done by the end of the iteration or sometimes after the iteration. So acceptance testing takes place very close after the or very close in the iteration till the end of the iteration, or even sometimes once the iteration is done, then in the next iteration the acceptance testing is performed. And acceptance testing includes users, operational, regulatory or contract acceptance test, and it also can involve alpha beta test that can be done based on the product. Now these are some of the test levels, and all these test levels are part of the same iteration in agile development approach and different from the traditional development approach, wherein the exit criteria of one test level became the entry criteria for the another test level. So please make sure you memorize all these test levels and the differences between the test levels in traditional development approach and agile development approach to before you appear for the ISTQB Agile Tester Certification exam. Thank you. In this tutorial, we are going to see testing and configuration management differences between agile and traditional development approach. Now in this slide, you can see there are some differences that have been mentioned in agile approach and traditional development approach. So in agile approach, if you see, there is massive focus on automated testing. However, in traditional approach, there is not too much focus on automation. Now, why in agile approach there is too much focus on automation? Because in agile you are doing iterative development, and the number of test cases or number of regression test cases in each iteration will increase based on the incremental development that you are doing in each iteration. So consider 10 iterations down the line how much amount of regression testing you would require to do in the 10th iteration or 11th iteration if you are not doing the automation. So you have to keep doing automation in each and every iteration or sprint so that you have the automated suite of test cases or regression test cases and unit test cases to execute those and meet the timeline in the 10th or 11th iteration based on the your agile development cycle or the timelines. So in agile, each and every step, be it the unit testing or the functional testing or system testing, wherever possible and wherever feasible, automation testing is the key, and there is a massive focus that you need to do automation in each iteration of the agile development in order to cope up with the large number of test cases that will keep building in iteration after iteration. Now in traditional approach, there was not too much focus on automation. There is automation in traditional approach as well, but it's more of a project by project basis, and if required they used to do it. It's not like if you are not doing automation you won't cope up, but in agile if you are not doing automation, you need large number of people to execute those number of regression testing from the previous iterations unless until you are building automation around that. So massive focus on automation in agile approach versus there is not too much focus on automation in traditional approach. The next difference is the continuous integration is used heavily in agile approach to ensure build stability and regular releases, and in traditional approach the releases were not very frequent, right? So there was the continuous integration was not much focus in traditional approach as well. So same as automation, continuous integration was not too much focus in traditional approach because there were not frequent releases. If you compare traditional approaches with agile approaches, in traditional approaches you would have got releases once in a month or once in a month and a half. However, in agile you could have a regular build, daily, nightly. The build happens, the test runs, and you'll get an automated report of the build as well as the test cases. So there is a continuous integration is heavily required in agile approach to cope up with all those builds and short iteration development cycle in agile. Now let's see some of the configuration management in agile development. What are some of the key points for the configuration management? So in configuration management in agile, there is heavy use of automated development tools, and these tools can be anything to do with the automated testing or managing the software development unit test cases, or even the deploying of the code into the test or other testing service. So developers continuously check the code and unit test into configuration management system using the automated build and test framework, and these frameworks allow the continuous integration of the new software with the system. So as soon as there is a new software checked in, there is static code analysis, unit test are automatically run on the new build. So there is heavy use of automated tools by developers, by testers in the agile development approach. Now let us see how configuration management works in agile and why there is so much need of automation in agile development approach. Now in agile development approach, you will see heavy use of automated tools to develop, test and manage software development. Right from the beginning of unit testing or static code analysis, developers use the automated tool to expedite the development cycle and get the build ready to be deployed. Once a build is ready, that build deployment also happens automatically using the automated tools in the test service. Once the deployment happens, there are automated unit tests or automated build verification tests which run just after the build. So these all usage of automated tool at different levels is very much involved in agile development approach. Now tools are used for static code analysis, unit testing and code coverage. So at each of these analysis and testing and code coverage phase, the automated testing tools are used. Now because there is a new code check-in daily by the developer in the team of agile development approach, the automated continuous integration server build, they build that code, they run the build verification test, and if required there are a couple of other sanity tests included as well. Once that test is run, they ensure that all the test cases pass, and if there is any failure, then the team is sent a notification or email that the build status has failed or the build has failed and which of the test cases have failed. So all this process, right from the unit testing, code analysis, deployment and testing, saves a lot of time. And once the team is informed about the build status with automated notifications, then the team works on fixing those issues first before they go further with more development work. With all these automated approach, with automated build happening, automated build verification test happening, unit testing happening, it saves a lot of effort for the testing team during the iteration, and it also improves the quality of the product in the end. The other thing that is automated in agile development approach is the functional test. So a lot of functional tests and regression tests are also automated, but if the functional tests take a lot of time to execute, the frequency of running those functional tests is less. It could be like in a couple of days that you could execute the whole suite of functional and regression tests. However, running the automated build and unit test and your build verification test happens with the check-in or nightly basis. Now, issues identified during continuous integration build are rectified first, so to ensure that nothing in the build is broken. So to summarize, the configuration management in agile development, new code and automated tests are managed by configuration management system. Then the functional automated test, which take a lot of time to execute, could be executed in a couple of days within that iteration, and it's not on nightly basis. Then any defects that are found during the build process in the agile build or continuous integration, they are rectified first before further development can happen. And automated test at all the levels, so like for example system testing or functional testing and integration testing, are required to have the better defect detection percentage as well as better product quality. Thank you. In this tutorial, we are going to look at the organizational options for independent testing. Now, in ISTQB Foundation Level syllabus, we have seen that independent testing team finds more defects as compared to non-independent tester. So having an independent team in Agile as well is very beneficial for the whole project and the quality of the deliverable. Now, let's see what are the options available for independent testing in Agile and see which one is the best fit for Agile development approach. Now, option 1 says testers to include testers in Agile team to perform testing. Now, this is the first option and pretty easy and okay to go ahead with, but there is a major risk with this approach, because once you assign a tester to the team, to the Agile team, they are working very close to the developers, and objectivity can be compromised because when the testers and developers are too close, they develop and they form an unconscious bias which can compromise the objectivity. So this option is brings with a lot of risk in agile development approach. The second option is to have a separate independent testing team to provide service during final days of the sprint. That's the second option, which is also not the best fit, because the reason for that is once you have an independent testing team and the testers involved during the last final days of the sprint or iteration, the testers will be not familiar what has went within the sprint, within the first week of sprint or a couple of days of sprint, and the lack of familiarity with feature and time pressure can cause impact to timeline. So they won't be able to meet the timeline if you just throw in a tester in an iteration in the last phases of the development or last phases of the iteration. So that's the risk of the option 2. Let's see what is the option 3. So option 3 is to create an independent test team and assign tester for the duration of the project. So this approach provides independence along with the longevity to understand and provide testing services without impacting timelines. So this is the approach wherein you have, rather than putting directly someone in the development team and developing and tester developing an unconscious bias and compromising the objectivity as it was in option 2. This approach, you have an independent team of testing and you are assigning the tester for that particular project duration, rather than assigning at the end of each iteration of that particular project, you assign the number of testers required for that agile project for the whole duration of the project. Now, the advantage of this is it provides the independence as well as longevity. So once the tester comes on board in the agile project, he is from the independent testing team, which provides the independence, as well as he will be able to collaborate easily and understand all the functionalities from the day one and help in the iterations during the testing life cycle. So this is the best recommended approach in agile. Now, what are the services that are provided by the independent testing team? So independent testing team can provide a service of test automation setup and execution. They do the functional and non-functional testing. They create and support test environments if required, and independent testing team complete the testing activities which might not fit in sprints. So for example, it's not necessary that each and every iteration or sprint will be able to do all sort of testing that is required within that iteration. So independent testing team can be really helpful here to provide the testing activities or to do the testing activities which might not fit in the sprint. For example, system integration testing or performance testing, which can go beyond the sprints or iteration. So these are some of the services provided by the independent testing team. So to summarize, there are multiple options for independent testing in agile development approach. Option 1 is to put dedicated tester in agile development team, which is not recommended because the tester might develop an unconscious bias and might compromise the objectivity. Second approach is to have the testing team involved during the later phases of the iteration, which is very risky, and because the tester won't know what has happened in the initial days, is what was planned and how the things need to be tested. So this brings a lot of pressure at the end, and the timelines might be missed. The third approach is having an independent testing team and putting testers for the dedicated duration of the project. So these are the three key options in the agile development approach and some of the services that are provided by the independent testing team. Thank you. Communicating test status, progress, and product quality in agile development approach. Now, agile teams progress by having working software at the end of each iteration. So at the end of each iteration, agile team have the working software, and that's how the agile teams progress. Now, to determine when the team will have working software, they need to monitor the progress of all the work items in the iteration and the release. So that's the key progress indicator to determine when the team will be able to deliver the working software, to monitor what all items are there in the iteration and in the release, and what's the progress of those items. Now, testers in agile team utilize various methods to record test progress and status. Now let's see what are those methods which testers use or utilize to record the progress. So testers utilize the examples like test automation results, progress of tasks and stories, the actual team progress, and the current velocity of the whole team. So these are the some of the indicators or some of the progress indicators that the testers use to record what the actual test progress and status is. So they do the test automation, they utilize the test automation results, they utilize the progress of the tasks and stories, they utilize the whole team's progress and the velocity to come up with the to record the actual test progress in the agile project. Now, what are the other ways or the ways which agile team or the whole team uses to communicate with the rest of the team? So some of the ways are there are verbal meetings, which is stand-up meetings, which are daily meetings that happen in Scrum, and then there are task boards as well. So you have Scrum board and Kanban board, wherein everyone will be able to see where the tasks are and what the actual progress of those tasks is. Then there are Burndown charts, charts in Agile, which show how much effort was taken in this particular iteration and how much has been burned till now, or how much has been worked on or completed till date in that particular iteration. Then there are wiki dashboard, which show the dashboard of the whole project and where the things are at this particular time. Then you have the email with the wiki dashboard. So there are emails that will be sent to the stakeholders, so on daily or the agreed timeline or agreed on agreed frequency, which will show you the dashboard of the actual project status. Then there are customer surveys as well. So these are some of the ways that Agile team uses to communicate with the rest of the team. So to conclude, we have seen that testers in an Agile team utilize various methods to record the test progress and status, and then there are different ways to communicate with other team members in Agile as well, which help testers to record the progress of the actual testing and status. Thank you. Verbal communication, daily stand-up in Agile development approach. Now, in the previous tutorial, we have seen that Agile team uses multiple ways to communicate among themselves, and verbal communication or daily stand-up meetings is one of that way to communicate with the other team members in Agile development project. Now, let's see what is daily stand-up. So, daily stand-up is a daily meeting that involves the core team, product owners, developers, and Scrum Master. It's a 15-minute quick short stand-up meeting which involves the core development team to discuss about what everyone is doing in the team, and if there are any blockers, then those blockers can be rectified by the other team members. There are ad hoc communication that happen within the team because the team is co-located in Agile development approach. So ad hoc communication happen at any time, but these daily stand-up meetings are scheduled and are more sort of formal to keep everyone informed. And daily stand-up meetings include all members of the Agile team. So any member of the Agile team or development team, like product owner, developer, and Scrum Master, are part of these daily stand-up meetings. Now let's see how these daily stand-up meeting agenda is. So daily stand-up meeting agenda for each member is that each member in the team, they need to tell what work got completed since the last meet and what work they have planned for completion until the next meeting. So whatever they have completed since they have met last, and what is the planned work until the next meeting, and if there are any issues which are blocking. These are the only 3 things that a person needs to talk in the daily stand-up meeting to keep it quick and short, and so that everyone knows where the team members or the team as a whole is progressing, and if there is anything blocking to someone, then if the other member in the team can unblock him to progress him further. So this is the key thing that needs to be that you need to stick in the daily stand-up meeting, and nothing more than that. This meeting is not to discuss any of the solutioning or the other issues in the project. This is only to discuss what a person has been working on, what he has completed, what he is planning to do, and if there are any blockers which can be unblocked by the other team members. And these team meetings or these daily stand-up meetings should not be more than 15 minutes. So it should be very concise and precise. Everyone should be talking to the point and only what is required, so that everyone in the team is aware the actual progress within the team. Thank you. The next method of communication within the Agile team is the task board, and in this tutorial I'm going to talk about the task board and how the task boards can be really helpful in the Agile development approach. Now, task boards provide an instant, detailed visual representation of the whole team's current work. So in Agile, you have the task board which have the visual representation of all the tasks that are there in that particular iteration and where that particular task lies at this particular time. So this is updated on a daily basis or whenever there is an update or person starts working on it. and whatever time he has spent on that particular task, they update it on a daily basis so that everyone in the team is aware of what the actual progress of the tasks on this particular board is, and overall how that particular iteration is progressing. Now, the story cards, the development tasks or the test tasks, and there are other tasks, there could be other tasks as well. They are created and displayed on the task board, and different colors are used to capture different task types, just to differentiate. So for example, defects could be of color red, and then story could be color white or blue, and then development task could be of some other color. Similarly, test task could be of some other color. So to differentiate whom these particular tasks on this board belong to. Now, in the next slide, I have taken an example of the task board from Jira. So this is how the task board will look like, and this is basically, there is an underlying workflow below this task board, wherein you can or how your task or story on this board moves. So for example, if you see this to do, in progress, and done, so there is a workflow behind that, and you can move these tasks from to do to in progress, and then once you are done with working on it, you can move it to done. So as you can see, these are the stories here, then this is the task here, it is a subtask, and similarly there are some of the stories which are still in to do, which are in progress, and some stories which have been done. So but just by looking at this task board, you can easily visualize where all the sprint 4 tasks are, or what is the progress of the tasks in sprint 4. So this is the duration. So this is just a dummy screenshot that I have taken. However, in the ideal situation, once the sprint is over, you will have most of the tasks move to done before the sprint is over. So this will show you the duration of that particular iteration, how many days are remaining, and based on that you can easily see how the team is progressing with the overall assigned responsibilities or tasks in that particular iteration or sprint. So the status of the tasks on the board are regularly reviewed by the team, both ad hoc and the daily stand-up meeting. So ad hoc you can go and have a look, but in stand-up meetings these are all always reviewed on daily basis to ensure that everything is on track and progressing as usual, and at an acceptable rate, so that whatever is planned for that particular sprint can be completed within that particular sprint, and if there are any blocker, those can be removed by the Scrum Master or the other team member who can help to unblock those incidences. So this is a brief about the task board. Task boards are very helpful in Agile. They provide instant and detailed visual representation of the complete team's work and help to track how the overall work is progressing within that particular iteration. Thank you. Burndown charts are another way or tool to track progress across the entire release or within the iteration in any Agile project. These charts are simple to maintain and easy to read and show the current state of the project or current state of the release, where how much amount of work has been done, how much amount of work is remaining, and this is really helpful to track the overall work in the iteration, the progress of the work in the iteration and in the release. Now let's see what the Burndown charts are. So it's a graphical representation of outstanding work versus time, and very common way to track progress across entire release and within each iteration. So these are very commonly used in Scrum and in any Agile development approach to track the progress and see how much amount of work has been done and what's remaining. Now let's see an example of a Burndown chart. So here I have a sample Burndown chart. So in Burndown chart you have on the x-axis you have mostly the days for that particular iteration. So here, just to show an example, I have taken a sample chart which has 21 days iteration, and the effort is on the y-axis, which is on the which is captured in number of hours that are required to do the work. Now the total work estimated was somewhere between 200 to 250, which is like 225 hours, and that work needs to be completed in 21 days. So this is sort of, if you consider this as an iteration, you see the x-axis has the days, y-axis has the effort, and then you have the tasks that are completed on the day. So once the task is completed, you see the completed task shown. Which task is completed, that will be shown in the tool as well. So if you go in Jira Burndown chart, you will easily be able to figure out what got completed on that particular day and how many points or how many hours got claimed for that particular task on that particular day, right? So here you can see this orange is the complete task, blue line with the dot is the remaining effort that is remaining on those particular days. This green line is the ideal burn down, which is very rarely going to happen because there is nothing called ideal scenario in the actual projects. There will be blockers, there will be issues on particular days, and there will be some days where you will be able to do a lot of work, but there will be some days wherein you won't be able to achieve much because of the issues or environment issues and any other many other issues that could happen within the project. So and this blue line is the actual remaining tasks in the project. So if you go through this the whole burn down chart, you can see that on day 21, as you keep progressing, you can figure out that how many tasks got completed on that particular day and how much amount or how much effort or how many tasks are still remaining to be completed. So for example, you are on day 11 in that particular iteration and you're looking at this burn down chart, you can easily see that you still need to complete approximately 100 hours worth of work in order to complete the whole amount of work. So because on day 11 only up to 125 hours have already been done. So you know that these burn down charts are very useful when you are to predict when all the amount of work is going to be completed. So these burn down chart can be used in iteration as well as you can use it for the whole release of the Agile project. Thank you. Dashboards or wiki dashboards in Agile development approach. So dashboards are another way to track progress across the project and the tasks that the team is doing within the iteration as well. So you can have a dashboard for the iteration or you can have a dashboard for the whole release as well. Now let's see what a dashboard or a wiki dashboard is in Agile project. So Agile team use dashboard for communicating status to the whole team. So dashboards are very easy to use and it's a visual representation of what all activities are going within the sprint, where the tasks are, what is the overall progress. You can add multiple widgets on the dashboard to visualize the data in different format that you need. You can have a pie chart, you can have a bar chart, etc., and you can have tabular format as well. So it's easy, highly customizable, and you can use it easily to track the overall progress of the sprint or the overall release. Now tools automatically update the work status on dashboard and send email to whole team. So now once you configure a dashboard on tool like Jira or any other similar tool that you can use in Agile for the project tracking and the task tracking within the sprint and the release, then these tools automatically update the status on the dashboard. So as soon as there is an update on the task, that is automatically reflected on the dashboard as well. And Jira dashboards are very common with Agile team. So Jira, it's highly customizable dashboard. You can add a lot of widgets available from their marketplace, and depending on the project need, you can customize it. You can use whatever is required to track the progress of the project. Now these dashboards are also configurable. You can configure the email setup with the dashboard. So as on a daily basis or whenever there is a major incident happen, so you can have different rules assigned, which will trigger an email to the relevant stakeholders to update the overall progress. And the benefit of this is that it saves a lot of time for the team members to actually report all those activities that they have been doing. So for example, in testing, you just need to set up a testing dashboard, and all the testing progress will be reflected on the testing dashboard for iteration as well as the whole release. Similarly, there could be other dashboards in project that could be set up for the whole project duration or for the iteration, which includes all the development as well as testing activities. So you can have highly configurable dashboards in the tool like Jira and add the widgets as per required, and this saves a lot of time and effort for the other team members to do the reporting activities in the project. Now let's see how these wiki dashboards or a Jira dashboard looks like. So this is the sample Jira dashboard that you can configure. So these are all the widgets. So you see these small section like this pie chart. This is a widget. This is another filter, rich controller filter. This is a bar chart here, bar graph, and here you have the high level status of what is in the backlog, what's in the work in progress, what's in the validation. So you can have all these different widgets available from the marketplace. You can keep adding those as per the need in the project or in the testing status report or testing dashboard, and add these and configure the filters behind that, and this will get updated automatically once any of the issues are being updated in the project or in the iteration. So that's a brief about the sample dashboard and dashboards and wiki dashboards in Agile project development. Thank you. Customer survey or customer satisfaction survey. Many Agile teams conduct customer satisfaction survey to get the product feedback, or whatever product they are launching in the market. They do the customer survey and get the feedback from the customers to see whether that particular product meets the customer's expectations, and if it is easy to use for the customer, or customer finds it very helpful to use, or there are some flaws or some more enhancement that needs to be made, or customer feels that there needs to be more refinement or more features to be added to make it more presentable and more easy to use for the customer. And that's the key reason many Agile teams perform customer satisfaction surveys to get the feedback. You would have noticed many products are launched in the beta phase. For example, even when Gmail came through, it initially launched as a beta product and it was invitation through only. So that these sort of beta releases are the key reasons to get the overall feedback from the customer through the customer satisfaction survey or customer feedback. Now, customer feedback, whatever is feedback provided by the customer, is used to improve the product. The key reason for the customer satisfaction survey is to get the feedback and to improve the product, whatever customer has requested or whatever is feasible to be implemented in the product. And that feedback also aids in key decision making. So for example, you have launched a beta product and the feedback that you are receiving is not good at all, or it is basically, it has a lot of concerns that customers are raising. So that gives you an idea that the product is not going to succeed in the wider market if you release it. So it also gives you feedback whether you should release it to the wider audience or fix all those issues that are being raised by the customer before you release it to the wider audience in the market. And that helps in the key decision making of the product release as well. Now, metrics and feedback that are received from the customer feedback should not be used to reward or punish any team. In Agile, it's the collaborative responsibility of the whole team for the quality and for the product release. So any metrics or any feedback that is received by whether it is from the customer survey or from the internal metrics, which is the defect density rate or any of the existing testing feedback or testing metrics that is existing in the product, all those metrics should be only utilized to improve the product and not to reward or punish anyone in the team. So these are some of the key benefits of having a customer satisfaction survey or customer survey before you launch the product to the wider audience in agile development approach. Thank you. In this ISTQB Agile Tester Certification tutorial, we are going to learn about how you can manage regression risk with evolving manual and automated tests in any of the Agile projects. Now, why does this regression risk increases in Agile projects? So let's understand the why part of it, and then how you can resolve those risks. We'll understand it later in this tutorial. So why does regression risk increases in Agile project is because you have smaller iteration known as sprint. So if you're following SCRUM, you'll be following smaller iteration called sprint, and each sprint you pull certain user stories, which is sort of a requirement that you build upon. And once those requirements are built, so after each iteration you have newly added functionality, you have new stories to work on, and that adds more functionality and more number of test cases and the code into the existing build. The other thing is that there are modifications required due to business feedback. So after each iteration you do a showcase, and after the showcase there will be a feedback from business, from stakeholders. Once these feedbacks are incorporated into the build, the modifications are done, and because of those modifications there will be new addition of code and test in the after each iteration. There is also addition, modification, removal of code in each iteration. So there might be possibility that you are removing the code or you are modifying the existing code that was built in the previous sprint. Removal could be possible because for example, after the feedback of the stakeholder, they do not require certain functionality or certain things in the feature that would require to remove certain part of the code. Addition of the code will always happen in the new sprint because you are taking new functionalities and you are building the code on the existing code that you built on in the previous sprint. So these are some of the reasons why you will be adding or removing or modifying the existing code in each iteration in the Agile project. Now, due to tight timelines, all the tests cannot be executed in each iteration. So that's another reason of the regression risk in Agile projects, because of the tight timelines. Like you have 2 to 4 weeks of iteration or sprint, and in that particular timeline it might not be necessary to test each and every part of the code. Ideally, when you are following Agile, you should be doing you should be meeting the definition of done or acceptance criteria for each stories until you can say it is done. But there might be possibility that certain type of testing which would be agreed within your project that is not done, and that might be pushed forward. So for example, acceptance testing of the stories or even the end-to-end testing of the stories might get pushed forward into the further sprints, which might increase the number of test cases to be executed in further sprints. And these are some of the reasons why the regression risk increases in any of the Agile projects. Now let's see how you can reduce or manage the regression risk. So first we understood why the regression risk arises in the Agile project. The next thing is we need to understand how you can manage the risk in the Agile projects. Now first thing you need to do is to revisit regression test suite in each iteration. Now revisiting the regression test suite in each iteration is very important thing if you want to have your regression suite up to date in each iteration and until the end of the project. So revisiting the regression test suite and removing any not required test cases from the suite and adding the new test cases in the suite is very important. The second thing is you have to automate regression testing. You cannot live without automation in any of the Agile projects. You have to automate the regression test suite, and any new addition in the regression test suite which can be automated unless and until there is an exception for those test cases, you have to have the automation for the regression test suite, because you cannot cope up with the new functionalities and new test cases that are built in each new iteration. There has to have in sprint automation. So whatever you are doing within the sprint needs to be automated within the sprint. Then unit testing needs to be automated. Build verification regression testing also needs to be automated. You have to automate acceptance testing and any repetitive tasks that you do in your sprint, like data staging or any of the test environment setup or build deployments. All these things in any of the agile project had to be automated. You cannot cope up with the functionalities or evolving functionalities in each iteration unless you automate all these key things in any of the agile projects. Now the next thing is how you can automate regression testing and why automated regression testing. So majority of the regression test suite should be automated. If not 100%, majority of the regression test suite, whichever can be automated or whichever test cases are possible to be automated, you need to automate those. There should be run against every new build. So as soon as there is a new build, these regression test cases, so you need to decide what frequency you want to execute these regression testing, but ideally for against each build, it's advisable to run the automated regression test suite to see that there is nothing broken in the new build, or all the existing or the regression test suite that you have, all the tests are still passing with the new build. Now if the regression test failed, you have to investigate, or your team has to investigate the failure first. Sorry about the misspelling here. It has to be the failure needs to be investigated first before proceeding with any further activities. Now if test failed due to defect, it should be fixed first before proceeding with further development activities. Now that's another thing that you need to follow to manage the risk, that if any of the test failed due to defect, that test need to be fixed first, or any underlying code needs to be fixed first before you proceed with any of the further development activities. So that's how you cope up with any of the complexities and risk in the agile regression testing. The next thing you need to do is in sprint automation. Now in sprint automation is basically doing the automation within the sprint. So for example, you have picked 5 user stories to be built in the sprint. Now the testing team needs to come up with the automation of the test cases around those 5 stories, and needs to ensure that functional or progression testing test cases are automated, as well as any regression test cases for those new 5 stories that are identified needs to be automated. And you should try to maximize the number of automation or percentage of automation in sprint, so that in the next sprint you don't, because in next sprint you will be getting another 5 or 10 more stories to build, and if you still have to regression test the 5 stories in the current sprint manually, in the next sprint, that will keep increasing the amount of work that you need to do in the next sprint. And that's the main reason that you automate whatever is there in current sprint before you move further to the next sprint. So in sprint automation is very, very important in any of the agile project. Now second thing is target to get more test coverage with automated testing. Now with automated testing, you shouldn't be looking automation testing or automated testing as a replacement to the manual testing. Now automated testing should be looked in as improving the test coverage, improving or adding the edge scenarios, or adding more scenarios to the testing and improving the quality. And it's not a replacement to the manual testing or the exploratory testing that you should be doing in the sprint or in any of the agile project. So with automation testing, you should be targeting more test coverage in each sprint. Now identify the sprint test cases which can be added to regression test suite. Now you have to identify the test cases in each sprint that you can add in a regression test suite every sprint, and try to automate the maximum percentage out of those regression tests as much as is possible in the sprint. The next thing is you have to have automated unit testing. Now unit testing done by developers when they are writing the code should be automated in any of the agile project, because if they do not automate that unit testing, that is basically adding up again in the iterations. It's similar to the regression test cases that for testing. It's similar for the unit testing as well, that if the developers are not automating any of the unit testing, in future sprints or future iterations, the pile up of the unit testing will be keep building up, and they need to ensure that they are automating that, so that in future sprints they don't need to look back or do that unit testing manually if they are doing. So that needs to be automated as well, and developers need to ensure that build is not broken. Whenever they are writing the code in the iterations, they have to make sure that any code check-in should only be done once all their unit tests are passed in that particular iteration. So automated unit testing is another thing that reduces the regression risk in Agile project. Now, automated build verification test. What is build verification? So build verification is whenever the developers are building the code or developing the code in the sprint, they write the code, they deploy it, or they compile it, and then they deploy it, or make a package to be deployed on the test machine or production machine after the testing. Now that package, when it's deployed on the test server, is a build. Now once the build is deployed, only then the testing team or any other person in the project will be able to start using that particular product. So build verification test, what it does is it deploys, so it will be run after the build is deployed, and there will be a minimal set of test cases in the build verification test which will identify the core functionalities or the critical functionalities before the testers or any other members in the team can actually start testing that particular product. Now BVT test should pass before testing can start. So whatever test suite that you have for the build verification test should pass before anyone can start working on that particular product, because that will ensure that time is not lost or wasted in testing any unstable software build. So if your build itself is not stable, or the core functionality, so for example, once you deploy the build and there is the functionality which says that user should be able to log in, and that's the first entry point to your application, and you're not able to log in after the build deployment, that's basically a wastage of time for the testers if they start working on that particular build. So build verification test need to be passed if tester needs to start working on the build. The other thing that reduces the risk is automated acceptance testing. So key acceptance test scenarios should be automated wherever possible, and these acceptance test cases should be run against each build as a whole system. And these acceptance tests provide feedback about product quality with respect to regression since last build. Now, acceptance tests should also be automated wherever possible, because these acceptance tests ensure or will ensure that your core functionality or the acceptance scenarios are still passing after each build deployment, and these should be these acceptance tests should be run against whole system or system as a whole. So at each level of this software development life cycle in Agile project, you should have a maximum amount of automation to reduce those testing risks or regression risks. So we had seen that you need to have automation at unit testing, regression test level, automated acceptance testing, build verification test. So at each level you should be having the automation in place. The next thing is, if there is any repetitive task in your project, say for example like data staging, usually that's what happens for the testing. So testing team requires a lot of data staging work, or a lot of existing data or different data combinations to verify the scenarios that they are looking for. That data staging part shouldn't be manual, because manual test data staging will take a lot of time, and if that's the case, it should be automated wherever possible. Build deployments in test environment should never be done manually. That should be also deployed, and that's where DevOps comes in picture. If you have good DevOps pipeline in place, the deployments and build verification test happen continuously along with regression test, automated regression testing as well. So all these build deployment activities, any data staging activities, or test environment restoration to different baselines. So for example, you're looking for a different baseline restoration, you should be having a one-click restoration thing which will restore it to a particular platform, particular baseline which has particular OS, particular version of certain software, etc. So all these tasks should be done automated or using the scripts, and even the data comparison. So if you're comparing data for your test, that should be automated as well. So any repetitive tasks in Agile project should be automated as well. So to summarize, in this tutorial, there will be a lot of regression risk or risks in any of the agile methodologies that you follow because of the iterations that you have in the in agile project. And in order to manage those risks, automation is the key thing, and automation at each and every step in agile project will help you to remediate or reduce the risk that you have in the agile project. Thank you. In this ISTQB Agile Tester Certification tutorial, we are going to learn what are the roles of a tester in an agile team. So as a tester, if you're working in any of the agile project, what are your roles and responsibilities, and what skills you need in order to succeed in any of the agile projects if you're working as a tester in an agile project. Now, the first thing is to have the skills, whatever skills you had, technical skills. As part of ISTQB Foundation Level syllabus, there were a couple of skills mentioned. You need to have all those skills anyways if you're working in any of the testing team. Plus, if you're working in an agile team, you need to be very competent in test automation, and that is because you would be doing a lot of automation in each and every iteration in agile project, and you cannot sustain the pace, or you cannot in agile project, because of the iteration, every sprint you'll be getting new features added on. So if you're not doing automation in each sprint, then it will be a big backlog, and you should be you'll be falling behind in terms of testing. So you should be competent in test automation. You should have knowledge of the test driven development approach, TDD, and acceptance test driven development approach. So we'll discuss these approaches in later tutorials. You should be good at white box testing if required. Usually white box testing will be done by developers, but just in case if it is needed as part of the test team, you should be aware and you should be knowledgeable in white box testing as well. And if you're good at automation, you will be able to do white box testing as well. You should be good in black box testing, which anyways, if you're working in the testing industry, you will be good at black box testing, and also experience based testing, along with this exploratory based. So you should be able to do exploratory testing in agile project to come up with any edge defects or any of the critical issues that cannot be found with the usual approaches that you take in the software testing. These are some of the technical skills that you're required. Then what are some of the behavioral skills? So behavioral skills that you require are that you need to have a good interpersonal skills, because in agile you have to communicate with your whole team on a daily basis. There will be a lot of communication with each other in the team, so good interpersonal skills are very important if you're working in any of the agile project. You should be self-organized, so nobody is going to guide you what you need to do. So you need to self-organize what needs to be done and ensure that the end quality of the product is good. You should be quality focused, so you should be having inputs, or you should be giving your inputs in each and every stages of the life cycle in the iteration. So from the design or even from the user story elaboration, or when the user stories are being pulled in the sprint, you should be asking a lot of questions based on your skills or testing skills, which will identify some of the hidden or some of the key issues that might have not been addressed in the user stories. So similarly, even in the design or development phases, you should be working with the developers and asking them questions around how you'll be testing it and what they are building. So there will be a lot of communication, so you should be quality focused and contributing in every phases of the agile development. You should be proactive to get up from your desk and walk to the other person's desk and ask the questions and clarify any doubts if you have. You should be solution driven. You should be very responsive if someone approaches you. You should be easily approachable and responsive in terms of whatever knowledge you have and whatever help you can do to for the whole team in order to succeed in the agile project. And you should be quick learner. So learning new skills is very important, because there will be a lot of pivoting in Agile, and you might be doing something and then suddenly there is a change of suddenly there is something new came up. So you should be able to learn quickly new technologies or new processes and implement that if required in any of the Agile projects. So these are some of the behavioral skills that are required if you're working in any of the Agile project. Now the next thing is, what are your roles in any of the Agile team. So if you're working as a tester, your roles are that you implement the test strategy and plan, you analyze and bring the best testing tool. So that's another part of it. So you have to first come up with the overall strategy and the plan, how you will be testing the whole product, as well as you should be analyzing the tools, the best suited tools. You should be able to configure and maintain test environments. So this might be you might be required to do this in some places, but at some places there is separate team to configure and maintain test environments. Then you should be able to mentor other team members. That's the key role of the Agile tester, that if there is someone who needs to upskill, or there is someone who joined new and you are subject matter expertise in that particular domain, you should be able to mentor the other team members to come up to the speed so that you all can succeed together. Then you should be able to plan testing during iterations. So during iteration, you should be able to plan what needs to be tested and do in sprint automation. So once you do the planning, you do in sprint automation in the sprint and do test execution and report any defects. So once you are done with the test automation, whatever can be automated, you run those automated test cases, and also any manual testing or exploratory testing that is required around those stories, you do those execution and report any defects that you have found. You should be actively collaborating with other team members to clarify any doubts or test coverage or any automation coverage that you have done. You should be actively participating in retrospective meetings. So retrospective meeting, if you're attending, you should be actively providing your feedback and inputs in those retrospective meetings, so that the whole team can learn from the feedback that you are providing. You should be providing feedback on progress and the test quality and coverage. So you should be proactive and have courage to say the actual progress and the quality and the coverage in the team. And the reason for that is, once you if you do not communicate the right situation in the project, then no one would know how the quality or the coverage of the product is. Then you should be setting up reports, dashboard and wiki for the stakeholder reporting. So that's reporting is another bit or another role that you need to perform in the Agile team. So you should be able to set up the dashboard for the stakeholders and also send the daily or weekly status reports from the dashboard itself to the stakeholder. Now, what risks are associated or test related organizational risks are there? So testers, because you are working as a tester in Agile, you are working very closely to the other team members. You might become tolerant on low quality and inefficient practices because you're very close to other people in the team. You might ignore if there is low quality or inefficient practices within the team. You might just ignore those, or you might become tolerant to those issues. The other issue that you might face is, or other risk you might have, is that keeping pace with excessive changes during sprints. So unless and until you implement a lot of automation, or you have automation around each and every most common sort of testing like unit, regression, unless and until you do automation around those parts, there will be excessive changes or excessive amount of work in upcoming sprints, and that will be a big risk to keep pace with that excessive amount of work or testing that will be there in the further sprints or iterations. Then you might lose objectivity due to closeness with developers. So that's another risk, that objectivity might get lost because you are very close to developers. And then improper iteration planning might overburden testers. So if the iteration planning is not done very well, it will overburden testers, and there'll be a lot of work in the iteration, and you won't be able to achieve what you are supposed to. There won't be automation around those stories that are taken in the iteration, and also manual testing that needs to be done around those stories won't be able to finish. And because of this improper iteration planning, there will be a lot of more work coming in further sprint, which you will be able to which you won't be able to cope up with. So these are some of the test related organizational risks. So in this tutorial we understood what is your role, what is your what skills you require as a tester to work in any agile project, and what are some of your roles in agile projects and some of the organizational risks. Thank you. In this ISTQB Agile Tester Certification tutorial, I'm going to talk about what is test-driven development and test-driven development lifecycle. So test-driven development became popular through extreme programming approach. So we have seen that there were a couple of agile development approach, and extreme programming was one of the approach, and test-driven development became popular from extreme programming. However, the test-driven development is being used in other agile development approaches as well, and you can use it in SCRUM or in Kanban, wherever you want. Your project wants, you can use test-driven development in the approaches, in other agile approaches. And even some of the sequential life cycle sequential methodologies like waterfall or V model, people used to, or projects used to use test-driven development approach as well. Now test-driven development approach helps developers focus on clearly defined expected results. The tests are automated and are used in continuous integration, and test-driven development is used to develop code guided by automated test cases. Now let's see what the approach is. So the test-driven development approach is you add the test cases before adding any functionality into your code. So before you actually, or before developer starts coding, you add the test cases. So as a part of the test team or in the agile development approach, once you join as a tester, your if your team is following the test-driven development approach, your role is to provide the test cases for the test-driven development approach and help the team to identify the test cases and the scenarios that need to be tested for the test development approach. So once the test cases are added, defined by you and the whole team, after that the developers start coding. And what they code is, they code so that they can make the test pass by adding the new code. Once they know that these are the test cases that needs to pass or need to be fulfilled by the code that they are developing, so they start coding to make those tests pass. And the third step is to refactor the code to pass the written test. So once they write the code, they run it. If there are failing tests, they again refactor the code, and unless all the test cases that are written in TDD approach are passed. Now TDD uses following processes. So if you the process is, you write a failing unit test, you make the unit test pass, and then repeat this whole process. So the test cases defined by you, they are the unit test before the actual development starts, and they'll be the failing test in the first instance. Once the developer starts coding, he'll start passing those unit tests, because there will be some code to fulfill the scenarios that has been written. And if there are some failing tests after the execution, he'll repeat the same refactor process until all the test cases that are defined in TDD approach are passed. Now let's see in the next slide the whole TDD process cycle. So you add the test cases, which are the unit test cases, and in agile projects, the whole team, so you mostly tester, identifies these test cases along with the whole team, and then the developer watches these tests that they are failing, and then he writes the code, runs the test again, and see how many tests are passed and how many are failed, and then he refactors the code until all the test cases are passed, and that cycle keeps going on. So there could be like new test cases again added within the cycle until all the test cases are passed. This cycle continues, adding code, refactoring the code, and adding new test cases. So this whole cycle keeps going on unless all the test cases are passed. Now that's the basic test driven development cycle. And what are the benefits of test driven development? That in TDD approach, the entire code is covered under the test, as code is written only after adding the test. So because you write the test cases first, so there is no code which is written any code that is written in TDD approach is upon the test cases. So you have the test case that is already there, and the code is written only to fulfill that particular test case or to pass particular test case. So there the coverage or the test coverage in TDD approach is very good, and then there are less defects because you start with the test cases first. So entire code is covered by the test cases or test scenarios. So final application eventually has less defects in test driven development approach. So in this tutorial we'll learn what test driven development is and what is the TDD cycle, test driven development cycle, and some of the benefits of test driven development. Thank you. Acceptance test driven development. In acceptance test driven development, you define acceptance criteria and test cases during the creation of user stories. So whenever the user stories are being created, defining of the acceptance criteria and the test cases, it is done during that definition. Now let's see what acceptance test driven development approach is. So first, in acceptance test driven development, whole development team and business stakeholders are involved. So like in test driven development approach, there was, if you're working in an agile project, there will be testing team developers involved to define those test cases or unit test cases. However, in acceptance test driven development, it's the responsibility of the whole team along with the business stakeholders to define the test cases or the acceptance criteria. So the whole team involvement is required in acceptance test driven development approach. Now first thing that is done is it is discussed what is required by the end user. So once there are stakeholders and other product owners, it is discussed that what is required by the end user, and then user stories are created with those acceptance criteria. So there will be a lot of questions in while defining those user stories, which will basically define what exactly is required by the end user or the customer, and those requirements are defined as the acceptance criteria from the in the user stories. Then the developer first writes test for those acceptance criteria. Now in acceptance test driven development approach, during that definition of the story itself, so developer and tester or the whole team defines or writes the test cases for the acceptance criteria. So once the test cases are written, and then developer writes the code to make that particular test case pass. So that once the test case is defined, acceptance criteria is defined, test case is defined from that acceptance criteria, and then developer writes the test for that acceptance criteria or for the test cases defined for that particular acceptance criteria, and then developer writes the code to make those test cases pass. And until all the test cases defined for the acceptance criteria pass, the developer refactors the code until the last test case is passed. So this is the overall test driven development or acceptance test driven development approach. Now, what are the benefits of having acceptance test driven development? So in test driven development approach, we have seen that there were many benefits. Acceptance test driven development is built on top of test driven development, which includes business stakeholders and end customer perspective in the picture as well, rather than just having the unit test cases being documented and automated like in test driven development. So the benefits of acceptance test driven development are more as compared to the test driven development, and the benefits are that acceptance criteria and test cases are defined during story creation. So that's the first benefit, that when you're creating the user story, you have the acceptance criteria already defined and test cases already defined, which have been agreed by the whole team in the agile development approach. Then acceptance criteria helps testers to easily identify the testing required. Now once you have acceptance criteria defined, then this acceptance criteria helps the testers what test cases need to be defined for each of those acceptance criteria, and that helps the testing team to identify those test cases from the acceptance criteria. Then it helps developers to write accurate unit tests which focuses on business needs. So once the testers know the acceptance criteria, they define the testing required, they define their test cases, and then they also help the developers to identify the right right set of unit test cases based on the business needs. So it's a collaborative effort in agile development methodology. So it's a tester works closely with developers to define the unit test against those acceptance criteria. Then acceptance test driven development quickly determines if acceptance criteria has been met or not. So once the developer is using those test cases, they are based on the acceptance criteria defined in the user stories. He also looks at the test cases defined by the tester, the functional test cases, and he tries to make sure that that those particular test cases or the acceptance criteria is met by the code that is developing. And because of this, you can easily determine whether the acceptance criteria has been met or not. Then in acceptance test driven development, you have less defects, which means that entire code is written or driven by the acceptance criteria or the acceptance or the test cases defined from those acceptance criteria, which reduces the number of defects in the end product. So these are some of the benefits of acceptance test driven development approach. Thank you. In this ISTQB Agile Tester Certification tutorial, I'm going to talk about behavior-driven development. Now, behavior-driven development approach is very similar to test-driven development approach. The only difference is that in test-driven development, you have you define the test cases at the unit test level. In behavior-driven development, it's more of at the user-focused or the application behavior level. So there are a lot of comparisons that you can do between TDD and BDD. The difference is the way the test cases are written, and there is some difference in the process how those test cases are implemented. Now in BDD, test cases are written in plain English language, and these test cases are very easy to understand for non-technical users or business users as well. So anyone who will be reading the BDD test cases will be able to understand what functionality is expected from that particular product or that particular application. Now tests in BDD are more user focused or customer focused and aim at explaining the application behavior. So test cases in BDD explain how the application should behave once it is implemented. Test cases in BDD use examples to clarify requirements. So there are multiple examples that are defined in BDD test cases to clarify the requirement around those test cases. Then BDD approach is driven by business value. So any test cases or any user story or scenario that is defined in behavioral driven development has to have some business value. There you shouldn't be building, or you won't be building anything in BDD approach that doesn't have any business value. So first thing is, whatever you're doing or whatever you're building, whatever you're writing in BDD approach, does it have any business value? And then you define a user story, acceptance criteria, and the test cases around that in BDD approach. Now BDD frameworks, there are many BDD framework, but BDD framework define acceptance criteria based on given, when, then format. So BDD framework can be implemented with many tools out in the market. So you have tools in Java which support that, you have tools in Ruby, Python. So there are different flavors or different technologies that have used the BDD framework which defines the acceptance criteria in given, when, then format, and helps the developers to write the code and testers to automate that code or the test cases using BDD approach. Now what in the next slide we'll see what a sample user story template. So if you see here, the user story in BDD approach starts with like, as certain type of user, I want some goal, so that some reason. So the example of that would be, so for example, you are writing a user story for enrolling to my courses in the training portal. So you will write, as a RCV Academy user, I want to enroll in ISTQB Agile training so that I can watch my training modules. So you have a user here, so type of user. So as a RCV Academy user, I want to enroll, you are doing something, you want to perform some action so that you can have some benefit, so that you can watch your training modules. So this is a sample user story example. Now in that user story you can have multiple scenarios. So scenarios start with the keywords like given, when, then, and and, but, etc. So there are many keywords defined in the Gherkin language that can be used to define the scenarios in the user story. So we won't get into more details of that Gherkin language and the keywords. As of now, you just need to understand the scenario will have the keywords like given, when, then, and there could be multiple scenarios within the user story. So scenario could be something like, given I am on the RCV Academy online training portal, when I try to log in using my email and password, then I should be redirected to training portal homepage. So that's the first scenario that could be that is possible in the particular user story. Second scenario could be when you are on the home page, given you are on the RCV Academy training portal homepage, when you try to enroll or when you try to click on the ISTQB Agile training link, then you should be able to you should be redirected to the ISTQB Agile training page. So that's another scenario that will form the basis of your test case as a tester and for the developer as well. And that these are all the scenarios that are defined in the user story and form the acceptance criteria for the user story. So there is always a business context in acceptance test driven in behavioral driven development approach. Now, what is the approach? So what are the steps in behavioral driven development approach? So BDD begins with user story to identify scenarios which must be fulfilled by the software. So BDD approach, it begins with the user story. So you define a user story, and within that user story you have a lot of scenarios which must be fulfilled as part of that particular user story. Now testers, once they get that user story, they validate or they write tests to validate those acceptance criteria or to validate those behavior or the scenarios that have been defined in the user story, and write the test cases around that. Then developer in the BDD environment has to implement code in order to make sure that those test cases pass. The third step is that developer goes through the user stories, goes through the scenarios that have been defined in the user story, and then he ensures that all the scenarios have been met or being addressed by the code that he has developed. Along with this, developer also goes through the scenarios or the test cases that testers have defined from those scenarios and ensures that all those test cases or edge cases defined by the testing team have also been met. Then developer refactors code until all the test cases that have been defined by the developer and the tester are passed. So this is the whole cycle. The cycle is almost, or the approach is almost similar. You define the test cases, and then developer writes the code in order to pass or fulfill the scenarios and the test cases defined in the user story, and refactors the code until all the test cases are passed. The approach is almost similar to TDD and acceptance test driven development. The difference is that there is a lot of focus on the customer and how the software or the application should behave, and focus on the business value. So if there is business value, then there will be user story defined and test case defined. Otherwise, in BDD approach, you do not work or define any user story or requirement if there is no business value or business outcome for that particular requirement. So that's all about behavioral driven development approach. Thank you. In this tutorial, we are going to learn about the test pyramid. Now, your software can be tested at different levels or different test levels, and this test pyramid is used to illustrate different test levels at which the software can be tested. And in the ISTQB Foundation Level syllabus, you would have already understood the different test levels, which are unit, integration, system, and acceptance testing. So these are the different test levels, and the test pyramid is used to illustrate these test levels at which you can do software testing. And what this test pyramid says is that you should be testing from the base of the pyramid to the top, and it is based on the principle of early testing. So let's see what exactly the test pyramid talks about. So if you see here in this diagram, you have the pyramid, you have a sort of pyramid, and then you have a unit testing level, then integration, system, and acceptance. And as you move further or move at the top of the pyramid, you will see the amount of test cases phases should be less. So the majority of your testing should be done in the unit and integration phases rather than pushing it further to the system and acceptance testing phases. So that's the principle which early testing says, that you should be doing majority of your testing early in the software development life cycle rather than pushing it further to the later phases. So test pyramid represents having more testing at the lower levels, which is unit and integration levels, and lower levels are often automated using the API based tool. So the web service automation or web service testing is required when you are following the test pyramid or early testing principle. So you should be doing a lot of web services based testing in the lower phases or lower part of the pyramid. So unit testing and integration should be done through the API based tools, and high level are automated using the GUI based tools. So once you come to the system and acceptance testing phase, there will be a graphical user interface, so you should be using any of the automated tool like Selenium or any of the GUI based tool to automate those scenarios and test the application. Now this test pyramid is only applicable for the dynamic testing. So once you are in the dynamic testing phase, you should be relying on the test pyramid principle or early testing principle. Then defects found at later stages are more costly to fix. So that's the known fact that in the testing life cycle, once the defect is found in the later phases, for example acceptance, it will be more costly to fix rather than the defect that is found in the unit testing. And that's the whole purpose of having this test pyramid and showing that your majority of your testing should be in the unit testing, then integration, then system, and then acceptance. So acceptance testing should be the minimal amount of testing which should just ensure to the end user or the customer that the function or the functionality delivered in the software fulfills the acceptance criteria that the customer or defined by the stakeholder. So that's all about the test pyramid. Thank you. In this ISTQB Agile Tester Certification tutorial, we are going to talk about Agile testing quadrants, test levels, and testing types. So testing quadrants were introduced by Brian Merrick, and these testing quadrants bring more clarity between the test levels and the appropriate test types done between those test levels. Now, as we have seen in previous tutorial, that there are 4 main test levels: unit, integration, system, and acceptance. So these testing quadrants bring clarity between those test level and the testing type that is done within those test level. The 4 quadrants reflect the reason why do you actually do testing. These testing quadrants are applicable only for dynamic testing and not for the static testing. So you have to keep that in mind for ISTQB exam. That might be one of the questions, that for which type of testing quadrant is applicable, whether it's applicable for the dynamic testing or static testing. So yeah, testing quadrant is applicable only for the dynamic testing. Testing quadrant help you to ensure that all the important test type and test levels are included in the development lifecycle. So in agile development, you have iterations, and in the iteration you do all sort of testing. So these testing quadrant help you to ensure that all the necessary test levels and the testing type is done in that particular iteration or the cycle. Testing type could be, or the type of the test cases in these quadrants could be business facing or technology facing. They could be manual, automated, or mix of manual and automated test cases. Now let's see in the next slide how the testing quadrant is defined, how it looks like, and what are the key key test levels and types of testing in the testing quadrant. So as you can see in this image, there are 4 quadrants: Q1, Q2, Q3, and Q4. These quadrants are defined just for the numbering purpose, and these does not signify that this is the sequence in which you should be doing testing. So quadrant 1 or Q1 is unit level, technology facing, and supports the developers. Quadrant 1 contains unit and component tests. Unit tests are used to analyze and define software behavior and are written before the code is produced. Q1 tests should be mostly automated and included in the continuous integration process. Any of the Q1 test cases should be included in a continuous integration process, because otherwise, if you're not automating, that backlog will keep increasing in the further iterations in agile development, and you will be able to you won't be able to cope up in future iterations. Quadrant 2 is system level. That's the another level, and it is business facing and confirms the product behavior. This quadrant contains functional test cases, story test cases, examples, prototypes or simulations, and these tests check the acceptance criteria defined in the stories and during the story development, and that is why these test cases improve the quality of the stories or the delivery of the stories that you do from the quadrant 2. Now these test cases are useful when creating automated regression test suites, and Q2 includes automated as well as manual test cases. So now as far as you can automate, you should be automating the test cases in the quadrant 2 because they are functional test cases and system test cases, so you should be automating majority of the test cases in Q2 as well. Now Q3 is user acceptance level. It is system or user acceptance level. It is business facing and contains the test cases that critique the product, and this quadrant uses realistic scenarios and data, mostly the end user, how the end user will interact with the system or how the customer wants the product to behave. So mostly either end user or the customer will be involved in the quadrant 3 testing. This quadrant contains exploratory testing, and it contains the scenarios or process flows, usability testing, user acceptance testing, and also alpha and beta testing are part of the quadrant 3. Because quadrant 3 is mostly user scenarios or end-to-end scenarios that will be performed on the software, most of the testing in quadrant 3 is manual, and there is very less automation in quadrant 3. So there could be automation possible in quadrant 3 as well, but most of the quadrant 3 test cases is manual. Now quadrant 4 is again technology facing and contains tests that critique the product. Now quadrant 4 test cases are basically to help the quality of the product, and these test cases are system or operational acceptance level, and these test cases could be performance, load test, security testing, and any of the utility testing, which is like compatibility, scalability, maintainability, interoperability. So any of these sort of testing which help to make sure the quality of your product is good, performance is good, and the product is scalable, those sort of testing come into the quadrant 4. Now during any given iteration in your agile development, tests from all the quadrants could be executed, or from some quadrants could be executed. So now by seeing this quadrant and understanding this quadrant, depending on where you are in your agile development life cycle, you should be able to figure out whether you need test cases from particular from one or two quadrants, or you need test cases from all of the quadrants to be included in that particular iteration. So this agile testing quadrant is very important if you're working in agile software development project, to ensure that all the necessary test levels and the test types are being captured and you are tracking properly for all the test level and testing types for the product that you are testing. For ISTQB certification level, you have to ensure, or for certification purpose, you have to ensure that you understand these agile testing quadrants, the levels and the testing within these levels thoroughly before you appear for the exam. Thank you. In this tutorial, we are going to learn about the role and activities of a tester in any of the agile development projects. So if you're working in any of the agile development methodologies like SCRUM, Kanban, or extreme programming, you need to have these skill set that we will be discussing in this tutorial, and perform the roles and activities that are discussed in this tutorial. So there might be more activities or more set of responsibilities, but this tutorial will have mostly all of the common roles and responsibilities that an agile tester needs to have to work in any of the agile development methodology. So for this tutorial, I'm going to take an example of the Scrum development methodology and see what are the activities or roles or key skills that are required by a tester in any of the agile development project. So let's see what those roles and activities are. So the first thing is the teamwork. Teamwork is the fundamental principle of agile development, and agile emphasizes the whole team approach, which means means that the developers, testers, and business representatives, they all work together, and it doesn't matter what the composition of the team is. Everyone in the team is responsible for the quality and delivery of the project. Now, from the tester's perspective, successful Scrum projects will require the teams to have to be, like the cross-functional teams to be empowered, co-located, collaborative, committed, transparent, credible, open to feedback, and resilient. So let's understand a brief about all of these terms. First, so cross-functional, as we have discussed in the previous tutorials as well, the team in Agile should be cross-functional, which means there should be people, or the composition of the team should be that people from different skill come together to solve a problem, or to solve a problem and deliver the actual product or the solution to the customer or the end user. The second thing is the team should be empowered. There shouldn't be any micromanagement. The team should be self-organized and should be delivering what they commit in the timely fashion, and there shouldn't be any micromanagement within the team, because Agile is more about the self-organized and self-managing team. So the team should be empowered to make their own decision and deliver what they commit in the sprint and within the sprint and the release. Co-location is another important aspect. So the team should be co-located to have better collaboration and communication within each member of the team. And as a tester, because you will be communicating a lot with the developer and business stakeholders to clarify the doubts and queries, so co-location is another important aspect of the Agile development approach. The next thing is collaborative. The team or the tester should be having a lot of collaboration with other team members, which involves having a communication with the peer tester or developer or the business stakeholder to clarify any of the gaps, or to ensure that whatever you are doing in the team or the work that you are doing is transparent and visible to others, and everyone has confidence of the quality that you all will be delivering by the end of the iteration, by end of the release. The team should be committed, or you should, if you're working as a tester, you should be committed, or everyone in the team should be committed to the delivery, and you should be delivering whatever is committed within the specified timeline. There should be transparency, and that's where the physical boards come in picture, like Scrum board, wherein you have all the tasks visible, who is working on what in that particular sprint, and that's pretty much visible on the physical board as well as on the software board, which could be a Jira board, a Jira Scrum board that you define, and everyone will be able to see what activities the other team members are working, and there'll be a lot of transparency across the team to see how the team is progressing in that particular iteration and the overall release. The team should be credible, that if you're working as a tester or developer in the team, you should be credible enough to deliver what you have committed within the specified timeline. You should be open to feedback. So if there is any feedback provided to you, you should be open to it in a positive manner and incorporate the feedback in a positive way and deliver or improve based on that particular feedback in upcoming iteration. You should be resilient to the changes. So if there are any changes within the next iteration based on the feedback from the stakeholders, etc. So you should be resilient enough to commence with the new changes or come up with the new tools and techniques in the upcoming iterations. So these are some of the key aspects of a tester or any member in an agile software development project. Now the next thing is around the role or activities that you will be doing as a tester in sprint 0. So sprint 0 of any of the agile project or Scrum is the sprint wherein you do all of the preparation work or define all of the initial stuff that you need before you actually start working on the product development. Now in sprint 0, as the tester, you will be identifying the overall project scope, you will be specifying the definition of done, you will be helping helping with your insights as a tester in the definition, in defining the definition of done for the sprint, for your particular iteration, for the release, etc. So you'll be providing a lot of inputs from the testing perspective to define that definition of done. You will be creating the task board and the project dashboard. So you could also be involved in creating the dashboard or project dashboard as well. So many places I have seen that if you're working as a tester, it's mostly helpful to provide your own insight to help in creating the dashboard, or if you have skill set of managing the Jira software or any of the agile development softwares, then you can also define the task board and project dashboard and provide your insights to have the right set of statistics displayed on the dashboard and task board. Then you will be also identifying procedure and setup tools for the test management, defect management, and automation and the other testing activities. So that's also part of the sprint 0 activity, that you will be identifying what process you will be following, what tools you will be using for the defect management, for the test management, and for the automation in your sprint. You will be defining test metrics as well. You will be defining the criteria to start and exit testing, which is basically nothing but the definition of done. So you'll be defining the definition of done for entering the sprint or exiting the sprint, and then exiting the or basically completing or saying the story has been done. So there will be a lot of criteria defined for at the story level, at the iteration level, and that will be defined in the sprint 0. Then you will also undertake quality risk analysis in the sprint 0. So these are some of the activities that you will be performing as a tester in sprint 0. There could be more activities depending on what your project requirements are and how big the project is. There could be more or less activities in the sprint 0 for a tester. The next thing is the integration. So when you start working in the agile development environment, there is no phased approach. So it's basically iteration by iteration or sprint by sprint development, and the product is built incrementally. So there is a basic level of development that starts, and then in the next iteration, next sprint, there is an incremental build that happens on top of what has been built in the previous sprint. Now, because of this incremental approach, there is an integration requirement, or there is a lot of integration that happens in each and every upcoming sprints. Now, as a tester, you need to have you need to define the integration strategy in order to identify that what all dependencies are there. So as a tester, you will analyze the whole architecture and see how the development is happening, what components have been built, and what is still missing. So that integration strategy has to be defined by you. So that will give you a clear picture of what the end result should be and how the delivery is happening, what components have been built, and what needs to be built further to enable the overall product delivery. And this integration strategy helps in continuous testing and delivery of the customer value. Because of this integration strategy that you define, that in sprint 1 these are the components that will be delivered, and in sprint 2 there will be more components built on top of these existing components that were built in the previous sprint, and how those integration points will be made between the work that is done in sprint 1 and sprint 2. All these things need to be defined in the integration strategy, and as a tester you will be the best person to define this strategy, because this will help you to ensure that you are doing the right level of integration testing in particular sprint and in the upcoming sprint when the product development or the new iteration keep building incremental product. And because of this integration strategy, there is a lot of demand for the automation activities. So any work that you will be doing in the current sprint need to be automated, so that in next sprint when there is new integration coming in picture, the existing integration that has been done, if that can be tested mostly by the automation, that will reduce a lot of amount of work in the upcoming sprint. So that's where as a tester you need to provide a lot of insights around the integration strategy. Now the next big thing that you need to do as a tester is the test planning, which is the default activity, if you're working in any of the project as a tester, you need to define what the scope is, what is the extent of testing that is required for the story within the sprint to complete the iteration, and what are the goals that you want to achieve. Then you need to define what test environment details, what test data requirement is, and what tools are required for you to perform that the testing for the whole project and deliver it successfully and with quality. Then you will be defining what test date and what the start and end date is, which is basically nothing. So all these activities are the whole planning activity. So you'll be defining the start and end date. You will be defining what test methods, what techniques and tools you will be using to test that whole product within the iteration and across the life cycle. Then you'll be defining any risks and dependencies, if there are any, that will be defined in the plan as well. There'll be product and project risks that will be defined, and then you'll be defining any mitigation plan for those risks. The risk will be prioritized, and based on the priority of the risk, you will be deciding which test cases need to be executed in what priority order to mitigate those risks. So test planning is another major activity that you need to perform as a tester in any of the agile project. The next thing is there are some practices that you need to follow as an agile tester. So agile tester role includes utilizing various agile practices, which is like pair programming, incremental test design, mind mapping, and etc. So pairing basically comes from the extreme programming and can be used in any of the agile development activities. So in Scrum as well, pairing is very helpful, and if you work with your peer testers, with the developers, and with business stakeholders on a regular basis, and you communicate and collaborate with them, it resolves a lot of the quality issues upfront before it actually goes into the code and it comes as a defect in the actual testing. So that's where pairing is very important. Testers sit together with other team members on one workstation and performs the task. So as a tester, you can sit with the developer to guide him what unit test he need to include, or if there is any gap in the unit testing that he is doing. Also, you can test with the peer tester to automate the test cases in this particular sprint. Then you can sit with developer to review your automation scripts. You can also sit with the testers to cross skill. So for example, one tester is working on module A and you're working on module B. You both can sit together to cross skill different modules and have everyone in the team on the same page. The next activity or practice that you need to implement is the incremental test design. So as in agile development methodology, there is an incremental product development happening in each sprint. So in sprint 1 will have a little amount of work that will be done, and then sprint 2 will be building incremental on top of it. So similarly, the testing team or as a tester, you should be building your test cases incrementally. So test cases will be built gradually from the user stories, and testers should start from the simple test cases and then move towards the complex test design. And incremental test design could be top down or bottom up. So for example, you can start from the top level model and then have the stubs below it, and could start with the test cases in the top down approach, or in the bottom up approach you can have the development happening from the bottom level modules and then integration happening until the top. So these are the two approaches that you could take as a test designer. Usually these approaches are followed by the development team, and based on what they are following, you can follow your test design approach accordingly to have the test case or test suite built incrementally in the upcoming iterations. And the last thing is the mind mapping. So mind map is the graphical representation of idea or concept. So testers, as a tester in an agile project, you should utilize mind mapping technique to record mind mapping tool to record any of the discussion. And because it represents the idea or concept graphically, it becomes really easy to visualize when you have this graphical representation of idea in front of you. It helps you to analyze the requirement. It helps you to come up with a better test design and test planning, and measure the test coverage based on that graphical representation. And this mind mapping helps in better test planning and also traceability and monitoring the overall test progress. So mind mapping is also very important aspect within the Agile project. So these were some of the key roles and activities that you need as a tester in any of the Agile development project. Thank you. In this ISTQB Agile Tester Certification tutorial, we will discuss about assessing quality risks in Agile project. So risk analysis is common across all the projects. It doesn't matter which type of project you are working, or even if you have worked in the old development methodologies like waterfall and V model, we used to do a lot of risk analysis in those as well. So it's kind of similar in Agile project as well. The risk analysis is same. It's basically at what point in the project you do that is a bit different, and that's what we are going to discuss, where you do the quality risk analysis in Agile project and what are the actions that you take to mitigate those risks and categorize those risks. So before we go further, let's understand what a risk is and what the risk likelihood and impact means. So risk is any factor that may create a negative outcome. So for example, risk is something which might not occur at all. Say you are working in an e-commerce project. One of the risks could be that the whole portal getting down, right? You don't have the high availability setup and your web server got crashed and you are not able to access the e-commerce portal, and that impacts the overall sale of your e-commerce store. That's sort of risk. If it became an outcome, then it's a lot of impact on the business. So risk is something which might create a negative outcomes. For example, server getting crashed. Now it might not happen at all, but if in case it happens, what is the likelihood of that particular risk to occur, and if it occurs, what's the impact, right? So that's risk is something which can create a negative outcome, and the level of risk is identified by the likelihood and impact. Say same example like e-commerce. Say for example, you're taking an example of the Amazon e-commerce store. Now you can imagine if the likelihood of getting Amazon e-commerce store down or crashing is high or very high, you can imagine the impact of the sales that it could have in just 10 minutes downtime. So with that impact, you can analyze how big the risk is, right? Or how what should be the category of the risk. So if it is a huge impact on the business, then it's categorized as very high or critical risk. And if it is a less impact on the business, or if it is something which might occur, like after hours, and it can be taken care in by the next day, then that is something that can be categorized as medium or low. So risks are identified by categorizing them into the likelihood and the impact of the occurrence. Now if the risk impacts the project success, it is categorized as the project risk. For example, team members leaving the company. So what is the impact on the project delivery or the timeline? That could be one of the project risks. But if it is a quality risk on the product, for example, performance, your product is not meeting the performance, your website is not giving you the response that you are asked for. So for example, a person comes on your e-commerce store and he's not able to add the product in the cart in like less than 2 seconds, then he'll just abandon the cart and go away. So that's sort of product quality risk or the product risk. And typical objective of testing is to reduce the product or quality risk to an acceptable level. So that's the major objective of testing, that you reduce the quality risk to an acceptable level so that stakeholders then can make decision to release the product in the market or to not release the product in the market. So unless and until the quality risk is in the acceptable level, product won't be released in the market. Now in Agile project, quality risk analysis is done in 2 places. First is when you are doing the release planning, and second is when you are doing the iteration planning. Now in release planning, the business representative may provide an overview of the features that will be included in the release and any perceived risk associated with them. Along with the business stakeholder, development team and testing team will contribute to the discussion and come up with the details of the risk and identify what further things need to be done to categorize the likelihood and the impact if that particular risk occurs. So that's what happens in the release planning phase. Now in iteration planning, it is more detail level, and in the iteration planning you do the estimate, you do the tasks for the story, and you do the estimate for the task as well. Now in the iteration planning, for each task or for each story, the risks are being discussed in a detailed manner, and the whole team discusses the risk and what is the impact or likelihood if that particular risk happens or occurs. And based on that risk, the overall test design and the level of testing that needs to be done for that particular story or task is defined, so that the risk comes to an acceptable level. Now let's see what the quality risk analysis life cycle is. So the first thing that you do in quality risk analysis is to identify the quality risks. Then the second thing is analyze the risk, and third is define the test. So that's the overall cycle of quality risk analysis. Now in identifying the quality risk analysis, the whole team meets to identify the quality risk analysis, which includes business stakeholders as well as the whole development team. And in the current iteration backlog, items are displayed, and everyone goes through the item and discusses the item, the quality characteristics, and any of the risks that could happen for those tasks that are defined that are discussed in that particular iteration backlog. Now the second step is to analyze each of the risks. So for example, you have discussed all the risks in the iteration, then all those risks are analyzed for the likelihood and impact, and they are categorized into the product, project, or business or technical risks, and based on the category and likelihood and impact, whether they'll materialize, the level of impact, they are categorized as high, medium, low. And once they are categorized in different categories, then the test cases are defined to mitigate those risks. So the team determines the extent of testing that is required for the level of risk, right? So if there is a product risk that has been identified that could have a massive impact on the business if it is an outcome, then you will provide or you will do a lot of testing around that particular area. For example, performance or the response time for the website should be less than 2 seconds, right? If it is like more than 2 seconds, user will lose the interest and they'll abandon the website and they will never come back. So if that's the massive risk for your business, then you will put a lot of effort on testing that particular functionality to ensure that the response time, it doesn't matter what the situation is, how many customers are there concurrently. So considering you have defined your non-functional requirement accurately, it should respond within that specified time frame or less than 2 seconds to the customer. So these test cases are defined based on the risk, likelihood, and impact. So this is the overall quality risk analysis cycle. Now, what are some of the quality risk examples, right? So we'll take some of the examples that are there for the quality risk. For example, the first one is slow application response to user, which is very common across all the applications that you see nowadays. So any of the applications or the successful companies that you see nowadays, like Gmail, Amazon, Twitter, Facebook, have you seen, there are so many millions of users hitting that particular portal at a time, but still the response time is always less than 1 second or not more than 1 second. So if this response time becomes 10 seconds, no one would even bother to open that particular portal. They'll abandon and they'll not come back, because it's not a good user experience. That user is just waiting for the application to load. So slow application response is one of the major quality risks in current market scenario. Then the second thing is incorrect calculation in shopping carts. So for example, you are on a particular website or particular e-commerce portal and you are purchasing some of the products, and you come up to the shopping cart and you saw the calculation of the total is not correct. So that is the major risk or quality risk as well, because it questions the credibility of the organization that they didn't even bother to check the calculation logic of the shopping cart. So people will not come back to the portal. The next quality risk is system crashes after a certain amount of time. So that's another performance or non-functional requirement that that is possible, that your system crashes after a certain amount of time, and that's another major quality risk. Whether the system is recoverable, so system recoverability is another quality risk. Is the system able to recover from software or hardware failure? So in case the system fails, whether your system is able to recover from the failure or not. Then whether the software works correctly on all the platforms. So nowadays there are so many platforms: Linux, Windows, Mac OS, and there are so many different flavors of Linux and Windows server and etc. If you are launching your software to be supported on just one particular platform, that won't be a good approach, because you'll be losing a lot of market, which a lot of segment in the market which is using another platform. So that's another major quality risk, whether your application or your software that you're delivering, whether it supports other platforms or not. Similarly for the apps nowadays, whether your app is supported on iOS and Android as well, or if it just works on the iOS applications. So that's another quality risk that is possible. The next thing is web application doesn't load on all supported browsers. That's another major quality risk. If your application is the web-based application, you should be testing it across all the multiple browsers available there and which are being used widely, like Internet Explorer, Chrome, and Firefox. So whether your application works properly on all these applications or not, that's the main that's another important thing that you need to make sure in the quality risk as well. So these are some of the key quality risks that you need to remember, and make sure that you memorize all the quality risks that could be possible. What are the risks, what is the quality risk analysis cycle, etc., before you actually go for the ISTQB Agile Tester Certification exam. Thank you. In this tutorial, we are going to learn about the estimation technique used in Agile project and how you can do estimation based on the content and risk of the story that will be that has been discussed within the team. So the estimation technique that is very commonly used in Agile project is planning poker, and this is the most common estimation technique used in Agile projects nowadays. And the values for the estimation, so there are planning poker cards with values like 0, 1, 2, 3, 5, 8, 13, 20, 40, and 100. And you could also use t-shirt sizes ranging from extra small to extra large. So these are some of the techniques. So you can use planning poker cards or the t-shirt sizes ranging from extra small to extra large, stating that this is very small story or this could be very large story. Then planning poker is the recommended method in any of the Agile project estimation. So let's see what planning poker is, how it is played, and how it is very helpful in estimating any of the stories in Agile projects. So planning poker, here is the process of planning poker. So you select the user story, then you discuss the story detail. Everyone in the team estimates that particular story, and then everyone shows the card, and then you come on the consensus. So in this whole process, what happens is everyone in the team, so whole development team including developer, tester, architects, so the whole development team sits together in a meeting room, and the stories are picked up one by one. So in the iteration planning, you pick the story one by one, and the story is being discussed. You discuss the acceptance criteria in the story, you clarify all the doubts, the risks associated with the story are being discussed, categorized, and then once all that discussion happens, the tasking happens. Then after the discussion, everyone in the team either will be having the cards with sizes ranging from extra small to extra large, or you will have the planning poker card which will have that number. Now after the discussion, everyone in the team will be asked to provide their estimate, and these estimates won't be disclosed until so these estimates will be your own individual estimate, and you won't be discussing with any of the members sitting in that particular room. So once you do the estimation, there'll be everyone is finished with the estimation, there will be you'll be asked to show your card. So everyone will be showing their card at the same time. And then if everyone has estimated the story as extra small, or there is consensus across the whole team, then that is what the estimate for that particular story is. Usually that's very rare and doesn't happen. So in that case, the person who estimated the story as lowest and the person who estimated story as the highest story points is asked to justify why they estimated the lowest and why the other person estimated the highest. And then based on those discussions or justifications, the other team member or these two team member will come up to consensus. If not, then there will be more discussion within the story for the story, and then re-estimation with this planning poker can happen again until everyone in the team reaches to a consensus that this is what should be the story point for the particular story. Now this is the usual estimation process in the Agile project. Now what is the benefit of whole team estimation? Now because you are using planning poker or other estimation technique in Agile project, because whole team is involved, so developer, tester and everyone other, even if required business stakeholders could also be there. So because of the whole team involvement, the story discussion during planning clarifies all the doubts and open questions. So if there are any open questions, then they are also discussed and clarified. Whole team comes to a common understanding. Now there is a lot of discussion, tasking happens, subtasks are created, risks are discussed. So everyone in the team is aware what task and what level of risk, what is the complexity of the stories, how the story will be implemented, what is the design around that. So high level everything is being discussed within that particular team, and whole team comes to a common understanding of that particular user story. Then higher estimates show that the story is complex. So if everyone in the team has estimated that this story is really large story, or everyone estimated as 20 story points for a particular story, then that means that user story is a complex one and needs to be broken into smaller user stories so that you can fit it into the sprint and finish it into the sprint. And that's the whole idea of agile development, that you should be able to or you should have a user story in up to a level that you can finish within that particular iteration and don't need to drag it to the further iteration. Then this whole team estimation approach also brings together multiple expert opinions. So everyone in the team who say for example you have a couple of subject matter expertise in that their particular domain or functionalities, this planning or estimation technique brings together the expert opinion and clarifies a lot of doubts upfront. And cross-functional team is best suited for the estimation. So for estimation, cross-functional team is the best suited team for doing the estimation. So if you have SMEs from the business, they could be part of the agile project team, and you have the solution architect, you have business analyst and developer and tester. So everyone working together and doing the estimation, it brings a lot of clarity to the solution and to the actual implementation of that particular user story. And this is the best suited for the estimation. This is the best suited configuration of team for any of the estimation for the work in the agile project. So this is so in this tutorial we discussed what is the estimation technique used in agile project. So planning poker is very common one, and what are some of the benefits of the whole team estimation. Thank you. In this tutorial, we are going to learn about the relevant topics that need to be covered in acceptance criteria defined for any user story in Agile project. Now, during each iteration, developers create code which implements the functions and features described in user stories. Now, these user stories code is verified and validated via acceptance testing. Now, acceptance testing is done to validate whether the code that is being developed by developer, whether it meets the requirements or not. And to be able to do acceptance testing, the story should be testable. and how the story will be testable when there is an acceptance criteria which basically says what need to be tested or what that functionality should look like in terms of functional or non-functional behavior. Now let's see what these topics are that need to be defined in the acceptance criteria of any story. So the first thing is that the functional behavior should be mentioned in the acceptance criteria. What this means is, what exactly does the system do? So for example, if you're working on an e-commerce project, what functionality are you looking for? So one functionality could be add item in the cart, remove item in the cart, right? So there could be many user stories defined. So what functionality you are looking for as part of that particular story? So there could be just one story just to define the functionality of adding and removing the item from the cart, right? So that is the functional behavior of adding or removing item in the cart. So that should be defined in the acceptance criteria. What exactly you want your system to do? Or if you're working in any other, say for example, a banking project, and you're working on some internet banking application, then what functionality you want in your internet banking application? Should the user be allowed to change his address? Should he be allowed to fund transfer within his accounts or external accounts? So all these functionalities should be defined in the acceptance criteria or the story that is being worked upon. Now functional behavior should be defined. The next thing that should be defined is the quality characteristic, how the system performs the specified behavior. Now the characteristics may be quality attributes or non-functional attributes like the performance or reliability or usability. For example, if you are launching an application, how much time it takes to load. You should clearly define that time, how much time or what is the response time you're looking for in the acceptance criteria as well. So quality characteristics need to be defined, the reliability, usability, response time, how many concurrent user it should support. All these things should be defined in the acceptance criteria of the user story. The next thing is scenarios or the use cases. So how the end user is going to interact with the application or the sequence of actions performed by the end user to accomplish the desired output. So this has to be defined in different scenarios. So any user story, you could have multiple scenarios defined, which will be in terms of end user interacting with that particular application and what he should be, what he is expecting as the desired outcome. So that those scenarios should be mentioned in the user stories as well. The next thing is the business rules. So what internal system rules performed based on the external inputs, right? So for example, you are providing certain inputs from the UI, then after submission what rules are happening in the background, and then what response is presented to the user. All these business rules need to be defined in the user story as well. And these business rules are very important because end user is not aware of all the business rules that are happening. So for example, your credit decisioning, or when you are applying for any loan or credit card, there is a background process that happens when you submit an application with all your detail and income. So that credit decisioning, there are engines, there are rules, and all these business rules are defined in the background. And once you submit the application, all these rules are triggered automatically and you are presented with the outcome, whether your application has been approved or declined. So these business rules or the background business rules based on the input provided, these business rules should be also clearly defined in the acceptance criteria. The next thing is the external interfaces. So any connection details to integrate the developed system to external interfaces. So for example, you are developing an application, but does this application need to integrate with other application, or do you need to expose any of the APIs so that other systems can integrate with your system, right? So for example, nowadays a lot of applications are there, even all the cloud-based services. You can they provide a lot of APIs that you can consume, and you can integrate with those applications easily. So those sort of details need to be provided clearly in the acceptance criteria as well. Any external interfacing requirement need to be provided in the acceptance criteria as well. The next thing is any of the constraints. So any timeline or technology limitations. Say for example, you are using certain technology which has certain limitations, and the technology that you are using cannot be is not compatible with certain platform or certain other application. Those constraints need to be mentioned in the acceptance criteria as well. Also, if there are any timeline constraints, those need to be mentioned in the acceptance criteria as well. The next thing is the data definition. So you should be defining the format and the data type and the values that are allowed in that particular format. So for example, what values are allowed in the UIs. So do you allow integers in particular field, or you just allow the free text? So all these data format, the type allowed, and what are the values allowed, and what are valid and invalid inputs, etc., need to be defined clearly in the acceptance criteria. Say for example, you are submitting an application, whether first name and last name should allow special characters or not. All these definitions need to be defined in the acceptance criteria when you are defining the user story. Similarly, if you have a date field, what format should the end user provide the date in? Or if there are any interfacing requirement, what format should be provided in the date or in the first name, last name, etc. So these data definition, format, type, etc. should be clearly defined in the acceptance criteria as well. Then there is some other relevant information for testers that helps tester to actually test the user story and ensure that the acceptance criteria has been met. So the other information could be like how the system is supposed to work. So if you can, if there is a detail around that how part of the system or the how the system can be tested in a testing environment, that's another helpful information. So for example, there is something really new and tester is not aware of what details are required, but if the business analyst or other stakeholder or other team members are aware of that, they can provide their input, and that can be defined in the acceptance criteria or in the other information of the story, which will help the tester to test in a particular test environment. If there are any specific tools that could be used or skills and knowledge that could be required to perform the testing. So for example, this particular story is really technical and it's just there is a lot of service-based testing that needs to be done for this particular story before it can be integrated further. Then you can provide that the skill, that web service testing skill is required, web service automation skill is required to perform testing for this particular story. So these are some of the other information that is helpful for testers if it is defined in the acceptance criteria or other section of the user story. So to summarize, in this tutorial we have understood what are some of the key information that needs to be provided in the acceptance criteria of the user story to help testers to perform acceptance testing of the user story in any of the Agile project. Thank you. In this tutorial, we are going to learn about the definition of done at the test level. So in Agile project, you don't have any entry and exit criteria that we used to have in other sequential development methodologies like waterfall and V model, wherein we used to define entry criteria and exit criteria in each of the phases. So when we'll enter the next phase, or when we'll say we have completed this phase successfully and we'll exit this phase. However, in Agile, we don't have any of these entry and exit criteria. So we have definition of done that is defined at different levels, and that's which definition of done ensures or is the you can say it's sort of entry and exit criteria for each level in any of the Agile project. So it could be at the test level or story level or iteration level. So definition of done is the key criteria that is being being defined in Agile project to ensure that whether you have met that criteria, and you can say your story or your test levels are done or not. So in this tutorial, we'll see what key things can be defined as definition of done in your test level. So this is not a comprehensive list. Depending on what type of project you are working on, there could be more activity, or there could be more criteria defined in definition of done, or there could be even less criteria. So let's see what are some of the definition of done. So in the unit testing level, you could have criteria defined like 100% code coverage targeted. So at the unit testing level, you should be targeting 100% code coverage. Any unfeasible paths reviewed and signed off by the development lead. So that's another criteria. So unless until all these criteria will be ticked, you can't say that you have finished unit testing for the particular user story or the task. The third criteria could be all unit tests should pass. All unit test results should be reviewed. Unit tests should be automated, and there shouldn't be any major and critical outstanding defects, and this could be also agreed. So there will be some places wherein there shouldn't be any outstanding defect in that particular user story, or there shouldn't be any critical outstanding defect, but rest we can address later. So this definition of done is something which is discussed within the team, within the Agile team, and the whole team agrees on this definition of done for each level or each iteration. Then the static code analysis should be completed. So these are some of the criteria that could be defined as the definition of done for unit testing. Now let's see what could be some of the criteria for the integration testing. So in integration testing, you could say all functional test cases should be executed. All the interfaces between units should be tested. So at the integration level, you should ensure that all the integration points between the interfaces that you are testing are tested successfully. There shouldn't be any critical and major defects. This can again change as per the agreement within the team. And then if there are defects that are identified, then they are all reported in the defect tracking tool, and there should be automation. So all regression test cases are automated as per the agreed criteria, and all the quality risks are addressed. So these could be some of the criteria that can be defined at the integration level definition of done. Now at the system level, you can have that end-to-end testing of the user story has been completed. All the acceptance criteria defined for the user story has been met, and any of the non-functional quality characteristics are met. So for example, performance, reliability, etc., they should be met at system level. Any quality risks, if they are found, they are covered, and the regression test cases at the system level should be executed, and if there are new test cases identified, they should be added in the regression suite as required. Then all the regression test cases should be automated. This again is depending what agreement is within the team, but mostly all the regression test cases should be automated, whichever can be. And if there are some which are not feasible, you should be getting exemption for those test cases that can't be automated. Then there shouldn't be any outstanding critical or major defects within the system testing, and all the defects that are identified in the system testing phase should be reported in the defect tracking tool. So these are some of the key things that are mentioned in the definition of done at the test level. So you can add more criteria to this existing criteria. These are some of the generic criteria that are utilized across the Agile project, but they are always discussed within the team, and depending on the organization and the type of project you are working on, you can tweak these criteria as per the requirement and needs of the project. So say for example, you have some regulatory or compliance regulatory requirements as well, then in that case there will be more strict criteria defined at each of the test levels. So it is more of a collaborative effort within the team to come up and define this definition of done. Thank you. In this ISTQB Agile Tester Certification tutorial, we are going to talk about definition of done for user stories. So in previous tutorial, we have learned the definition of done for test levels. In this tutorial, we'll see what definition of done is at the user story level, or what are the criteria that you can define in definition of done for user stories. So please note that this list is not a comprehensive list of definition of done, and this list can change as per the needs and type of your project. So these are some of the generic criteria that are found in the user story definition of done. So before the user story is selected for iteration, it should meet the following criteria. So when we say definition of done for the user story, then the user story has to meet certain criteria before it can actually be picked in the iteration. So what are some of the criteria or definition of done criteria that can be defined at the user story level? So first thing could be user story is completely documented. So that's the first criteria before you can actually pick it up in your iteration. So when you pick a user story in the iteration, it has to be fully documented with all the acceptance criteria and all the scenarios as we discussed in the previous tutorial. So it has to be fully documented. The second thing is that it should be fully understood by the whole team. If there are any open questions or queries in the user story and that are not being understood by any of the member of the team or the team, then that user story should not be picked up in the iteration for development. That's the another criteria for the user story definition of done. Then the third thing is testable acceptance criteria defined in the user story. So user story should have testable acceptance criteria with all the functional aspects and non-functional aspects defined in the acceptance criteria. User story should be reviewed by the BA lead. So once the user story has been done, BA lead should review the user story and should give a sign off that it has been reviewed and there are no open and outstanding questions on the user story. Then the user story should be walked through within the team, and the team should understand and have all the queries answered before it can be said that the user story has met the definition of done. Then there should be no outstanding queries on user story. If there are any outstanding query, all those queries should be answered, or they could be waived off, or they should be signed off by the BA lead. Then all the subtasks and tasks for the story development should be created and estimated before you can actually pick the user story for iteration. So this definition of done at the user story level is basically saying that all these criteria should be met before a user story can be pulled into the iteration. Now there could be another definition of done defined at the user story level when this user story can actually be closed or be said done after the iteration or after the development work has happened. So there could be another criteria of definition of done defined for the user story as well. This is pre the iteration when you are picking the user story in the iteration, and there could be another definition of done defined for the same user story when it can exit the iteration or when it can be said as finished in terms of completion of the user story. So these are some of the criteria or the list that could be mentioned in the user story as definition of done. Now this list can increase or decrease depending on what type of project you're working on, and this is not a full list of definition of done. Thank you. Definition of done for features. So feature in agile development is something very high level work item which might have multiple epics below them, and then epic might have multiple user stories below a particular epic. So for example, you are building a web portal for any of your client and that portal has the login functionality. So that login functionality, when you talk about that, could be one of the feature of that particular portal, and then below the login functionality you will have the feature, you will have an epic login using Google account or Gmail account. Below that feature you can have login using your your Twitter login credentials or login using your Facebook login credentials. So these could be some of the epics below that particular login feature. Now below these epics, you can have multiple user stories to implement all this functionality for your user account or for the login functionality. When all these epics below this particular feature are done, then you say that that particular has been completed. So feature is very high level work item, and that might span multiple sprints, because in one particular sprint you might not be able to complete the whole work item for the feature. So let's see what can be definition of done for the feature. So as you can see, feature may span multiple stories and epics, and feature also spans across multiple iterations. Because of the size of the feature, it might span multiple iterations to implement the whole functionality that is defined within the feature. What are some of the items for definition of done to be considered in the feature? If there are multiple epics below the feature, then all those epics need to be completed for the feature. If there is just one epic and multiple user stories below that epic, then all the user stories in that epic need to be completed, and then epic need to be completed in order to say that the feature has been done. The second point is that feature design is complete and approved by the technical architect. So when you have that feature in place, or whatever you want to implement as a functionality for that feature, you need to ensure that the feature design or that login functionality that we are talking about has been designed and been approved by the architect. Then development is complete for all the stories in the feature. So below that feature, if you have multiple epics, those epics will have a lot of stories below that. Then you need to ensure that all the user stories have been completed below the epic which are under the feature. Then the testing, unit, integration, system and acceptance testing has been complete. There are no outstanding critical or major defects, and if there are any defects, then they are agreed by the stakeholders or by the team or relevant stakeholders, who need to sign off that yes, we are fine with these open defects and they are not critical ones, and we can go live with the existing functionality with those open defects. And then if there is any documentation work to be completed, then that needs to be ensured that it is being completed perfectly fine. So this is not a comprehensive list of items that you will consider when you are writing definition of done for features. You need to make sure that you discuss this definition of done with your team, with the stakeholders that are involved in the development effort of the feature, and ensure that this list is agreed by everyone when you are going to say that this is what a definition of done is for the features. Thank you. Definition of done for iterations. Iterations in agile software development are time-boxed cycle, which are also known as sprint in SCRUM. In these time-box iterations, you pick the user stories that you can develop as a development team and deliver a working software after the time box expires or end of the iteration. So let's see what are some of the definition of done criteria for iterations. Now, the first thing that you need to look at is all the user stories that you have added in the iteration are fully developed and tested, and it is good enough to be shipped as a product. So any stories that you pick in the iteration or sprint needs to be fully developed and tested and is good to be shipped as a product, or it's a working product. Then you shouldn't have any outstanding critical or major defects for any of the user stories that you have picked. If there are any non-critical open defects, then they should be approved by the stakeholders, that they'll be either deferred or put into the product backlog to be looked at the later iterations or cycles. Then if there are the testing for all the user stories should be complete. So all the user stories that you have picked for that iteration, which is usually 2 to 4 weeks of cycle, then the testing development effort for those all user stories that are picked within that iteration need to be complete. Then any relevant documentation for the user stories has to be completed, and because they are the deliverables for the user stories. So for example, you have picked a user story or an epic for which the design document is required, then you need to have a documentation for that. For the user stories, you need to have the test cases if they are required, they need to be documented and added into the execution cycle, and execution should be done in the tool. Then after the test execution, you should be able to produce the test report for the execution. So these are some of the documentation that might be required in the iteration, depending on what agreement and arrangement has been made within the development team in the agile software development methodology. Now please note that these criteria of definition of done for iteration are not the comprehensive list of definition of done. This can change. These are some of the key pointers that how you will be able to write the definition of done for iterations, or what definition of done is actually stands for. So it's sort of saying that you can correlate it with the exit criteria in other traditional software development methodologies like waterfall, that these are the key things that need to be completed before you can say that particular user story or the work item has been done in the iteration. So this list can be customized, there will be points that can be added or removed based on the discussion within the team. Thank you. For releases. So in agile software development, a release may span multiple iterations or sprints, and when you are defining the definition of done for releases, you should consider some of the following key criteria that we are going to discuss in this tutorial. Now, when you're talking about the release, so release will have multiple sprints in there. It might be approximately 6 sprints, so like 3 months cycle, and in those releases you release the software to the production. When you talk about agile software development, you can also release very frequently. So it depends what frequency your organization is following, and releases might be even 1 month. You can go in production for 1 month, and based on what frequency is being defined, you can define what needs to go into the release and what all definition of done criteria you need to consider for those releases. And since release span multiple iterations, so that means there might be multiple features and epics that will be delivered as part of the release. Now, what are the key criteria that you need to consider when you're talking about definition of done for the releases? The first thing is that all code for release should be complete. So when you are saying that this is the release I'm looking for, and this is a monthly release, and in a monthly release, what all features or what all epics I'm going to deliver in that particular release. So all the coding for the user stories below that particular release need to be completed, and then all the unit, functional, system and non-functional testing should also be completed. So not only just functional but non-functional aspects of the release or the items that are added in the release should be completed as well. Then all the quality criteria should be met, and adequate testing should be performed for the items that are added in the release. So it should be functional, unit level testing, any performance testing and non-functional testing should also be done and completed as per the risk analysis done for that particular release. Then all the acceptance criteria that are mentioned in the user stories for that particular release need to be met. So that again comes down to the user stories acceptance criteria. You won't be able to move, or you shouldn't be moving a user story as done unless or until the user story meets the definition of done. So in terms of releases, it comes down to saying that all the user stories that you have added in the release should meet their acceptance criteria, or the acceptance criteria defined within the user story and the acceptance criteria defined for the release. Then you shouldn't have any outstanding critical and major issues. So if there are any critical and major issues, that means that your software is not developed with the quality, and you shouldn't be going into production with the known issues that might impact the credibility of the organization. Then you should have sign-off received from all the involved teams, development, product owner and QA. The sign-off should be there, and all the documentation, whatever is required for that particular release, should be also completed. So these are some of the key criteria that you need to include in your definition of done for releases. Again, this is not a comprehensive list. This can change as per the discussion within your team and stakeholders, and what key criteria they need to include as part of the definition of done for releases will impact this list. Thank you. Applying acceptance test driven development. Now let's see what acceptance test driven development is and how you can use it, or how you can apply acceptance test driven development in the agile software development approach. Now acceptance test driven development is the test first approach. So it's similar to test driven development and it's based on test driven development. The difference is that in test driven development, users or developers develop the test case. It's more of a developer focused test driven development, whereas acceptance test driven development is more of a business focus. So when you are writing test cases in acceptance test driven development approach, you will be more focused on the business processes and how the end user will interact with the system, rather than the developer coming up with the test cases based on his understanding of the requirement. Now, acceptance test driven development approach has 4 key steps. The first step is to discuss, second one is to distill, then develop and demo. So these are the key steps in acceptance test driven development's life cycle, wherein you first discuss within the team, then you distill what are the criteria, then develop and demo. So let's see what are these 4 approaches and what all steps or key work items are involved in these 4 steps. So let's go ahead and see what is involved in the discuss approach. So in the discuss step, this is the first step of the workshop, and in the discuss step you discuss the user story or the work item that needs to be done with the whole team. So it's analyzed, it's discussed, and within the developer, tester and business stakeholders to come up with any ambiguities or any incompleteness or errors in the user stories. And then once everyone in the team is happy and all the open questions have been identified in the discussion and addressed, the next phase of that user story is to distill that user story. And when the discussion is finalized and user story is finalized, the next step is to distill that user story. In distill step, it can be done by the tester only. Like in first step, you have the development team, you have business stakeholders involved. However, in the next step, which is the distill step, there could be the development team involved or only testing team doing the distill work of the user story that has been discussed and finalized in the step 1. What is done in the distill step? Tester writes the scenarios or the test cases or acceptance tests based on the acceptance criteria defined in the user story. So he has been involved in the discussion step already. He knows what all acceptance criteria have been defined for that particular user story. So based on those acceptance criteria, he'll come up with the acceptance test scenarios in the distill step, and those acceptance test case scenarios are then documented by the tester, or there might be possibility that even more people or even the developer is also involved in the distill step, just to get a more perspective of different people within the team. Once these test cases are defined, then the next step is to come up with the negative scenarios as well. So the first step in distill phase is to come up with the all positive scenarios or all the positive conditions that confirm the acceptance criteria defined in the user story. The next step is to also come up with the scenarios or the negative scenarios that might be required to be addressed for that particular story. Apart from negative scenarios, you also need to come up with the functional, security and any other different non-functional attributes of that particular user story. So that's all what happens in the distill step. Once all the positive scenarios, negative scenarios or non-functional aspects are being defined in terms of acceptance test cases, then the third phase is the development phase. So now you have the set of complete user story which has been discussed in first step. Any ambiguities has been addressed. Next step has been completed, which is the distill step, when the tester has documented all the acceptance test cases. The third step is to start developing the user story, or to do the actual coding, wherein now the developer starts writing the code in similar to test driven development, but however he just refers to the acceptance test cases written in the step 2, which is the distill step, to meet the acceptance criteria or the test cases that have been documented in the step 2. Now once the coding has been done and all the acceptance test cases that have been defined in step 2 are fulfilled, then the next step is step 4, which is demo the product, right? So whatever has been developed, it is packaged, built by the developer and deployed on a test server, and then that working software or working piece of code is demonstrated or showcased to the relevant stakeholders. So there'll be business people involved, there'll be the whole development team involved, to see what has been actually built and whether there are some more improvements or more inputs required, or whatever has been built meets the criteria that was defined in the discuss phase. So these are 4 key steps in acceptance test driven development lifecycle. Thank you. Testable and non-testable acceptance criteria. So in this ISTQB Agile Tester Certification tutorial, we are going to learn what is acceptance criteria and how you can define testable acceptance criteria. The other thing we are going to discuss is how you can differentiate between testable and non-testable acceptance criteria, so that you can come up with the testable acceptance criteria, or you can provide input to the person or the business analyst who has written the story to ensure that there is an acceptance criteria in the user story that is testable. Now, if we go by definitions of acceptance criteria, so acceptance criteria are the set of statements, each with the clear pass-fail result. So when you get a user story from your business analyst, he documents the requirements that are in form of user story, and the requirements come from the discussion from the stakeholder or the business people to understand what exactly they are looking for to build. Now business analyst then articulates those requirements in form of user stories, and he provides or he writes the acceptance criteria into clear pass-fail results. So he'll mention what actions need to be performed by the user when that user story is built as a working software, and if those actions are performed, then whether they should pass or fail. So for example, say let's take an example of a login functionality. When you are building a login functionality using Google credentials, say you are using your Google credentials to log into the admin portal, if that is the functionality that has been built by the development team and you're testing that functionality, what will be the clear pass fail criteria for that? So the pass criteria, acceptance criteria, could be when I use my valid Google username and password to register myself or to log in myself on that admin portal, I should be able to log in successfully. The other acceptance criteria should be clearly indicating when this login should fail. So if I'm using invalid username and password, then the login should fail. So this is a brief example of how the acceptance criteria might be written in that particular user story. Now if we go by the definitions of Microsoft and Google of acceptance criteria, Microsoft defines acceptance criteria as the conditions that a software product must satisfy to be accepted by a user, customer, or other stakeholder. So it's pretty simple. The conditions that need to be defined in the software or in the user story, when that user story is built and working software is available, then whether those conditions are met for the user, customer, or stakeholder or not. So that's the simple definition that Microsoft defines. Google defines acceptance criteria as pre-established standards or requirements a product or project must meet. So it's a pre-established standard. So when you are building a user story, when you are defining a user story, what are the pre-established standards that you are looking for to build in that user user story, whether you are looking for a valid login using your Google username and password. That's one of the criteria. Invalid username and password should fail. So these are some of the predefined or pre-established standards that you're defining in your user story as an acceptance criteria. Now, the other thing to note is there is no partial acceptance criteria. It is either met or it is either not met. So whatever criteria are being defined in the user story, unless and until all of them are met, you can't say that acceptance criteria has been met. So everything that is defined or pre-established standard has to be met completely. Only then you can say acceptance criteria has been met. Now let's go ahead and see what are testable and non-testable acceptance criteria. When an acceptance criteria is being defined by the business analyst as an agile tester or as a tester in an agile project, your responsibility is to go through the acceptance criteria, go through the user story, get involved in the discussion, and ensure that all the acceptance criteria and the details mentioned in the user story are testable. And if they are not, you need to ask questions to clarify the details so that any non-testable acceptance criteria becomes testable acceptance criteria. Let's see some of the examples of testable and non-testable acceptance criteria and how you can identify what is testable and what is not testable. So if you can see on the in the table on this page, you can see testable criteria is login page should load in less than 2 seconds, right? So here it is clearly indicated when you're launching a login page, then it should load in less than 2 seconds. So there is a time limit mentioned as a criteria that gives you a clear indication what time or within what time the login page should appear for the user. Now, if there is an acceptance criteria defined something like login page should load quickly, so you don't know with this word quickly, you don't know whether it's 2 seconds, whether it's 5 seconds, 10 seconds. What does quickly mean when the business analyst has defined this acceptance criteria as login page should load quickly? So if this is something that you notice in the user story, you raise a question, what exactly you mean by quickly, whether it's 2 seconds, 5 seconds, 10 seconds, and then these discussions clarify what exactly is required to change this non-testable acceptance criteria to a testable one, so that you can actually go ahead and see what is the performance based on the baseline or the acceptance criteria mentioned. The other criteria is system should be available 24/5. So system should not go down 24/5. So Monday to Friday, 24 hours system should be up and running. The other criteria which is non-testable for the same requirement could be system should be available always. So always could be 365/7, right? So 365 24/7. So it's like all the year round the system should be available. But if the business requires the system to be available only 24/5 or Monday to Friday 24 hours, then you have to get it clarified. So anywhere that you see always, quickly, or anything that is not well defined in terms of performance or that cannot be tested, then you raise a question and clarify that. The other criteria is a person with doctor role can access patient file, right? So here we are talking about the role that yes, which role should be able to access patient file. Now the similar criteria could be mentioned like user should be able to access patient file. So in this criteria, when it says user should be able to access patient file, it's not clear which user they are talking about, or which user is defined in the acceptance criteria of the user story. So it has to be clearly defined role when there is a functionality to access patient file, that which user should be allowed to access patient file and which user should not be allowed to access the patient file. So there shouldn't be any ambiguity in defining the acceptance criteria, and if there is any, then you need to clarify with the business analyst and stakeholders to come up with the clear testable acceptance criteria. So with these examples, I hope that you are clear with the testable and non-testable acceptance criteria. Thank you. Functional and non-functional black box test design. Black box testing is behavior based. What this means is the system is tested to ensure that outside of the system boundary, it delivers the required behavior. Now, you do not interact with the actual code, how the code is being executed. in the black box testing. So you are looking at the system as just a black box, and you are not worried about how the code or the methods are being written and the communication or integration happens between the parts of that particular system. So you are testing the system as a whole as a black box. You provide the input and you verify the output. If the output meets the expectations, then your test is passed. Now, these black box test design techniques that we learned in ISTQB Foundation Level Syllabus, or if you have been working in testing already, you would know there are a lot of black box test design techniques that are available. So all these techniques, so for example, equivalence class partitioning, boundary value analysis, decision tables, state transition test design, all these test design techniques are still valid in agile development approaches. You need to apply all these test design techniques to test the user stories that you are getting into the sprints. Now, using these techniques, you can write your positive test cases, negative test cases, experience-based testing, which is very popular in agile development approaches, and exploratory testing is also very important and in agile development approaches. So using these test design techniques, you can do all these types of testing along with non-functional testing as well, to ensure that the quality that you are delivering at the end of the sprint is good enough and meets the expectations of the end user and stakeholders. Thank you. Exploratory testing and agile testing. Now, in any agile project, exploratory testing is very important, and let's see what exactly an exploratory testing is and how you can perform exploratory testing in agile project. So exploratory testing is about learning the system as you design and test it. So you do not do the preparatory work before you actually start testing. When you are doing exploratory testing, you actually learn about the system and design your test cases as you learn about the system. Then test design and execution occur at the same time. So there is no preparatory work upfront in exploratory testing. You do not design your test cases before you execute it. You do the design and execution at the same time. It is guided by test charter. So I'll explain what test charter is in the next slide. But test charter is the key thing that guides the exploratory testing. Test charter provides the test condition to cover during time box testing. So there is a time box testing when you are doing exploratory testing, and test charter provides the test condition that need to be covered during that time box iteration. Then most recent test results guide the next step. So when you are doing testing in exploratory format, then whatever most recent result you are getting, you decide your next step based on that particular situation or result that you are at that particular moment. Then testers in exploratory testing use both white box and black box test design techniques. So it's not just black box, it's basically combination of white box and black box test design technique. Now, what is test charter and what information needs to be included in test charter? So test charter is nothing but a document which includes the following information that we are going to discuss now. So test charter contains the information about the actor. So who is going to be using the system, who is going to use the system. So for example, you have a login portal or you have an administration portal or any online portal that you have worked on, and that online portal supports different users to log in. It could be end user or any public user can register and access the portal, or the same portal can be accessed by the company employees, test managers, and other roles that are present in the company. So you define who is going to use the system, whether it's the end user or it's the manager or it's a team lead. So that is the information that needs to go into the actor section of the test charter. Then the second thing in test charter is the purpose. What test conditions or objectives you are trying to cover when you are going to test the system. That's the purpose. The third step is the setup. What preconditions or setup is required before you start the test. So for example, your test environment should be ready with certain level of configuration, software, hardware, and the application in certain state before you can actually start your testing. So that all information goes into the setup section. Then you have the priority, which is basically the importance of the charter. So for example, you're writing a charter and that charter will belong to certain number of user stories or certain feature, right? So it could be just one user story or a particular feature or an epic. Now, based on the importance of that particular feature or epic or user story, your importance of the charter is also defined. So what is the priority of this charter depends what is the priority of the user story or the feature for which you are trying to write this test charter. The next thing is the reference. So you provide the reference to the user stories, the related user stories and risks for which you are writing this charter. The next section is the test data or data. Test data is required to carry out testing. So what all test data you need to carry out the particular scenarios or the testing that you are planning in the test charter. The next thing is the activities. So what all activities or possible scenarios you're trying to perform, and Oracle note. So how you are going to evaluate the product, whether it meets the expected result. That goes into Oracle notes, and the variations. So any variations or alternative actions that you want to perform, which are going to complement the activities that are described in the activity section of this charter. So these are some of the key information that goes into the test charter, which guides the exploratory testing sessions. Now, what are the heuristics which can be applied when you are doing exploratory testing? So heuristics are nothing but rule of thumb that you can apply when you are doing exploratory testing. So first thing is the crude application. So you can apply create, read, update, delete. So these are the functionalities that you can apply when you are doing the exploratory testing, or you can use follow the data. So for example, whatever actions you enter, search, report. So for example, you are searching for certain issues in the portal, then you just follow whether there is an option to export these issues or whether it allows you to print these issues. If there are options, you just follow the actions accordingly. Then you try different configuration variations. If there are configuration changes that are allowed in the system, try doing that. Then are there any constraints in the system? Then for example, you are doing certain operations. So for example, you are filling up the form and then you try to close that particular window. What is the response of the system in that scenario? Or if there are mandatory field and you do not fill and try to proceed, how the system behaves. Now the next thing is the interruptions. So if you're doing something and you try to interrupt, for example, you are midway through logging the form and then you try to log off, what is the behavior of the system? Then you can also use multi-user. So multi-user logins, multi-user trying to log in the system, how the system will behave. Now, what is the useful information that needs to be documented? So whenever you are doing exploratory testing, you need to document the information of the finding that you are getting when you are doing the testing. So for example, the test coverage, how much test coverage has been done for that particular user story based on the user stories that you have covered. Then what are your evaluation notes? So what are the findings and observations? What are the risks and strategy that have been covered? So based on the user stories covered, how many high priority user stories or the high risk user stories have been covered? So you document that information. Then if there are any issues or doubts or any findings, for example defect, you document that as well. And actual behavior, what is the actual behavior that you have found? So you just either take the screenshot or take a short video of the recording. Then the next important thing is to manage the exploratory testing. So how are you going to manage the exploratory testing? So exploratory testing is a session-based, can be managed using session-based test management technique, wherein you can have sessions, uninterrupted sessions of 30, 60, 120 minutes, time box minutes, and these sessions will basically be utilized for doing the exploratory testing. So test sessions include the following: so survey session, analysis, and deep coverage. So survey session is nothing but initial exploratory session with the system to learn how the system works. Then the next session you can schedule will be time boxed again for the analysis, which will evaluate the functionality and characteristics of the application. And then the third session you could utilize for the more negative and edge case scenario. So when you do this sort of session based test management technique, then you have very streamlined session identified for what should be the focus area in each of those sessions. So the next thing is what other testing techniques you should be using along with the exploratory testing. So in agile development methodologies, it's not just that exploratory testing is good enough to do the testing. It's just an add-on and an extra benefit that will provide good quality or better user experience when added on top of the other testing techniques, for example, analytical strategy or model-based strategy, regression averse, process and standard compliant, and consultative strategy. So all these strategies along with exploratory testing is very important. So let's see what all these strategies are. So analytical strategy is something, for example, risk-based strategy or requirement-based testing, which you will anyways do when you are doing your iteration. So you'll get a user story, that sort of requirement for you, and then you will identify the test scenarios and test cases to test for those requirements. So that is analytical strategy. So you'll do that in the sprints. Then you can also have the model-based test strategy, wherein the team will build a model based on the actual or anticipated situation of the environment, and then test the system accordingly. Then regression averse strategy. So regression strategy is mostly automated, and you try to execute any of the regression scenarios that has been identified in the current iteration or in the previous iteration. Then there could be also process or standard compliance. So if there is a software that you are testing needs to comply with the standards or the process, then you follow the standard compliance or the process compliance strategy to ensure that those scenarios are being covered. The next strategy you need to use is the consultative strategy. You need to consult the subject matter experts and the business people or the key stakeholder who are knowledgeable in that particular area, and ensure that the scenarios that are identified by them or the edge case scenarios are covered as part of the consultative strategy. So all these testing techniques and strategies are important along with the exploratory testing technique that we have discussed in this tutorial. Thank you. Tools in Agile Projects. So in this tutorial, we will learn about what are the important tools that are used in any of the Agile development projects. So in ISTQB Agile Tester Certification exam, you might be asked about the key tools that are being utilized in the Agile software development methodologies. So let's see what are the key tools that are being utilized. So the tool categories that you need to be aware of is the task management and tracking tools. So there are certain categories of tools that are utilized in any of the projects. So you have task management and tracking tool, communication and information sharing tools, software build and distribution tool, configuration management tool, test design, implementation and execution, and cloud computing and virtualization tool. So many of these tools were traditionally used as well in traditional development methodologies as well, like waterfall and V model. But there are some tools which are a bit different. For example, the task management and tracking tool in Agile is a bit different as compared to it was in the traditional development methodologies. And similarly, communication and information sharing tools are a bit different. So let's see what all tools are utilized in Agile software development. So the first category is task management and tracking tools. So task management tools are the tools that record the stories or your task or subtask for the development. Jira is very popular software. So Atlassian Jira software is very popular nowadays and used at most of the places in Agile software development. Apart from Jira, there is Trello, Pivotal Tracker, Asana, and Rike as well, these tools also provide similar functionality as Jira. There are a bit of differences, and there'll be some differences in the customization, but yeah, Jira is the most popular and powerful tool nowadays for Agile task management and user story management. Then you what task management tools do is they record the effort estimations for the story. So you can record the efforts, how much time you are going to take or how much story points you are going to take to complete the story. You can track the story or task progress. So in Jira you can create your own workflow as per the need, and you have ability to create Kanban and SCRUM board wherein you can track the story progress within the sprint or the workflow. Then you have the visual representation of the current state of the story and task, so it clearly gives you the indication where that particular user story is. It will also provide you the functionality to about the sprint and report progress. So you have Burndown charts available which you can utilize to see the progress of the sprint or release. These tools also provide the dashboard to include progress of the iteration or release, which is the Burndown chart. So you can have epic Burndown or story Burndown or the iteration Burndown chart. Then there is integration with configuration management tool and release tool also possible with these tools. So these are some of the task management tool functionality and some of the software tools that are available for the task management in Agile software development. The next set of tool is the communication and information sharing tool. So these tools are utilized to make the online knowledge base for different project information. So wiki is one of them, and then so information sharing tool is basically to share the information that you have gained as a team member with other team members. So some of the tools that you can utilize is either wiki or Confluence. Confluence is also from Atlassian and very popular tool nowadays. So you can document all your information in the project in Confluence, and that can be easily shared and accessed by the other team members. Then you have other communication software for which you can do instant messaging, video conferencing, etc. So for that you can use Skype or Atlassian HipChat to do the communication and desktop sharing. So these are important tools because nowadays you have remote teams working at different locations. So having wiki or Confluence for information sharing and communication tools is very important to make the progress within the team. The next set of tool is software build and distribution tools. So software build tools are the tools which actually build and package the software, right? So whenever the developer writes the code, then he checks in the code into the version control system, and these build tools fetch the code that has been written, they build it and package it, and then they can deploy it. So these are the software build and distribution tools. So daily builds and deployments are very important in Agile because there is a daily work or development that happens in Agile, and because of that you need to have automated tools to build the software on daily basis to ensure that nothing is broken from the last build. And because of that these build tools are very important, and they as and when the developer checks in the code, they do the build and run the set of automated test case to ensure that nothing is broken in the build. Some of the tools used for the software build and distribution are Bamboo, Jenkins. Jenkins is very famous. Gradle, Ant is another build tool, and TeamCity. Right. So these tools are very helpful for continuous integration and continuous delivery of the software. Then the next set of tool is the configuration management tool. So configuration management tool are the tools that are used to track the configuration or track the versions of the important products. So these are required to store and track changes to all the important work products. It includes your documentation, it could be your documentation, could be your code, etc. And this allows traceability, and it stores all the historical information in your code and the document. So for code you have very popular tool Git is available, and then you have TFS and Ansible as well. So these are some of the configuration management tools available. Then the next set of tools is the test design, implementation and execution tools. So these are the tools that you will use frequently in Agile development project for your test designing, implementation and execution. So these are some of the manual tools for test design and some of the automation tools. So In testing, you have test design, management, data preparation and generation tools, test data load tools to expedite the data load, and automated test execution and exploratory test tools. So some of the test tools, for example, Tricentis Q-Test is used for the test management, wherein you can design and store your test cases. And then you have test data preparation and generation tool, which you can use data dynamic and other tools around that. Then there are data load tools as well. So data preparation and load, so it will prepare the data that you need for doing the test execution, and can load the test data in the test environment as well. You have automation tools, very popular, like Selenium, SOAP UI for the API testing, and Tricentis Tosca. Catalan is another important open source automation tool available. And then you have exploratory test tools as well, for which you can utilize some of the other tools. Then the next set of tools is the cloud computing and virtualization tools. So cloud computing is and virtualization tools are important to utilize the capability of the hardware and software available on the cloud. So for example, Amazon Web Services or Google Cloud. So what you can do is you can spin your own machine on Amazon Web Service or Google Cloud, and then utilize the capability of virtualization to use that for your test execution or any other needs. So rather than having all the hardware and software for the machines in your company's data center, you can utilize the cloud computing services, and you can also use the virtualization from VMware, so wherein you can have a big server, and that you can distribute, or you can virtualize it into smaller different machines with different configurations, so that you can have a different set of combinations with combinations of virtual machine that you can use for testing. You can have Linux, a machine with Linux operating system, a machine with Windows, different flavors of Windows operating system, Solaris operating system, and that is all possible with the virtualization tool. If you do not have the data center at your location or in your project, you can still utilize the cloud computing or virtualization provided by Amazon Web Services and Google Cloud. So these are some of the cloud computing and virtualization tools that you will come across while working in the Agile development projects. Thank you. Congratulations on finishing ISTQB Agile Tester Certification course. Let's see what all you have learned in this course. So just to rephrase, we have learned about Agile software development fundamentals. We have learned about Agile approaches, differences in Agile versus traditional development approaches. And then we learn about status of testing in Agile projects, how you can manage risks in Agile projects, what are the testers' role in Agile projects, and some of the Agile testing methods. Then we learn about assessing the quality risks and estimating the test effort. So what are different options to estimate in the Agile projects. Then we also learn about the techniques in Agile projects and the tools used in Agile projects. So we have learned all these topics, which are all included in the ISTQB Agile Certification syllabus in detail. So congratulations on finishing all of the topics, and good luck for your exams. Thank you.